examples. There are radar, and the camera, and the ultrasonic. So today I'll briefly, I'll focus on the radar to radar interference. So that, I described that the reflection surface on glass or mirror or guardrail will give you some interference. So also there are environmental interference. So the LiDAR case, so airborne particles, the fog, heavy dust, snowflakes, something like that. So now I'll give you a few examples how those interference will impact on the real situations. There are many accidents in the AV cars. So for example, Tesla case, it happens 2016 in Florida. So that time they used the camera and the radar. So that gives, but the sensor missed the detection. The bright sun glare and the low contrast gives missing the obstacles. Then car hit the obstacles. So actually, this time it was a truck. So that the white trailer and the bright sky, okay, they degrade the data. Also, the Uber case is 2018 in Arizona. They used the LiDAR and the camera and the radar. So, but this case, in the night, the low light and the dark closing, and then they hit the bicycle over there. Okay, so the LiDAR return signal is very weak, and the surface reflection gives you some malfunctions. Also, this one is that Waymo case. So the car hit the wall. So they use the radar and the camera and the radar. So that gives, this case gives the phantom obstacles. So you can, maybe you cannot see here, so this time it's very heavy snow, it's heavy rain. So later they analyzed the point cloud data, then due to the very heavy rain, they cannot recognize the wall. So then the car hit the wall. So this is for the Baidu Apollo. So at the time, there are very big dips in the very big pit in the road, but the car cannot detect the pit and then fall down to the road, the pit. So another one is a Xiaomi case. So this happens at 2025. They use the camera, LiDAR, and the radar. But still, this case is unknown why it happens. But the car is damaged very severely, and at that time, the people cannot open the car door, and the 3 students died. So this is a summary of the accident. So based on the sensors, the LiDAR, and the radar, camera, GNS, and then sensor fusion case. It depends on the situations. So you have very severe situations. So some cases people died, and then so the failure mode is maybe most important. So that the LiDAR case, the very small return from the environment. So because of the fog, rain, and absorptions, so the sensor cannot recognize the pupils or the obstacles. Okay. So based on those informations or the accident, so we learned that the accident mainly happens due to the perception ambiguities. It's not due to the sensor blindness. So sensor can give some data, but based on that data, so we cannot perceive what is the environment. So car or bicycle or the pedestrians. So then also the interference is structured. So it's correlated, means that all the sensors gives the wrong information at the same time. Also that some cases the uncertainty propagate. So that's the key issues we need to solve. Okay, I'll move fastly because of time. So then this is some statistics for the accidents in AV. So as the time goes on, the accidents increase almost exponentially. That is because of we have many AV cars. So, but most accidents is that very the minor accidents. So over there is about 90% of the accident is very minor. But until 2025, the only 65 people died. So then I have to compare these accidents with the human drive. So this is from the Statistica. So then the red is the autonomous driving, and then the black is the people, the human driving. But if you look at this, so you should say why we're doing this. Because of the autonomous driving, it looks very high accident rate. But this case, the autonomous driving includes every accident. But human driving only includes the reported by police. Okay, that's why we have very big difference. But if we believe that the data from the Waymo, so the situation is very different. So that Waymo reports says that the injury rate reduced by 91%, and the collision severity also 85%. So also the intersection safety improved by 96%. Also the police report crash reduced by 57%. So you can compare these two directly, then maybe depends on whether we believe this data truly, then maybe the autonomous driving will help. So this is like the ChatGPT generated scenario. So what will happen in we do not solve the interference problems? So if we have a program lane like this, so urban canyon case looks like this. This looks like a chaos. Okay, so that's why the people are looking for the solution for interference. Okay, so I will give you briefly mitigation scenario. This is too busy, but I'll focus only on the LiDAR case. So there are few scenarios, but I'll give you some brief experimental result about the random modulate CW LiDAR, so how it overcome the interference. So this is a very simple configuration. So we have a true random signal and optical modulator, so that the coherent light was modulated by optical modulator. But in this case, we are not using the well-known signal. We use the very true random signals. Then the scanning optics can do the scanning for the 3D image. So then we need to have coherent detection. Then we are detecting the correlation between the original data and then the returned data. So then the signal processing for the perceptions. So the experimental setup is almost same as the FMCW case, but we just change the true random signal from the CW the signals. So then this is very simple demonstrations. We have walls and the two LiDARs, and then try to how interference happens. So if we use the conventional LiDARs, so these are two walls, and then the LiDAR, then we have interference signal. But if we use the proposed system, we completely eliminate the LiDAR, the interference. This is due to that correlation detection. So if the interferer, the signal is not totally correlate the original LiDAR signal, you cannot see interference. But since we are using true random signals, so interference signal has no correlation between our signals. That's why we completely eliminate the interference. So we also test the 4 different LiDARs. So the RM case is our case, and the CW is that we are injecting just the CW, and then we use the FMCW LiDAR, also the pulsed TOF LiDAR. 4 cases, we can see this is the interference power versus SNR degradation. So the 4 different cases, regardless of the types of LiDAR, the proposed LiDAR works very well for mitigation of the interference. So this is very brief demonstration, but so once again, I come back to the sensors, the 3 different sensors. So then if you compare the 3 different sensors, so for the daytime with the bright light, all the sensors work very well. But in the nighttime, the camera is not working unless you use the IR cameras. But IR camera is very expensive. So, but the heavy rain and fog case, camera is not working. But LiDAR may be okay, but the radar is not working. LiDAR, no, sorry. The LiDAR is not working, but radar is okay at the case. Because of the radar use the long wavelengths compared to the light, it is very insensitive to the rain and the fog. So the object classification case, camera is best. So the precision distance measurement case, the radar is best. So velocity measurement, radar is best. So if you look at that, once again, no single sensor can meet all the conditions. So that means that only our solution is the sensor fusion. Okay. So because of the time limit, and I am not the guy for the sensor fusion, even though one of the solutions I didn't touch the sensor fusions. In summary, so autonomous driving is in our real situations. Okay? So the machine are making a decision based on the perceived environment from the various sensors. But the key enablers for this is that the computing, artificial intelligence, and the sensor, also the energy source, efficient batteries. So, but the problem is that the safety and the security are greatly affected by the perception degradation due to the interference between sensors and the interference between sensors and the adverse weather conditions, also some security attacks. So conclusion is simple. So we have to solve computing and artificial intelligence and the sensor layer technology all together to resolve these interference problems. So if we solve all the problems, maybe we can have, oops, what's going on? Oops. don't know. Okay, anyway, these are two photographs. So one is that I took last Monday, and I sightseeing this place. So I saw that very many motorcycles and cars, and they are, some I can say, they are mixed together. So it's very hard to see, hard to understand how I can go ahead, how I can drive here. But once those problems are solved, maybe we can get very nice situations. So, okay, there you can see the motorcycles and the cars there, so they can go very smoothly. Oh. So these are current situations. So I took this photo last Monday. Then hopefully we can modify this like this based on the technologies. So hope, and then mostly the young guys, the young people, the students. So you have to do this. Okay, thank you. Thank you for your attention.
Thank you, Professor. If you have any queries,
thank you, Professor E. 안녕하세요. My name is CF Kwong. I'm from the University of Nottingham. Just one question. By the way, thank you for the very insightful information and the talk. The question is, if all the cars are interconnected to the ITS, Intelligent Transportation System, in the future, how much is the reliability will increase? Thank you.
I think you are not expecting correct answers. Actually, I don't know. So I did not touch the interconnectivity in this biograph, but so that as I told you that the car is the network node. That means every car should interconnect together and communicate together. But if only there is isolated car, so it's very hard to make a correct decision because of all the sensitive information is not fully reliable and fully acceptable. So we need the interconnection between the cars. So that brings many other issues of the attack and also the securities, so also the interference. So even we do that, I'm not sure how much reliability we can improve. But the one thing is sure that reliability will improve greatly, but I don't know how much.
Thank you, Professor. It was wonderful, insightful presentation. You talk about like sensors, brain, and the controls of autonomous vehicle. So basically, that's targeted for protecting the car, right? So the driving is a social thing. It's not just physical, right? So you need to have consideration of the environment which you are driving, right? You also mentioned many of the things, the pedestrian secure safety or other examples, right? You also like shown the image of Nepal traffic, right? That is mixed, right? And we can see very uncertainties in the roadsides, right? In which the human makes some decision based on some uncertainties, right? So there is a heterogeneity, the mixed traffic, and the heterogeneity in standard, heterogeneity in protocols, right? Because there is autonomous vehicle, there is like some other vehicles, there is some public vehicles as well, mass transportation system, and some light, small vehicles, pedestrians, right? So we need to consider all these environment, right? So basically what I am seeing historically is the companies, they are trying to build up some safer car, right? What do you think? This is just a concern, it may not be the question, right? So how we can make the environment safer? Okay, what technologies should be prioritized to make the safer environment for the autonomous vehicle instead of just making the vehicle, autonomous vehicle safe? This is, okay, thank you.
So once again, I don't know answers. But based on my background, so and also the history, recently I saw that one articles from, I forgot the name, but in China they used the train without rail. So I was very amazed for that. They developed the infrastructure based on the old idea in 1950s. So they are making the infrastructure, and then they put the autonomy in the train. So maybe that can be one solution in limited areas, because of we are using all the very, very correct road information, and we can put autonomy into the moving vehicles. So that can be some solutions in very limited areas, but areas like here, so we have more than motorcycle than cars. So this case, I realized that it will be very, very difficult. That's why intentionally I bring this photo. So it was very, how can I say, for me, it is a very strange situation. So even although my experience in the roads, I saw only car mainly, no motorcycles, very few motorcycles. So that's why I mostly ignore the motorcycles during my, how can I say, when I think about the problems and the solutions. But here, the situation totally changed. So it will be very difficult. Because of the motorcycles, so inside the motorcycles, there will be very limited computing power. Also, the sensor is very hard to install in the motorcycle.
Yeah.
So we have to give another domain to the motorcycles. So we have to think about that. So that may be the good research topic in here, not
Thank
the
you.
other places.
Thank you, Professor. One question. Thank you, sir. So I think we are talking about the motorcycles in our country, but there are lots of medical ambulances and all these things flying through the roads. So apart from the optical sensors, are you covering the sound or kind of ambulances type of signals in the detection through this car? Excuse me, I took a last one question and then.
So you mean the emergency car? Ooh. So there are some research articles on how to handle the emergency cases. If you look at the computers or the algorithms, we have the interrupt. Just like the cases, so we have to handle every all the cases with the first priority for the emergency cases. But so at that case, maybe ITS. So if all the cars are interconnected, so it may help the problem. But without connection between the cars, maybe it's not easy. But yeah. Also, I don't have a clear answer for that. Okay, thank you for attention. So
last one question and then finish.
Okay, I have one question. You have mentioned that you are going to use deep learning, advanced AI in your autonomous vehicle. But in autonomous vehicle, you are going to make real-time embedded system, right? So how you are going to incorporate such a high advanced algorithm in low bit embedded system? One question is then one. Another is, have you considered of latency between B2B communication in this one? Thank you.
I think two questions are related. So maybe two questions depends on the computing power. So that's why I give you three different layers. So the sensing layers, and the computing layers, and AI layers. So those computing layer and the AI layer should work together for better algorithm, for better deep learning or the processing method. So at this moment, maybe we don't have clear solutions, but currently we have the custom designed deep learning chips and also system on chips. Those two cases maybe solve those part of the problem, but actually it is not easy to have real-time all the decision and the actions. So it's maybe our open questions. We have to work very hard to solve the problems.
Thank you. Thank you, sir. Very insightful keynote speaker, Chang Healy. Big round of applause for him. I'd like to request Professor Timilayami, madam, to hand over the token of love to the keynote speaker, Chang Healy. Please, ma'am. Thank you, Professor, and all the attendees. We will come back after 10 minutes short break, and the next session will be started 11:05 a.m. Thank you.
I'll be using this.
Yeah, okay, yeah,
And I
enough.
just put it
If
this.
you need this, you can just long press this to turn it off.
Excellent. Okay, thank
Should
you.
I push it inside?
No, no, it's okay.
You'll fall down. Just be careful.
No, I think this one is okay.
Okay.
Yeah, excellent.
किया चढौँ खिच एउटा आज खिच्ने हो என்னாச்சு பிரீத்தி வரலையா എടുത്തില്ല മാം ആ വരെ அவங்க എടുക്കില്ല
Okay, good morning. We are moving to the next session of day 2 of the International Conference on ICT and Photonics. This session will be on RF and photonics track. I'd like to call upon the session chair, Professor T.D. Subas, to be on the front row. Similarly, I would like to call upon Dr. Asim Dakal, session co-chair. I would like to request all the participants, guests on the lobby, please enter this ballroom 1. We are going to start the plenary session of this session. I'd like to request all the participants, guests on the lobby, please enter this ballroom 1. We are about to start the session here. Okay, please.
No, not over. You need to
So good morning to all. So now we have our second keynote talk by Professor C.F. Kong, Associate Professor, Head of Department of Electrical and Electronic Engineering, University of Nottingham, Nimpo. So his talk is on scalable and privacy preserving blockchain architecture for CV2X with dynamic sharding and zero knowledge proofs. So I invite Professor to hand over the section.
Thank you, Chair of the session. Good morning, everyone. Namaste. For those from Southern India, Vanakkam.
Vanakkam.
Vanakkam. From Korea, 안녕하세요. From China, I didn't say ni hao. It's over there. Okay, so today, just now, the keynote was talking about physical security of the connected vehicle, not connected, the autonomous vehicle. I will talk about the similar topic, but my focus is more on the cyber security related to the connected vehicles. So first of all, I would like to sincerely thanks to the organizer for the kind invitation to speak in this conference in this beautiful city of Kathmandu. This is my first visit in Nepal, but I'm deeply impressed by the warm hospitality and generosity of the Nepalese people. So let me begin with a simple but powerful observation. So first, I was told that I only have a 30 minutes presentation, so my apologies if I rush it through. So vehicles today are no longer mechanical systems with communication modules attached. They are distributed cyber-physical agents operating within short decision-making ecosystem. So at the moment that the vehicle begin to exchange the state of information, the speed, trajectory, sensor perception, driving intent, so the challenge shift. So the problem is no longer about connectivity. The real challenge becomes trust at scale. So today I'll present our work on a scalable and privacy preservation blockchain architecture for CV2X, integrating dynamic sharding with zero knowledge proof, or ZKP. So this work, just a little bit of a disclosure, this work has been presented in Montreal last year in the IEEE ICC. I expand a little bit for this conference, and I elaborate more on the architectural rationale and the underlying complexity, transformation, and the system-level performance outcome. So the central question guiding this research is following. Can we enforce trust, accountability, and privacy in large-scale CV2X network without relying on a central authority while still meeting stringent latency requirement? So these are my topic for today. Of course, I need to introduce where I'm from, and I will talk about the worldview within the CV2X, proposed architecture, performance evaluation, of course, the conclusion. Don't be fooled by this picture, because this was taken probably about 5-6 years ago. So, yeah, look at this picture. Yes. So I earned my PhD in mobile and satellite communication from Multimedia University in Malaysia. I'm a senior member of IEEE. I'm a registered chartered engineer with the Engineering Council of UK. I'm currently the head of department. It's my second term as my head of department for electrical electronic engineering. So in our department, we got 42 academics and research staff, from chair professor all the way to a very junior staff. We have about 280 undergraduate students, 23 MRes students, and we have a big bunch of 82 PhD students working with us. So first of all, a little bit about the university that I currently affiliate with, University of Nottingham. It's a public research-oriented university in the UK. It has broadened its presence with a unique tri-campus structure. It is a member of a Russell Group in the UK. So it is similar to the C9 University in China, Ivy League in the US, or a group of 8 in Australia. So the university has established 2 international campuses. One is in Malaysia, and another one found in China, which was founded in 2004. So currently I'm based in the China campus. I'm also a co-founder of this next generation Internet of Everything laboratory. So our research themes including intelligence across smart city, healthcare, logistics, manufacturing, and smart transportation. So in our lab, we have numerous prominent people with a variety of expertise and background. Most of us are working on the 5G and 6G related topics. My area specifically on the 5G mobility management and of course Internet of Vehicle, particularly in the area of cellular V2X, CV2X. So if you look at the worldview, the global trend of Internet of Vehicles, Asia Pacific region is expected to experience exponential growth, driven largely by China's leadership in 5G deployment and connected infrastructure. So the ecosystem is highly competitive with major automotive and technology players actively investing in IOV platforms and communication solutions. So the market is segmented across hardware, networking, services with and services that take the largest share, while cellular networking and the V2V, vehicle-to-vehicle communication, are expected to dominate the communication layer. So overall, IOV is not just about growing, it's about scaling rapidly, which makes efficient and secure data sharing architecture increasingly critical. So to understand why trust problem becomes so challenging, we must first understand what vehicles has evolved into. Now, I'm not going too much deep into this because our first speaker has mentioned quite a lot about onboard sensors. And this is what happened in our cars today. It's full of sensors. And it increasingly becoming very sophisticated. So in other words, each car is effectively a mobile IoT, Internet of Everything. And if you look at the global trend, in 2015, only 20% of newly sold cars are connected. And by 2024, that figure has risen to 75%. Of course, in 2025, it's a lot more. In most of the major market in car manufacturing. Now, this is not an incremental growth. It's a structural transformation. So when connectivity becomes standard equipment rather than a premium feature, 3 things happen simultaneously. First, the number of network participants increases dramatically. Every connected vehicles become potential transaction originator and validator participant. Second, the interaction density increases. So it's not just a number of vehicles, but it's a number of pairwise or multi-party interactions between them. And the third is the cross-domain data exchanges. So vehicles not only talk to each other, but also with the roadside unit or RSU. So, and of course, it involves a lot of other technology, including clouds, edge computing, etc. So if we denote the number of vehicles as V, the number of potential interactions, pairs, the scale approximately with V, with the factor of 2 in the dense environment. So V2X or CV2X is actually 2 different things. The V2X is an umbrella, then cellular-based V2X. This is what I'm talking about here. It provides communication backbone for the ecosystem. So what actually is the CV2X? So basically it's standardized by the 3GPP. So 3GPP, for those who are not in mobile communication, 3GPP is the World Standardization Organization that standardizes all the mobile communication standards. What you're using starting from 3G all the way to the future 6G is all standardized by 3GPP. In fact, the name is called Third Generation Partnership Project. They never changed the name ever since the 3G. So it supports multiple communication modes. So that's why they call V2X. X means for everything. So it can be V2V, vehicle to vehicle, V2I, vehicle to infrastructure, V2N, vehicle to network, and V2P, vehicle to pedestrian. So in China, there are at least 12 highways installed with the RSU, or roadside unit, and operates in the CV2X mode. As of now, they have not commercialized the 5G V2X yet. They are only at the level of LTE V2X. So we are still testing it through for the 5G V2X. It's still in the lab and testing phase. So it creates this connection. It creates all kinds of opportunities. And this has become our live laboratory. Laboratory to test some of the innovations in sensors as well as network-connected vehicles. So up to this point, the conversation is always about connectivity and deployment scale. We are moving currently today from a communication-centric system to the intelligent-centric system. And this allows, the communication enables the data exchange. And intelligence requires governed data sharing. But connectivity alone does not create intelligence. So a connected vehicle does not trust shared data, cannot operate safely. So it's all about trust. So we are moving from communication-centric system to intelligent-centric system. And this one needs to be properly governed, as I mentioned. So at this stage, the discussion moves beyond the engineering convenience into regulatory necessity. So across jurisdictions, mobility data sharing is no longer optional. It is increasingly structured, mandated, and audited. In European Union, the ITS directive, National Access Point and the Cooperative Connected and Automated Mobility Management, CCAM. They share data, they do a data sharing framework, and the emerging European mobility data space all push towards to interoperability, accountable and secure data mobility, secure exchange of mobility data. The regulatory philosophy is very clear. Cooperative and automated mobility system must operate within a transparent and traceable data ecosystem. That means data exchange mechanism must be standardized. Access must be controlled and audible. Liability must be traceable. Cross-border interoperability must be assured. In China, the Intelligent Connected Vehicle, ICV, similarly emphasized on unified standard, large-scale V2X infrastructure deployment, and coordinated governance across ministries and provincial authorities. So China's smart highway pilots and city-level ICV demonstration already required structured data and exchange among vehicles, roadside infrastructure, and traffic management centers. So at this point, we clearly articulate the engineering challenges. So CV2X data sharing operates under 4 simultaneous constraints. So the first is a massive scale. So vehicle density in the urban corridors can reach thousands of nodes literally thousands of nodes. In some provinces in China, or in some city of China, we are talking about millions. For instance, in Shanghai, we're talking about millions. So millions of or thousands of nodes per square kilometer. So each vehicle may generate periodic status update, safety messages, perception data, and cross-domain transactions. The second issue is latency. So cooperative safety applications, collision avoidance, emergency braking coordination, intersection management require a sub-second validation. In some cases, we're talking about 100 to 300 milliseconds. It is in the acceptable window. It may be less. The third is about high mobility. So those nodes are constantly moving and joining and leaving communication regions. So it's unlike static IoT networks. The shard membership and the communication topology are very dynamic. And then the last one is that we are too much on OEM based. OEM means that it's all about car manufacturer. They probably develop their own standards. And this is a problem because if car manufacturer A and car manufacturer B are developing their own standard, they cannot talk to each other. This is one of the main reasons why in cellular communication, they created 3GPP, so that all kind of communication devices are following the same standard. So CV2X data sharing must operate in the massive scale under strict latency constraint and highly dynamic and partially untrusted environment. This is tricky, but I will explain later. And at the same time, preserve privacy and accountability. Now this raises a key question. I will just read from here. How can you trust, you govern, and you make accountability to be enforced without relying on central authority? How do you do this? Now in fintech, they found a solution. In Bitcoin, they found a solution. They use blockchain. And in this case, of course, we use blockchain also. So blockchain in CV2X is a decentralized, trust, integrity, and audible. And in the network, vehicular network particularly, the traditional blockchain cannot be used. So we have to modify somehow the blockchain. So in this case, the key limitation of the traditional blockchain is about scalability and latency under high mobility. And how do we do this? So we use this concept, blockchain sharding. Anybody who are in mobile networking will be very familiar to know about this term called sharding. It's a divide and conquer strategy, so that the way how we process it in a parallel fashion. So in traditional blockchain, every node must verify every transaction, and this of course create bottleneck. So you imagine that if you're driving in the road, the traffic police check every single car. And don't talk about traffic police check every single car. Just talk about the roadblocks. And you have a whole bottleneck of cars queuing to pass through the roadblock. Now this is what happened in the traditional blockchain. So what happened is that we use another approach we call sharding. So sharding breaks the network into smaller groups. And so the transaction can be processed simultaneously. In other words, what we do is that instead of a single roadblock that the traffic police check, we divide it into 5 or 6 roadblocks. Everybody will move into the roadblocks. We just increase the number of traffic police to look and check each of the each of the car. So however, we face a unique challenge. So the car moving very fast across regions. So causing frequent cross-shard communication. So if we use sharding alone, it solves half of the problem, but it does not solve the whole problem. So this leads to what we call 1% attack risk, where attacker only needs to compromise one small portion of nodes to control a single shard, and the remaining and maintaining data consistency across shard become computationally expensive. So this is where we propose our structure that has been presented in Montreal last year. So our proposal is based on dynamic load balancing, sharding to prevent shard congestion. So we use what we call zero knowledge proof, this approach. So what is actually a zero knowledge proof? If you look at this ChatGPT generated, what they call that, image. So zero knowledge proof is that to tell people that please trust me, but you cannot see the data. So you preserve the privacy. So what they do is that they don't check whether that the data is trustable. What they check is the process, the rules that you put on, is it trustable on and is reliable. So it's a matter of quality assurance and quality control. So the quality control, you check everything. Quality assurance, you trust the process. And the one that is being audited is the process. So this is what zero knowledge proof. So at the same time, you do not have to look at the data, so you preserve privacy, and yet at the same time, the process you trust means that you say that this data is trustable, it's authentic. So in CV2X environment, this means that we can validate transaction without exposing vehicle identities or sensitive trajectory information. So, but in our work, zero knowledge proof is more than just a privacy tool. It's actually to manage the scalability. So too much sharding, you have problem in scalability, and we need to simplify further the checks and balance. So this is where the zero knowledge proof comes in. So up to this point, we have established that sharding improves throughput. It allows parallel processing, reduce per node load, increases system capacity. So naturally, one might assume sharding solves scalability. But here's the very, very, very uncomfortable truth. Sharding scales computation, but it does not automatically scale coordination. So the moment vehicle moves between shards or transaction span shards, cross-shard validation become unavoidable. So this is where the bottlenecks appear. So if we have a T cross-shard transaction, validation grows as O in the bracket of T. That's how we define it. So more vehicles, more transaction, more cross-shard checks, more cross-shard check, more communication overhead. So eventually, communication overhead cancels the benefits of sharding. So sharding alone breaks under high mobility. That's the keyword. So the insight of our work is that instead of validating each cross-shard individually, we aggregate them. And we trust the process of zero knowledge proof in our algorithm. So we just need to validate one proof, and we trust the rest that this proof is correct. So in a nutshell, without zero knowledge proof, to trust you, I need to check everything. But with a zero knowledge proof, I can only check that you follow the rule, right? So it's a quality assurance thing. So our core contribution, just a quickly, just a touch and go. If you want to know detail, you can read the paper. It's available on the IEEE, IEEE Explore. First of all, our contribution relates to the dynamic load balancing sharding. So the sharding is not purely on geographical, it's not static, it's purely based on the load. So we dynamically adjust the strictness based on the load. And then the second is the zero knowledge proof enabled cross-shard validation. I have explained a little bit later, just now. So this is a key technical innovation. And then the third thing is a hierarchical consensus mechanism. So we separate consensus into two levels. Actually, yeah, it's two level. So each shard we use the PBFT. So it's a Byzantine proved for a strong intra-shard agreement. So this keep the consensus below the consensus time below 360 milliseconds, even in a dense, high mobility CV2X environment. So just a quick glance on the different layer that we have designed the whole system. So at the user layer, we have vehicles with OBU. OBU stands for the onboard unit. So all the sensors and processings are there. At the network layer is that the RSU, the roadside unit, and the blockchain layer. This is where we design heavily and modify heavily the traditional blockchain with a dynamic sharding using zero knowledge proof, enable cross-shard validation, so we can split, merge, and still validate efficiently. I will not go through this one because I think in the interest of time, because this is a little bit too technical. If you're very much interested, I will show you the what they call it, the paper, the link to the paper. You can read the paper if you're interested. So it's the same thing for here. So we will talk about the performance. So this table tells a very simple story. I will just briefly explain. So without sharding, everything is global. So the storage is over here is O bracket n, and the throughput is O bracket 1, and the system does not scale. So sharding improves the storage by dividing the m, small m. So O n divided by m. And the throughput, instead of n, it becomes a m. So it depends on the dynamic, on the load. So the cross-shard validation still grows, but then it grows linearly with the O bracket of t. So it becomes a new bottleneck. So our design keeps sharding scalable, but reduce the cross-shard validation using aggregated zero knowledge proof. So we preserve the throughput gains and eliminate the coordination bottlenecks. So before I show the performance, so let me briefly discuss about our simulated 3 practical attack vectors. So first is what we call shard hopping attacks. So adversary can jump into a shard rapidly and evade monitoring or destabilize the load balancing. The second attack we simulate is the cross-shard consensus sabotage. So a malicious group can attempt to push invalid cross-shard events. And the third is a resource exhaustion attacks on the zero knowledge proof generation. So you flood the whole system until the resources are exhausted. So you can flood the system with a bogus transaction. I think our first speaker did mention about the attacks just now. What they do is that they flood with they jam the system. But this one is more on the cyberspace. They flood with all the garbage and waste of proof of a computation. So we did on the simulation, so we used the OmNet++, we had to redesign the whole thing, we use Sumo. And we do somewhere that is very near to us. This is the map of our campus. And we do simulation around the area. And this is the result. If you look at no sharding, the orange color, let me show you. Okay, you can see. So the orange color, the more number of vehicles, the number of throughput drops. This is because of the bottleneck. But we put the sharding, all right, just sharding, so the throughput increases, although that later on it will taper off because of the bottlenecks. So, and then the second thing is that we look at the bandwidth. So bandwidth, we include the algorithm that we propose with a zero knowledge proof. And if you look at here, no matter how many vehicles that you throw into the system, it does not bottleneck, and the amount of available bandwidth is still available. It's still there. And the last one is about concession time. That's why we're talking about how fast that we can process the whole thing. So as you can see that with our proposed algorithm, which actually there are two. One is called intra and one is inter-sharding. So inter-sharding is with what they call that, checks between 2 or 3 shards together. Intra means that the checks is individual, all right? So the same thing, the more number of vehicles is still maintained, the processing time. So the conclusion. We propose a scalable, efficient blockchain architecture for CV2X data sharing. 3 mechanisms works together. First, dynamic load balancing sharding to distribute resources evenly as the traffic density increases. Second is zero knowledge proof enabled cross-sharding validation, where we verify and aggregated proofs in time. So cross-shard coordination does not explode with mobility. And the third thing is that hierarchical consensus mechanism. So it's a lightweight-based checks inside the shard, and the zero knowledge proof verification for the cross-shard operations. So as a result, we achieve 90.8% lower validation bandwidth, and of course we kept the time for processing below 360 milliseconds. So future work, apart from here, of course, we're using reinforcement learning. Those who are in AI, you are very familiar with reinforcement learning to make it more dynamic and train to the present moment. Other than that, also, we aim to field test this in the highways in Zhejiang province, hopefully in 1 or 2 years' time, that at least we can prove it in the field. So if you're interested to read more detail, please feel free to download this paper in the IEEE Explore. And of course, I'll be available throughout the whole conference. We can talk a little bit more detail about it. If you want a mathematical proof, everything is inside that paper. I do bring some algorithm over here. It's already published. You can take picture if you want to. So I think that's all. Thank you so much for your time.
Questions from audience side?
Professor Yi.
Okay, so this can be a simple question, but thinking about when I driving the car, so I just need information from neighborhood cars. I don't need the information from the far of my car. So that means maybe we can reduce the data. So we should exchange maybe minimum data that really needs to the safe driving.
Yeah,
So what's your opinion about that?
I totally agree with you. In our field, particularly in VANET, we call it cluster. So we do a clustering. Traditionally, the cluster is in a fixed distance. There is a lot of work in my lab that we're looking at the possibility of a dynamic cluster. So I give you an example. There's one of my PhD students that work on my idea, my project, that we work on the truck platooning for all the trucks taking the cargo from the port to the distribution center. And for that one, we need to design a special cluster because the cluster is fixed all the time. But we cannot use it for the commercial, the individual vehicles because it comes with different size and shape and with the different terrain. So we are using historical data and the localized data in order to decide how big is the cluster that we're looking at. And we also look at the trade-off into the communication load that we have. So it is a very ongoing work on this one. And let me tell you that it is not an easy work to do that. Thank you, sir.
Any more questions?
One more question is that currently people are looking for quantum communications or quantum key distribution. So what do you think about that, the future of the QKD in autonomous vehicle? That's one of my headache.
This is another interesting question because without enabler, we cannot have no matter how good is your algorithm, is useless. So there's another group in my lab looking into quantum communication and quantum computing, and then this goes all the way down into instead of relying on the traditional processors, they are using another type of processor they call neuromorphic processor. And it's very, very lightweight. And if it is lightweight, the processing time is a lot faster and a lower power. And neuromorphic processors is a good contender to challenge big, discover what they call it, big system that probably created by NVIDIA. Because NVIDIA is huge. It's very huge. Probably at the roadside unit you can put it. But inside the OBU, it's not practical to do this. So yes, it is ongoing work. Again, it's not easy. It's go all the way to a very physical part of the communication, to the point that they need to redesign the waveform.
So is this ICTP generation has any fundamental, cryptographic limitations?
Come again, sorry, sir?
ICTP generation caused any, cryptographic limitations in that?
Cryptography?
Yeah.
Okay, so just to be clear, blockchain is not really a cryptography. It's more of the trust. Is to tell people that you can trust me. Cryptography is to hide. You just hide it. Cryptography is another layer of the research. Two of my colleagues are looking at the lightweight cryptography. I'm not an expert in that area, but just give you a very light, what they are doing is that they want to design a system that is so mathematically complex, and yet it is light enough. In terms of algorithm, is light enough to be implemented in what we call a vehicular network. So the vehicular network, one of the things that we always think about, you see, if you send human or if you send anything to the space rocket, every single gram counts. Every single gram. In the fast-moving communication, every single bit of data counts. So you reduce 1, 2, or 3 bits of data because cryptography, you need to add a lot more layers. The more layers you have, the more secure it is. And yet, at the same time, is it justifiable? Is it too many or too small? So it's a very balancing world that we are looking at. I hope I answered.
So any engineering optimization challenges? Any engineering optimization challenges?
Optimization challenges. Of course. We optimize it all the time. So the work that we're doing now is that we involve machine learning. Now, machine learning itself is not really highly optimized. We need to have some sort of a benchmark in order for you to go. The thing is that how do you optimize the benchmark? So we need to use a lot of other heavier way of optimizing it. So the way we do it is that we have many levels. The first level is we do what we call the O&M, Operation and Management and Maintenance, Operation and Maintenance period, where probably every 3 months or 6 months we optimize, we train the data, so we go to optimal level, and then each vehicle will have a small scale of machine learning to make it even more optimized. So one go train all to near optimal, another one is online optimization in order to do that. And we cannot just simply use any kind of a learning algorithm for that. And sometimes there are one or two of my students that show me the result, and we found out that instead of using machine learning, use a heuristic algorithm is even more efficient as compared to the machine learning. So sometimes I tell my students that don't use machine learning for the sake of machine learning. All right? Thank you.
So any questions?
Excellent. Thank you so much. For our friend from India, Nandri, thank you so much. Thank you, everyone.
So as the saying goes, the best way to predict the future is to create it. So thank you, Professor, for your wonderful lecture and interactions. So now it's a token of appreciation. It is on behalf of this organization committee, you can share a short memento to Professor. So we have our next speaker. So education is not the filling of a pail, but the lighting of a fire. So we have another speaker to create fire among us. Is Professor Yakshiyan from the Department of Electrical and Electronic Engineering, the Hong Kong Polytechnic University, Hong Kong. So she is about to talk on integrated optical sensing and communication and its applications in urban areas. She's expert in
optical fibering network. Thank you.
So thank you, Chair, for the nice introduction. And just a brief introduction of myself. My name is Yashi. I'm from the Hong Kong Polytechnic University. Yeah. Okay. So. Wow. Sorry, it seems that. Oh, all right. Okay, so let's start. And the title of my today's talk is Integrated Optical Sensing and Communication and its application in urban areas. So I think some of you may be heard about this concept, integrated optical sensing and communication. Like in yesterday's talk, since we also have a keynote talk talking about this technology. But today I will just focus on the work we've done in Hong Kong about this kind of technology. And I will start from the background. So you can see this is actually this figure shows us the distance of the telecom fiber deployed in China year by year, and it is gradually increasing. And the background is that we know nowadays the optical fibers are everywhere, and specifically, like optical fibers are mainly used for data transmission. So people are thinking about, since we have a lot of fibers, how do we fully use these optical fibers? Because, like, see, if we can find other functionalities of fibers, we can realize extra values of existing deployed optical fibers, right? And we know optical fibers can serve as sensors, and there are, if we say we can integrate the sensing capability into optical fiber networks, it can bring us a lot of advantages. For example, can turn the telecom network to huge sensing network, and also increase the value of existing telecom infrastructure, and provide proactive fault detection to optical fibers to ensure the stable data transmission. Since we are now in the AI era, so high speed and high capacity data transmission is very important. So to ensure the stability of optical networks is quite important. And we say optical fiber sensing actually is a good tool for us to reach the goal. And let me just introduce you several techniques to realize the technique IOSAC. Yeah, so basically we just look into this technology from the sensing view. The first type of the solution to realize IOSAC is based on what we call the forward sensing, because the light is forward transmitted. And we say this kind of technology is more compatible to optical communications because data actually is forward transmitted. So the sensing principle can be divided into two categories. First is related on the tracking of the state of the light, a state of the polarization of the light. So we say because the external disturbance can induce the change of the fiber birefringence, and in that case, the polarization of the light when it is propagating in the fiber will also change. So if we monitor the change of the polarization, actually we can detect the external vibrations. And the second method is based on the phase tracking. It is straightforward because we know when the light is propagating in the fiber, the external disturbance will induce the some kind of strain to the fiber, and as a result, the optical phase of the light will also change. But if we compare these two technologies, we say the polarization tracking, this method, the advantage is that it is cost effective because it can be integrated to the optical communication system directly. No need of extra devices. But the disadvantage is that it is less sensitive because it is based on the fiber birefringence, while for optical phase, it is much more sensitive, and it can provide the localization capability. Let's say if we have two light beams counterpropagated in the optical fiber, then we will have two actually phase signals with a certain delay related to its the position. So for the phase sensing, we can localize the event, and the resolution is around somehow tens of meters or around 100 meters. And the disadvantages of the optical phase sensing is that it requires, we say, ultra-stable laser or narrow linewidth laser, because the laser phase noise also influences the SNR of the phase signal. Well, so as I just mentioned, we want to realize integrated sensing and communication. So based on the forward sensing scheme, we try to propose somehow cost-effective solutions. And this is the first work we've done. And the fundamental system is the coherent optical fiber communication system. So we can see this is a typical structure. We have the transmitter laser, and at the receiver we have another laser source called the local oscillation laser. Okay, and let's say, how do we realize sensing? Yeah, if we just split some part of the light at the receiver side to let it counter-propagate in the fiber, and then we have another detector at here, the transmitter, then we can get two signals. One signal is here at the receiver. We have the coherent receiver here. We can demodulate the phase signal of the forward propagated light. And then we have another signal transmitting in the opposite direction here, and we demodulate the phase signal of this light beam, and then we get two counter-propagated phase signals. And if we use the, as I just mentioned, the time delay estimation algorithm, then we can both detect and localize the external disturbance. And we do the experiment, and this is the experimental setup. And the telecom transmission actually is very standard, the 60 gigabaud 16 QAM signal. And of course, we need to use two narrow linewidth lasers, and we have two signals for us to realize sensing. One is we transmit a piloton, which is a continuous wave signal we used in optical fiber communication, while here we use it for sensing purposes. And another one is the counter-propagated continuous wave signal. Okay, and since the signal frequency difference between these two counter-propagated light waves are very small, so we just need a very low-speed receiver here at the transmitter side of the communication system. And we use this kind of device, what we call the PZT, to introduce the vibration, and the sensing is realized by the phase tracking. And fiber here, we just for the demo is a deployed fiber network in Hong Kong. The total distance is 100 kilometers. Okay, so this is the route of the deployed telecom network. It is a real telecom network, and yeah, we just this is the location of our campus here. The network just goes through this. This is the Victoria Harbour, and it goes across it. We have a tunnel here, and then goes through the Hong Kong Island, and then to the Kowloon City, and then go back to Polio campus. All right, so we first investigate the influence between the sensing and the communication signals. As we can see, if we increase the power of here, the sensing, the continuous wave sensing signal, the SNR of the data actually decreases, right? So we can see here, if we fix the power of the sensing signal to the -7 dBm, and we just turn the sensing signal on and off, we can see the SNR of the data. Actually, the influence, the vibration is very small, and we say the influence from the sensing to the communication can be ignored. And then we just study the performance of the sensing, and these are some like spur-like vibration signals, and we do that like. Obviously, the signal can be well recovered, and the localization, the accuracy is, we say, actually good, somehow good, because it's like around tens of meters, yeah. And we can see here from this, the noise figure of the retrieved phase signal, we can see since the telecom data is on, and we have some like high frequency noises located here, like larger than 50 kilohertz. But if we say the signals at the like low frequency area, the noise actually can be neglected. And we say in practical applications, the vibration signals actually located in the low frequency area. So somehow the influence of the communication to sensing can be ignored. Well, all right, so as I just mentioned, we need the narrow linewidth lasers, right? So actually, we say in telecom world, we do not actually want to use the high price, the narrow linewidth lasers. So how to relax the requirements of this kind of high price laser is very important. So we try to just solve this problem, and we propose a scheme based on what we call the optical comm technology. The idea is that, okay, we have a laser source, and we use the modulators to generate the frequency comps, and these comps actually share the same phase pattern because they are from the same laser source, right? And then we introduce a delay to one of the frequency term and keep the other frequency terms time synchronized, and then let the signal to propagate the optical fiber, and at the receiver, we also introduce the delay. We have another tone at the receiver, and we introduce a time delay to one of the frequency tone, and the others are also synchronized. And then you may see we actually have several signals with different frequencies, and then we can demodulate these the phases of these signals, right? And let's say if we just focus on two frequency tones, one with time delay and the other without time delay, what will happen? Let's look at their phases. Yeah, this is the phase of the signal with time delay and the other without delay, while they also carry the external phase the phase variations, right? And then we can do the differential calculation by we just time shift the first phase signal and then do the phase differential between the time shifted signal and the other phase signal. And finally, the phase noise term induced by the laser source are cancelled while the vibration signal are kept. So, yeah, we can do the vibration sensing using the low-cost telecom-grade lasers, and this is the experimental setup. Sorry. All right, let's just look at the results. So let's just compare the two phase signals. The above figures show us the phase signals just directly demodulated from the data. And we can see if we reduce the vibration, the intensity, and when the applied voltage are related to the strength, the intensity of this vibration signal, it is reduced to 0.1 voltage. We cannot see any useful information, right? But if we do the differential phase calculation, even if the vibration strength is very small, we can still demodulate the signal very well. Well, what happened? All right, so here is somehow conclusion of the previous part. We say the forward sensing method can be integrated into coherent transmission systems easily, and it is very suitable for the long-haul sensing applications because signals is forward transmitted. It can go through the optical amplifiers like EDFA, but it faces the problems. For example, we need the bidirectional transmission for the localization, and also price time synchronization, and the spatial resolution or the localization accuracy is not that good. Yeah, so we need to find other technologies for better sensing performance. And the second sensing scheme is based on what we call the we say DAS, or phase sensitive OTDR. This is based on the Rayleigh backscattering. The phenomenon occurs inside the optical fiber. If we send a light pulse into the fiber, and we know there exists some impurity inside the fiber, and the light can be gradually scattered, and the backscattering signal can be used for sensing. And here, let's say if we have a vibration or external disturbance occurs at a specific point along the fiber, and then the signal distance we detected changes. So due to the time of flight of the signal, we can both detect the signal and also know its position. So the advantages of this kind of technology is that it is very sensitive and it can offer high spatial resolution. Well, of course, we still need the narrow linewidth laser because it fundamentally based on the phase detection of the Rayleigh backscattering signal. And then, let's say if we want to integrate this kind of technology to the optical communication systems, what challenges do we face? Okay, the first is that actually the spectral efficiency and the crosstalk. Since, as I just mentioned, we send the pulse-like signals into the fiber. So this kind of signal has a feature is that the peak amplitude is very high, while the average signal amplitude is low. So we say we have a very high PAPR, and it will introduce the evident nonlinear influence to the telecom data. So traditionally, we use the technologies, we say the wavelength division multiplexing to realize this combination. But the problem is that we need to have the dedicated channel reserved for the sensing, while, as we know, it will consume the bandwidth, right? The baggage for the telecom data transmission. So that is what we don't want it. And the second is that sensing, here the backscattering sensing structure is somehow different from the communication system, because we say we need actually the narrow linewidth laser, and also sensing requires the low speed AD or DA, but communication usually you use high speed DA or AD. So the challenge is that whether it is possible for us to design a system, we can both share the hardware and the fiber between the sensing and the communication. So based on these challenges, we proposed a scheme to integrate the DAS, what we say, the really backscattering sensing with the coherent optical communication systems. And here the DAS technology relies on we say the linear frequency modulated pulse, but the fundamental theory is similar. We just detect the phase of the really backscattering signal. And let's say how we realize the integration. So let's just consider the physical layer frame of the coherent transmission. This is actually the data structure. So we have the in telecom data, the structure we have here, what we say, the training sequence and the payload. So for the training sequence, its baud rate actually is much lower than the payload. So we take use of this training sequence, and we say if we just put our sensing the pulses into this training sequence part, then we can realize the actually the time sharing, right? And let's say if we look at the frequency spectrum, we put our sensing signal at the row of area of the data, the frequency spectrum of the data, and we say we can realize the frequency multiplexing. Somehow it is the frequency sharing, because this is the main part of the data, while the role of actually, if we put sensing signals in this part, it will not significantly influence the performance of the telecom data. And then we say we realize actually the time staggered to avoid the crosstalk between the sensing and the telecom signal, while we have this kind of frequency sharing, and it helps us to save our frequency source. And then we do the experiment. So let's say this kind of scheme help us to realize the hardware sharing at the transmitter. Since we can use one AWG, the arbitrary wave generator, to generate both the sensing and the communication data. But the problem is that, as you can see from the time figure, the sensing actually has very high amplitude, while the telecom data, its amplitude is not that high. So it will, due to the high intensity of the sensing signal, it will introduce the problem, what we call the quantization noise. So we should consider the launch power, or what we say, the intensity of the sensing signal, okay? Well, for the frequency, yeah, since sensing is located in the row of area, so we can just use a filter to filter it out, and we can easily do the signal demodulation. And let's first see the sensing result. Here we just fix the signal power. STPR means the power ratio between the sensing and the communication, okay? Let's say the sensing power is 8 dB higher than the communication, and we fix this value and do this performance investigation. While we applied the sinusoidal phase variations, it can be actually well recovered, and the SNR of the signal can reach more than 20 dB. And let's look at the influence of the sensing to the communication. Yeah, we just gradually increase the launch power of the sensing signal. As we can see, if the sensing power is like 8 dB higher than the communication, while both of the sensing and the communication can reach a good performance. But if we further increase the launch power of the sensing, well, the communication performance actually is not acceptable. So we say this kind of method somehow provide us a solution to realize the good performance in sensing and communication, but we should also consider the practical applications if we can reduce the sensing power or increase the sensing power. It just depends on the real applications. Okay, so we say we have so many integration methods, right? So if we have sensing by using the telecom deployed fiber, what applications can we achieve? And we have done some actually tests in Hong Kong by using the deployed fiber. And here is some details of the specifics of the fiber. It actually contains over 100 fibers in a fiber cable, okay? And we use this is the distributed acoustic sensing system, and we have the spatial resolution of around 3.5 meters, and we try to realize traffic monitoring using the fiber. And wow, it is quite different from the other areas like the country road and highway road, because in Hong Kong, yeah, we say the traffic is very dense, so the urban noise will significantly decrease the quality of the signal we picked. So how to reduce the influence of the noise to enhance the signal quality is a very important, actually technical challenge. Yeah. So the first work we done is that since we have so many fibers inside one fiber cable, so we can use several these sensing interrogators for us to retrieve to detect the signals from different fiber links, right? So here we use two devices to simultaneously detect the data, and then we do the signal processing using the maximum ratio combination, and we can see that these are the individual signals we achieved using the devices. And if we combine these signals and do some kind of averaging, so finally the SNR is increased, and wow, we can use this kind of technology for us to do the first step, signal denoising, and then we can use some advantage algorithms for us to remove the unwanted noises. So particularly we can use the low pass or somehow band pass filtering to retrieve the signals we wanted in specific frequency band, and also using somehow the wavelet denoising algorithms. But we know both of these algorithms, they face the problem of the uncertainty between the time and the frequency accuracy. So these kind of trade-offs can be solved by using the algorithm, what we call the superlet. So superlet is kind of wavelet, but it decomposes the signal from both the time and the frequency domain. So if we decompose the signal and then we pick up the signals just located in the frequency band we are curious about, then we can do the signal denoising like this. Let's just see the signal after the superlet denoising. This is the original wave, and this is the signal after denoising. We can see the signal, the SNR is actually significantly improved. And Then let's just do the signal processing in traffic monitoring. As we can see, if we use the traditional bandpass filter to remove the noise, yeah, the signal is relatively weak, right? And if we compare it with the superless method, yeah, the signal is obviously strengthened. And then it led us to actually achieve the signal from the other the other road tracks, like the vehicles just moves in the opposite direction, okay? So let's see, if we can improve the SNR of the traffic signals, we say we can realize the detection of all the large vehicles in both directions. Okay, and then let's just continue to look, because we say these vehicle signals, actually, we can see there are several slant lines, right? So there, how do we get these slant lines? The step is that we need to normalize the signal. Then these signals with high intensity becomes obvious, and then we can see the vehicle signals, the trajectories in this kind of waterfall plots. But it is obvious, like the heavy vehicles is much easier to be detected, while the light vehicles, like cars, somehow is difficult to be detected due to this kind of normalization. So the solution is that if we do not treat this figure as a whole, if we just segment it into small pieces and then do the normalization, what will happen? Let's see if we use this kind of pixel, the small window, to scan the figure and do the segmented normalization. We can compare these two areas. Some extra traces appears, and these slant lines are related to the weak vehicles. And then let's just make it like further. If we make the window much smaller, and then all the vehicles here related to the small or the weak vehicles just appears, and the detection of the vehicles on the road, we can say we can detect like more than 95% of the vehicles on the road. And here, if we have the vehicle trajectories, these signals, we can also estimate the weight of these vehicles. The reason is that the signal intensity, its amplitude, is related to the weight of the vehicle. So if we have like large weight vehicles, then the signal amplitude is higher. So we just like using a window, and then we just sum up the signal amplitude inside the window and scan it through along the trajectory, and finally we can get a number, this kind of index related to the weight of a vehicle. The larger the index is, the higher the weight of the vehicle is. So we can somehow roughly estimate the weight of the vehicles. And also, let's see, we can detect the speed and also count the number of the vehicles on the road, and it will help us. This information is very useful for the transportation systems. Like see here, the gradient of the trajectory changes. That means the speed of the vehicles changes. So we can use the speed information to monitor the traffic jam, and also help us to manage the traffic system. And then if we combine it with the weight information of the vehicle, we can also manage the road asset, because heavy vehicles are like more easily to like disrupt the road service. So it is very important to monitor the heavy vehicles on the road. Well, if we have this kind of sensing knowledge, it will be really useful for our transportation systems. All right, so here comes the conclusions. I just presented several ISAC, the designs, and the goal is that we want to realize the simple and cost-effective ISAC schemes. And the first scheme I introduced is based on the forward transmission, while the second scheme is based on the relay backscattering sensing technologies. And since we have this technology, we can apply it to the deployed fiber networks, and then we can realize some applications. And I just introduced the traffic monitoring we achieved in Hong Kong, and we use several denoising methods. The first is the combination of the carotid signals, and second is the spatial wavelet analysis, the algorithm, and the third is the segmentation to enhance the weak vibration traces. And also we can achieve the rough estimation and the congestion monitoring using the sensing technologies. All right, so yeah, that's all my presentation, and thank you for your attention.
So thank you, Professor, for your
Any questions are welcome.
Yes, I have a question.
yeah.
So it's great to see IOSC, SSC moves from this lab prototype to practical implementation, because you implemented in Hong Kong.
Yeah.
So we to have see that in Kathmandu it's a great traffic. So what are the hurdles you see if you implement the same thing in Kathmandu?
The thing is that the Kathmandu, like the motorbikes are like quite popular. So yeah, we somehow can monitor it, but the situation seems to be more complex than Hong Kong. Yeah.
I also need to add in the same question.
Yeah.
I think you must have also experienced the traffic jam problem at Kathmandu, or otherwise you must have heard about the hazardous traffic jam at Kathmandu. So I also would like to complement or add my question that as a rapidly urbanization city, Kathmandu, what do you recommend in context of an integrated optical sensing and communication system be practically deployed to improve the traffic jam at Kathmandu?
Yeah.
Same question.
Yeah, the same question, yeah. So the traffic jam actually can be realized because we have trajectories. So somehow we do not need to monitor all the motorbikes, just heavy vehicles or the trucks or buses are actually enough, because for the traffic jam, all this trajectory will reflect the speed, the velocity of the vehicles, right? Yeah. So if it occurs, I think all the vehicles on the road, they're in the same situation, right? So for Kathmandu, if we have the fiber deployed along the road, then we have this kind of technology. Yeah, we can monitor the congestion. Yeah,
there can be many factors that actually impacts, but keeping everything constant. So your 2-3 suggestions.
Yeah. So that's it. So the thing is that the advantage of this technology is that we can use a single fiber to monitor tens of thousands or tens of kilometers, in the city or in the urban area. So somehow, if you have this system, we can real time get the information from the road. So no need to using human beings for the monitoring. Somehow, maybe useful for the congestion, but it should cooperate with the traffic lights. So if we have.
Thank you.
So in Korea, so most of the fibers are installed or deployed along the manhole.
Oh yeah.
So your fiber is deployed under the road or in the manhole?
Along, yeah. So it's just along the side of the road, yeah.
So all the data should depend on how far from the road to the manhole.
That's it. That's it. So the key point is that we say if we want to detect these signals, the coupling between the acoustic signal and the fiber is very important since it is based on the acoustic thing. So see here, the fiber is deployed just along the roadside, So the coupling in the tunnel is good. so we can get good signals. While if like see in this urban area, somehow in some region we can get the good signals, but in some region because the coupling is not that good, so yeah, so the signal is not that good. So
if a car goes to the center of the lane, so
yeah. And also you mentioned the distance between the car and the cable. Yeah, that's also a problem. If the car is far away from the cable, the signal is not that good. And for the application, we say the fiber usually is just dedicated deployed, not using the telecom fiber. Yeah, since telecom fiber actually, it will reduce the coupling between the acoustic waves. Yeah, so that's opposite directions. Yeah.
Yes, any question from the audience? Yeah?
So you mentioned that we can improve the traffic through the use of optical fiber layout, right? So I would like to know, how does it affect the nodes? Because we cannot just have the optical fibers laid down without having effective throughput on the nodes. Because when we were deploying in Thailand, what affected us was the nodes like the routers and the repeaters and the amplifiers. So how does it affect?
That's a question, very good question, because actually in telecom structure, we say the fiber network is usually not point-to-point, right? We have a lot of nodes. So these kind of splitters, the nodes will introduce large attenuation to the signal. So yeah, that's a question. So we have other methods. I did not present here. Yeah. So this is very the basic or the fundamental technology. Yes, and this kind of area actually is emerging only like 3 to 5 years, I think. Yeah. So the thing is that the forward transmission method actually is good because the light signal, it just propagate with the fiber, and we do not rely on the backscattering. So the backscattering, the light intensity is very low. So it can, somehow if we deploy it, it should go through the nodes. The signal is like fully attenuated and we cannot get any signals. While if we use a forward transmitted light, yeah, we can have good, somehow good signals. Yeah, like see in the access network, yeah, we can detect the phase at the end user side, and then we can also monitor the vibration. But the problem is that the localization is a problem since we need the bidirectional signals. So yeah, we can monitor it. We can detect the vibration, but localization is a problem in the access network, okay?
So I think you should be encouraged to write a next paper considering Nepal's infrastructure.
Thank you.
Yeah, it's a great news that ICTP has paved a way for a big problem of Kathmandu. So there is a solution. I request the experts from Nepal to contact Professor Yasi for further implementation. Thank you. Thank you very much, Professor, for your introduction.
It's a token of love.
On behalf of the organizing committee of ICTP, it's a great honor for me to hand over a token of appreciation to the Professor Yasi.
Next, Sulabh Gaire.
So next we can start with the...
Next, Sulabh Gaire.
Namaste everyone, it's me Sulabh Gaire and I'm here to present my paper Static Sense, Static Object Detection Using Wi-Fi Channel State Information. My co-authors are Vivek Chand, I Shrestha, Naveen Lamichhane. And if you see the literature in the field of Wi-Fi sensing, then most of the papers are focused on dynamic sensing that uses Doppler shifts, that time variant thing to detect the motion of human, like human activity detection and gesture recognition. But very few papers are written in the field of static sensing, detecting the static object using Wi-Fi channel state information. Why? Because the static object create a faint signature that is easily masked by the environmental clutter. What's the hurdle? The gap lies because the static sense create a constant subtle multipath distortion, and the reflection from the wall and furniture create a noisy baseline identical to the object, so that the static object gets blended into the environment itself. And to solve this problem, we present our system, Static Sense. This is the high-level overview of what we have done. Like, we have used low-cost commodity hardware, ESP32, to transmit and receive the Wi-Fi CSI signal. What we do is isolate the Wi-Fi signal, isolate the static object in a Faraday cage-like environment. Then that will remove all the ambient noises and capture a clean signal. Then we refine it to remove the noise of the box itself, the Faraday cage itself, by doing the baseline subtraction. What we do here is we subtract the signal created by the empty box to the signal present in the object. Then we use models like ResNet to classify the object. This is the hardware setup. We are using two ESP32 microcontrollers to transmit and receive the signal. And we wrap the entire box with aluminum foil to create the Faraday cage-like enclosure to remove any dynamic noises that is present in the environment. And we are, the foil is for creating the enclosure of the dynamic noises. And we collected the CSI data in two phases. Like, first of all, we collect the data of empty box, that is baseline, and we collect the data of the object inside. Like, there is a screwdriver inside, we close it and collect the data of the object itself. Then we did that for 5 static objects like motor, pliers, scissors, screwdrivers, tweezers, and we kind of changed the position and orientation to capture the variety of multipath distortion too, so that the model could learn it better. And this is the signal processing pipeline that we have used. First of all, we correct the CSI data. Then we pass it into the different subcarriers. We extract the amplitude and phase. Then we do the phase sanitization to remove the noise created by hardware, and Hampel filter to remove any brushed noise created. And we do the baseline subtraction after that. And we make it ready for AI to learn it, like we do windowing and normalization, and put it into the ResNet model to classify it. Why we are doing phase sanitization and Hampel filtering is, like, there are certain errors created by the hardware itself, like carrier frequency offset and sampling frequency offset. Those are created by the changes in the clock speed of 2 microcontrollers, so that add a linear trend to the signal that creates a not exact frequency, not exact phase that is really present. So to mitigate that, we do the phase sanitization, we do the process of linear detrending, and there are some brush noises created when the sometimes the hardware create the brush noises, like there are some spikes in the that should not be there, but that is. So we use the median-based Hampel filter with the window size of 7 and threshold of 3, and that removes the noises present in the signal. Then we do the baseline subtraction after that. initially we have collected the data of the empty box, and we have the data of the object, and we subtract it to get the object-induced signature that can be trained using the machine learning model to predict it nicely. This removes the static clutter reflection from the box itself, isolating only the pure object-induced effects. And to see, that was the, to give you the overview of what happens, but this is the real visualization of our data. As you can see, for all the object categories, I have put the amplitude and phase plot. For motor alone, you can see, before we can see the object and the environment noise, but after the baseline subtraction, we can see the pure static object-induced signature that can be easily classified by the model itself. Then we fed this images into ResNet model, and it classifies the image, the CSI data into the 5 classes: motor, pliers, scissors, screwdrivers, and tweezers. This is the result. We got the accuracy of 98%, and this is the confusion matrix. The summary of this project is to validate the methodology for static object detection using commodity hardware like ESP32 and deep learning model to achieve 98% accuracy. But there is some limitation in our project, because this is done in the control lab environment. We are using Faraday cage to remove entire ambient noises present in the real world, so this might not be feasible yet in the real environment. And another thing was, this was not done deliberately, but the object that we chose were mainly metallic in nature. And the object that we chose to classify were contained some metallic objects, so that the high accuracy might be the result of that too. So that further work needs to be done for the real world deployment. I think using directional antennas can be a solution to that Faraday cage-like encoder. And another, we need to expand it into non-metallic objects too. We need to test it in non-metallic objects too. And thank you.
Questions from audience side?
Any query from audience? No?
So I'm trying to understand the operation principles. So is this based, if you put the objects into the Faraday gauge, you are detecting the change of the resonance frequency, why the data changes if you put the object there? What is the principle of the data changes or the spectrum changes?
To be clear about your question, you're asking me, if we put the object inside the Faraday cage, why the environment noise get cancelled?
No. Why, if we put the object inside of the cage, so what physical parameter changes?
Basically, when this CSI data is vastly sensitive to the environment noise, and to remove that, we are using Faraday cage. Yeah.
So you have a cage.
Yeah.
So you have some data.
Yeah.
So that when you put the object there, you have different data. So why?
Basically, when we put the object inside the Faraday cage, the data of only the box is being collected, not of the outer environment.
So how do you address the privacy concerns?
Yes, sir?
Privacy concerns. How you address the privacy concerns?
Privacy concerns. We are not currently focused on the application side. We are testing if we can detect the static object or not. So we haven't worked on the privacy concern side yet, sir.
So I had a question, but you already said you haven't worked on that, so let me stop.
Maybe I spend too much time. Maybe I'll ask the personally.
No, that's okay.
Okay. Okay, thank you very much.
Thank you.
Next, Preeti, could you please come forward?
Good morning, everyone present here. I'm Preeti Ravikumar from RMK Engineering College under Anna University in India. And then my project title is Design and Development of CAN log analyzer with parameter tuning and ECU flashing validations. And then my teammate Suresh and Aravind, and then Hari Vignesh, and then Nagamani Kandal. We all like to travel in a car and automobile. We are using all automotive industries. But behind the car, we love to drive a car, and then we like to travel in a car. Behind that, there is a safety. We want to ensure a safety because this project is ensuring a safety. We all know that as we did not wear a seat belt means it gives an alarm. Like that, there is some of the parameters behind that. Start from a seat belt till the airbag. Your life is deciding through that. If an accident has happened, the airbag came out. Literally, your life is inside a car till a safety during that parameter programming. That for that validation, we have came up to the software. Like this software is made. It is a unified software. We have already worked together with automobile industry as well as automotive lead peoples. Like this project have including that ECU flash comparison and CAN log analyzer and actual value viewer and editing. If the what is flashing? Flashing is it is a programs that inside the ECU, like updating or rewriting. It will be doing if your phone there is OS doing updates. Similar like that in the automobile or in a car there is an ECU. It is like an OS. That programming inside we have dumping is called as a flashing. Same like that. Here we have ECU flash. It is one of the file. We are going to dump a code into an ECU file. That file is called .ecu file. And then some of the engines, it is nearly in a one vehicle there will be 200 plus ECUs. So we can't able to check that the ECU coding has dumped inside. It is correct or wrong. It may be wrong. Maybe it's wrong means it will be detect that get die of an patient. If some of the incidents the airbag it's not comes out means it's make dangerous to the persons. So here in a technical part here UDS command and programming session will be done. In that problem, in a survey which you have taken in an automobile industry was in 2024, the automotive electronic trends modern vehicles have contained 80 to 150 ECUs, but we can't able to get into manual calculations. In a premium car, it have increased this 200 ECUs. And these are the problems we have taken. And then validation time issue. If you are taken in a manual, it will be take more than 30 to 60 minutes time. And then here, our app, it will be done into 30 seconds. And then in a production site, in a plant, it will make more time delay. So the production will be get late. So that we have came to this idea. And then our problem statement is what I have said is time consumption. We have eliminating the time consumption into 60 minutes to 60 seconds, as well as a human error done by manual values, as well as like it is a combined app. There is no data security is needed because we have able to downloaded this app into your local software itself. No need a cloud storage, no need a database management system also. And then the proposed system, there is three types of three validation part, like ECU flash comparator and CAN log analyzer and actual value viewer and editor. Actually, here we are going to compare with three files. One is standard file, is a CSV file, and then is a ECU file, which is an input file, and then after input, we have get one receiver, it is called as an output file. The standard file that will be have given from an ECU manufacturers. And then input file, what we have going to dump into a program. That program is always in an hexadecimal codes. And then after the dumping the code, it will be getting an output. It is in a dot log file. Using a CAN log, we have done this. Like ECU flash comparator, it will be compare with standard file, input file, and then output file. And then we can able to get as an output through CSV files. And then here it will be do decoding, processing, and then re-encoding. The methodology of an ECU flash comparator will it's verify the input output versus the standard. Like standard files are always it's always a common. It will be in decimals, but our input file that will be in an hexadecimal. So we want to convert the hexadecimal to decimal, and then here nearly 58 parameters are there. Each parameters has single formulas to calculate all those things. And then we have done this encoding, and then after the encoding, it will do a re-encoding for getting into a normal decimal. That decimal values will be compared to the standard file, and then we can get an output. And then in the CAN log analyzer, it does an encoding a CAN messages and to read. Like we have CAN ID in a CAN log. While we for each parameter, it gives a CAN ID. If you send the message, means it will be giving zeros and ones. Same like that, it will have some CAN ID that will be denoted as a CAN from a CAN log file. And then viewer and editor, it allows to check that values is right or wrong. And then that ECU parameter decoding, it has the decoding methods like programmatic, manual check, and then see in the programmatic we have using a bit masking, shifting, and lookup tables. It is called like it is a one kind of we have like 16 bits of data. We are going to masking a data in like in a method of bit shifting and bit masking, shifting, and lookup tables. And in manual, I have done in a manual. It takes me one parameter for one page. For 58 parameters, it takes too much of time, and then it took more number of things. And then in UDS message decoding, it is a one kind of protocol. And then here it is classified into a 16-bit into a single frame and first frame and consecutive frames and flow control frames. These are the things we have able to calculate from the 16-bit data, and then we get a clear messages. And then service direction. And UDS service direction, there is some of the, like these are the address 0x10 and 0x27 and 0x3E. These are the parameters which is contained inside the ECUs. And then the flow diagram. These we are comparing three files: standard, input, and then output file. The standard file is always a constant. It is in CSV file, and then input file which is in .ecu file, and then output is also in .ecu file. This ECU files are always in zeros and ones, which is binary, and then that programming will be in hexadecimals. And output files is also in binary, but in programming will be in hexadecimal. But the standard file only in decimal. We only compare with decimals. Through that only we can able to find that programming is correct or wrong. This software, I have done a software. This was a lookup of a software. It consisting all those things like what are the time, and then what the parameter and the parameter address, and then what the parameter should want to be, and what the parameter after the input and then after the output. I have done that for ECU comparator, and then HISA ECU viewer. It is one kind of ECU I have tried. The data and then address, as well as what the standard file want to be, and then what the output. It will be show that is that is correct or wrong. If some section was missing or timeout was missing, means the airbag will not come outside. Some of the reasons will be behind this. And thus, these are the literature review. Will be hand over to Anna Suresh sir.
We are from RMK Engineering College, Chennai, Tamil Nadu, India. So actually, we got a problem statement from one of the leading automobile industries in India. So she worked along with the industry professionals. So that problem statement is very simple, but it's very useful for the automobile industries. So particularly, she involved in designing the software tool. So that is not available. So far, the manual tool was manually, the checking and testing process was done. So in order to design this, design and develop this software tool, so analyzing the various papers. So from the paper, the merits, limitations, everything is considered for developing this such tool. So in the first paper, so there is a limitation for research focused, not a tool for flash validation. So, but there is a relevance to our project, supports the importance of reliable CAN decoding, so that we have taken so in our project. Then in the second paper, anomaly detection survey, so there is a limitation for broad survey implementation details may vary from time to time, but the suggests potential future direction, so integrate ML-based anomaly detection that we have given for the future implementation. At present, we have not done this machine learning algorithm. Then the third paper emphasis on IDS, so not on ECU flash validation or parameter editing, but it's whose advanced analysis features we might adopt so later for security and diagnostics. Then in the fourth paper, the statistical approach to develop the engine control threshold for anomaly detection. So it has some limitation, that is the domain-specific threshold, not a decoding or editor way of the tool. So, but useful for defining, so finally identifying whether it is pass or fail criteria after decoding all the parameters. So these are the, let me conclude by explaining the benefits of this project. So she developed, so along with the automobile professionals, so design and develop an integrated diagnostic tool, one tool for ECU flashing validation and CAN log analysis. Then it can automate decoding, comparison and verification of the input and output of the electronic control unit files. Then provided real-time CAN log decoding into human readable, so diagnostic values, so the human can finally understand so whether it matches with the standard input and output files. Then enable actual value weaving and parameter editing using encoding and decoding techniques also introduced. So it reduces manual effort, testing time, and human errors also in the electronic control unit diagnostics. So it creates a scalable and user-friendly platform suitable for testing, protection, and further R&D use. So it has the future scope. So live CAN interface integration and DBC file support. Then artificial intelligence-based anomaly detection also is right for the future scope. Then batch electronic control unit validation. Then cloud-based diagnostic platform also we have planned to include in future. Then it enhanced security and firmware integrated checks also to be done in future. So conclusion, so this is a completely unified platform. So it combines electronic control unit, flash comparator, CAN log analyzer, the viewer, an editor into one particular software tool. So automation and accuracy, as far as this both is concerned, automates decoding, validation, and editing process. So it ensures accurate results. Then fast execution, as she told, completes full ECU validation and diagnostic less than 60 seconds. Engineer friendly also simplifies workflow with user-friendly interface for testing and the technical team. It is very useful for the technical team. So improved reliability, reduce errors, so saves time and enhances the vehicle fault diagnosis also. So these are the references. So thank you very much for the opportunity given.
Any question from the audience? Yes? No? You want?
Then I have a question. So how your tool ensure safe and reliable, so without risking firmware corruption?
Actually, sir, like I have worked with the peoples, like they have given a data. It is in a mask data only, but there is a threshold value between this to this. It is mentioned in a CSV file of standard files. That values within that only I have set it this, and then I have tested in that industry itself, sir. Okay,
so I have any proof that whether you have
yes.
implemented? So
yes,
can you show? Because we have a column in the evaluation implementation.
Yes, sir.
So that's what I'm asking.
Actually,
so you must have something to show.
So others, the next section we can ready.
Okay, next, Janwarnal Islam and team, could you please come forward? Okay, who is the presenter? Okay, you want this?
Thank you.
I have.
Is it? Load was in all. Was you? Okay, thank you.
It's fine.
Can I start? Okay. Good afternoon, everybody. My name is Neeraj Tamrakar. Basically, this presentation is from Rajwal Islam and other team members, but I am presenting in behalf of them, since they are not able to be participating over here. So good afternoon, everybody. My name is Neeraj Tamrakar, and I am from Gyeongsang National University, and my expertise is especially in vision systems, but today I am giving regarding this photonic radar systems. The title of the presentation is Interference Mitigations and Visualizations by PSO, PSO Optimized Multi-Creep Waveform and Selective Spectral Filtering in a photonic radar systems, and this has been done collaboratively by Nanjing University of Aeronautic and Astronautics and University Malaysia Perils and Kathmandu University. Moving on to the content, the content that I'm going to cover would be introductions, simulations model, principle, results, and conclusions. Moving toward the introductions, the proliferations use of the radar in the same frequency bands increases the probability of interference. Because of this interference, there is a performance degradations, and as well as there is a false detections problem. In conscience to the interference, when we talk about the coherent interference, it renders ghost object in radar range profile. So basically the object of the research is to mitigate this coherence interference, occurring of the coherent interference. So there are many processes like signal processing and machine learning solutions for mitigating the coherent interference. But the issues are they are very slow and relatively expensive and heavy hardware. But in case of like compact systems, it wouldn't be useful. So in this research paper, what the researchers have done is they have utilized the particle swarm optimizations to generate the multi-chip rates so that the coherent this interference can be mitigated, as well as it is able to visualize the interference signal as well. So if we see, okay, that is not working, thank you. So moving on to the simulations model. The simulations model scenario is, as shown in the figures, it consists of victim radar and interference radar and the target space for the experimentations. So in victim radars, it has a particles swarm optimizations algorithms, which will be driving the dual drive MZ modules, modulations, which will be generating the corresponding frequency, transmitting frequencies, and the transmitting frequency will be used to localize the target 1 and 2. Talking about the target space, these two objects, target 1 and target 2, are separated with a distance of 2.5 centimeters. Because with respect to the receiver, first object is 3.552 meters, whereas the second object is 3.577 meters. So in case of interference radar signals that we are getting from the IR units, so if there is a coherent interference, in case of general linear frequency modulated detection systems, it won't be able to properly detect these two objects because of the ghost object. So here the researchers has utilized PSO multi-chip frequency. Okay, let's go. So researchers has used optimized multi-chip linear frequency modulations with the help of PSO. So we are exploring basically three forms of this photonic radiations. One is linear frequency modulations, another is arbitrarily multi-chip LFM, and finally optimized multi-chip LFM and their performance. If we see, like if there is a non-coherent interference, then in that case, when the beat frequency is generated, like in case of this graph B, it will be easily separated. So selective separate filtering can easily distinguish between the interference and the object reflections. But if we see the coherent interference, in case of coherent interference, what happens is we can, the peak signals that we receive during the reflections would have the object reflections frequency as well as the interference. So we have to segregate this object frequency and interference frequency. For that purpose, the two methods has been used. One is arbitrary MC-LFM and another is optimized MC-LFM. In case of arbitrary MC-LFM, the slope of the radars is decided by the 3 gigahertz, 15 gigahertz, and 6 gigahertz frequency. Whereas in case of optimized MC-LFM, it is determined by the PSO optimizations. And in this figure, we can see like it is 24 gigahertz minus 24 gigahertz and 24 gigahertz. So moving on to the selective spectral filtering. So when we go from the linear frequency modulations to AM, MC, LFM, some improvements would be there. Then drastic improvement can be seen in case of optimized MC, LFM. So moving on to the result, if we see the coherent interference in the victim radar signals, the LFM, AMC LFM and OC LFM results are shown over here. In case of LFM, we can see there is a ghost targets over here, which has a significance peak value, suggesting there would be a interference in case of LFM. But in case of AMC LFM, there has been an improvement because this ghost targets has been removed, and there is a line space of 1.7 centimeters. And in case of OMC LFM, there is a drastic improvement because there is a difference is 1.8 centimeters, and if we see the DVM also, it has increased 10.75 dB in compared to the 7.13 dB. So apart from the distinctions of the desired radar signals, it is also able to visualize the interference signals also in this method. So if we observe this OMCLFM, then at this point, it is able to find out the reflected radar signals, whereas in another part, it is able to segregate the interference signal as well. This is the main signals we desired, and this is the interference signal. So here, the final results is shown without interference, with interference, and proposed method. Without interference, the object spacing is 2.5 centimeter and line width is 1.8 centimeter, whereas PSL value is 15.72 dBm. In case of with interference, object spacing is 2.4 centimeter, line width is 1.8 centimeter, and PSL is 10.75 dBm. This is because of AMCLM. But in case of optimize, there is the object spacing is 2.4 centimeter and line width is 2 centimeters and PSL value is 14.34 dB, which is very much close with comparisons to the without interference. So MCLFM with this SSF can properly segregate the interference as well as find out the interference visualizations also. Going to the conclusions, new method for coherent interference identifications and mitigations has been developed, which has a PSL of 14.34 dB with 2 cm line width and 1 mm detections error, and it performs similar to the interference-free situations. So it offered unified solutions both for interference suppressions and visualizations. So telling this, I would like to conclude my presentations. Thank you.
So how does this system perform in dense environments with multiple reflectors?
Since I am just presenting this, I haven't have a deep knowledge.
Okay, thank you. Thank you. Good presentation.
Thank you.
Thank you.
Are we going to give feedback right now or not at the end?
We need to complete.
Yeah, I think it's better to complete. I am the presenter. I will complete it.
Sarvagya Buddhachari is the next presenter. Then we will have a lunch break.
Okay. Well, very few left, although anyway. A very warm good afternoon to everyone who still stick to this end, despite of the great hunger. Okay, so, well, I am presenting this presentation on behalf of my research assistant engineer, Susan Hangeju, who actually works as a research assistant on my lab, antenna lab, in Kopo Engineering College. Where I work as a faculty member. So myself is Sarvagya Buddhachari, and our project or the research study is on simulation study of the optimal egg beater antenna design for the low Earth orbit satellite ground station. So that's our. So we will be going through these topics, which I will be going one by one. So I'm not going to invest much time on this slide. So we try to find some of the solution for the low Earth orbit. Why we choose the low Earth orbit? Because in our country, that is what is ongoing. So we have the CubeSats that has been launched, like NepalSat 1, and then the Munal, and then the other satellite like recently launched is like Slipper2Sat and other. So we want to address those fields. That's why we try to do some of the projects on that. So for the low Earth orbit, the challenge is that it is uplink at the low altitude, like just in 160 to 200 kilometer altitude, and so it has a very high speed, around 90 to 120 minutes to circle around the globe. So because of the high speed, it brings the challenge that it has a very low visibility. That means the interface time with the ground station is very low. So to uplink and downlink the signal, it's a challenge. So now to do that, we bring up with the egg beater antenna. That's the omnidirectional right-hand circularly polarized antenna. And so the problem statement is the high speed of the low Earth orbit with the low visibility. And of course, we can use the directional antenna like the Yagi-Uda antenna, but it comes at the cost of the high investment. And it's not compatible when you try to set up any kind of this station at the remote area, especially in the hilly area. That's what we are targeting. And that's why we have to go for the low cost without the tracking mechanism. And in the omnidirectional antennas also there are other options, which I will show in the next slide. And other thing that we want to invent is the antenna that has been designed currently. They don't have the systematic approach. They have used some of the values that have the theoretical computation, but some of the values they have used as a hit and trial basis. So we want to overcome this probabilistic approach of designing the antenna by a systematic optimization through the simulation, so that we can overcome this probabilistic or the experimental guesswork with a systematic approach. So that's where we are trying to work on. So I'm not going to invest much time in this also. So we have done literature review before we jump into the objective. So to briefly going through it, there are many kinds of antenna which have been actually explored. Some of the major type of the antenna that has been used or explored is the quadriflyer helical antenna, Yagi-Uda antenna, and then the egg beater antenna itself. So with the Yagi-Uda antenna, of course, you need the tracking. With the quadriflyer antenna, you have a problem with the helical design and then the 90-degree phase shift. So that's what is the problem. So we try to use the egg beater antenna. That's how we streamline and we deep down to the egg beater antenna. And basically, we try to design for the low Earth orbit satellite, targeting for the pre-existing satellite like the NOAA satellite or the Meteorite M. That's the Russian satellite. So we try to receive the simple weather data and the low resolution image data and so on. And then when we try to optimize the different elements of the antenna, like we try to optimize the loop length, the reflector length, and the spacing between the loop and the reflector, and then also the number of the radials, and the diameter of the loop and the reflector wire. That's what. And while we try to maximize, what we try to obtain? We try to obtain the higher performance for the case of the directivity, for the case of the gain and realized gain, as well as for the case of the S parameter and VSWR. So now, for the directivity, gain and realized gain, we try to get the maximum value that we can achieve. And for the S parameter, we try to get the negative value, the lowest value that we can achieve. So normally it should be less than minus 10 dB, that is acceptable. And then for the VSWR, we try to get the value as much as near to the 1. So that's what we are trying to. So VSWR means the voltage standing wave ratio, that's what it means. And S parameter means the scattering parameter. So in this, we can have other parameters also, but we are specifically focusing on S11. So with that, so our methodology is like we try to come up with the theoretical design for the parameters that we have the equations. For those parameters, antenna elements for which there is no any theoretical design, we try to do from the simulation. So we try to use the simulation environment, and then we use the 3D modeling, parameter analysis, we optimize, and we find the, we conclude with the parameters that we have. And then with that, till now, we have completed the simulation, and now we are based on the optimal parameters that we obtain, we are now doing the empirical design. That means we are actually fabricating the antennas based on that one. And of course, we will do the tuning, and then other optimal values will be obtained, which will be finally verified with the simulation value that we have obtained. So this part, the empirical and verification part, is not included in this paper because it's still ongoing, and we will be including in the future works. So the first is the theoretical design, of course. For the theoretical design, we have the egg-Wheeler antenna. For the parameter that it should have is the loop length, phasic line length that actually gives the 90-degree phase shift, reflector length, loop to reflector spacing, number of radials, and the diameter for the loop and the reflector wire. So for the basic calculation, we have the, sorry. Okay, so for the basic calculation, we have the calculation of the wavelength. And then we have the calculation of the loop length, which has been derived from the literature that I have listed in my references. And then also the phase line length is also derived from the equation that has been given in that literature. And in the case of the phase line length, we have used the RG62, and for that we have the velocity factor of 0.86 that had been used for the calculation of the phasing line length. And then with that, next is the simulation. So initially, at the beginning of the simulation study, we try to use the antenna Magus. And with the antenna Magus, it provides the parametric model of the egg-Wheeler antenna. And we also use some of the recommended setting, like we use the 3-in-wire, integrated equation, 2 ports, and so on. But it doesn't provide us the flexibility in the step size that we can vary while doing the simulation. That's when we trigger to find another simulation model that we can, or the simulation environment that we can use up. It didn't provide us that flexibility that we can use the smaller step size or different parameters that we can include in the simulation. That's why we have to move to the another simulation, that is the simulation studio, sorry, CST studio. And then in that CST studio, we actually can extract or export the parametric design that we have developed in the antenna Magus. And then here, it provides us the flexibility of optimizing the different values of the antenna elements. And we specifically vary the space between the reflector and the loop length. And we also vary the reflector length, number of the reflector length, and like the wire diameter for the loop and the reflector. Those are the things we vary. And when we vary, we try to see and note down the directivity, gain, realized gain, S parameter, and the VSWR. So with that, so when we do the optimization, at first we started with some initial value that was suggested in one of the literature, and with that we optimized one value, keeping other values constant. And then when we got the optimum value, that was used for finding the optimal value for other subsequent elements antenna elements. So that's what we did. And for the empirical design, it's ongoing. As I said, we have selected the copper and 90-degree phase shift for the 62 cable, which we are trying to find tune by using the nano VNA, and we will also check the different parameters with the nano VNA and spectrum analyzer. And finally, we will be doing the verification, which we haven't done yet. We will be doing in the future work. And then for the simulation, there are two sets of the simulation. One for the radial length, and that is the reflectors. Reflector with the radial reflectors, and another one is for the square plate reflector. So those are the two set of the simulation that we have done. So in this case, we have first is the simulation for the reflector length, which is shown at the, if you can see the reflector length mean with the length of the radials, which is shown at the right corner, as you can see. And we have varied the value from lambda by 1 to lambda by 10, and other values are for the initial assumption, which we have been selected from this literature, which they claim that it is the optimal value. So, but we want to check through the simulation. That's what we are doing. So initial assumption, we use the n is equal to 8. That is the number of radial, and then the spacing between the loop and the antenna loop and the reflector, and then the diameter for the antenna loop and as well as the reflector. So for that, we did the simulation, and we found out that the optimal value for the reflector length is lambda by 5. And for that, we obtained the directivity of 4, gain of 3.9, realized gain is 3.977, and S parameter is around -24, VSWR is 1.25. So that's what we obtained. And then after that, we did the simulation. Where I should show? I think you can change the slide for me. You can go to the next slide. Okay, I think this must, can you do one by one? Okay, so otherwise it will unfold my mystery that I have put a lot of effort to do in sequencing. Okay, anyway, so for next one, we are trying to do for the simulation for loop to reflector spacing. That is the spacing between the loop and the reflector. And of course, we put there some insulator like the plastic material and so on to have that one. And then this gap, for this one, we have vary this SRE value from lambda by 1 to lambda by 40, and we have take the reflector length, the optimal value that we obtained in the previous simulation. So we took lambda by 5, that was obtained from the previous simulation, and then we kept the other assumption as it is. So with that, it's not working. Okay, so with that we got this optimal value. That is SRE is equal to lambda by 13, and we can see that realized gain has been increased to 4.5. And we are emphasizing in the realized gain rather than the S parameter and VSWR. As you can see that for the S parameter and VSWR, it is not the minimal value for both the cases, but we are considering this value based on the realized gain, because the realized gain consider these parameters, and this parameter actually provides the value for the reflection that is actually a signal reflection that is actually caused due to the impedance mismatch between the antenna and the port, as well as the antenna and the transmission line. So those are the things it provides, but that is already incorporated while we calculate the realized gain. So that's why we try to focus the optimal value for the realized gain. So that's why we take this value despite of S parameter and VS parameter is not the minimum value. Okay, now it's working. So now the third one is for the number of the radials. We try to change the value from 1 to 20, and we take the optimal value for SRE and LRE that we have already obtained. And then we keep the other parameter as it is. With that, we obtain the optimal value of n equal to 10, which was not the same like when we start with initial assumption. And with that, we could obtain the realized gain of 4.955. After that, we also did for the simulation for the wire radii loop of the for the loop length. And you can see that that's the diameter that I'm referring to. That is for the loop of the egg beater antenna. And then other parameters like SRE, LRE, and N, which was previously optimized from the simulation, has been kept constant. And we keep the other parameter as it is. And with that, we obtain the optimal value at the 0.5 itself. So there is no improvement on this case. So realized gain is still the same. That is 4.955. And we also did for the last but not the least, we also did for the case of the diameter of the radial length, that is the reflector as shown in the figure there. That's what we are trying to optimize. And for that, we kept all the other optimal value that we have obtained from the simulation as before. And then for that, we obtained 0.4 centimeter, but it's not that significant change actually. So we can consider it's the same thing. So here, so what I want to emphasize here is that we started with 3.977, which was given by some of the theoretical literature, which is widely used by many people to design this egg beater antenna. And when we did the simulation, we could get the achievement of 1 dB increment. Although it may seem a little bit increment, but 1 dB means around 20% of the improvement. So it impacts, in the case of the transmission, it impacts in the size of the SPA size that we will use to uplink the antenna. And in the case of the downlink, it will help because considering the low Earth orbit, it has a very fragile signal. So even a 1 dB counts a lot because it will be increasing your power by 20%. So that's why it is significant. It's not significant, but I can say it's a remarkable improvement for the case of the low Earth orbit. And with that, the another case that we did it for the square plate reflector. And for this, we have, at first, we have tried to do simulation for the length of the square plate. It is shown like that. And for this also, we use the copper material that we used for the earlier case also. And then initially, we assumed the SRE and DW that we have obtained from the previous simulation. And for the thickness, we have initially assumed 0.4 centimeter. And with that, we obtained the gain has been the optimal value that we obtained for the length of the square plate is 1.3 lambda. And with that, we can achieve the realized gain of 7.60. And the S parameter, our VSW, are increased, but still it is within the acceptable range. So we can use this value. And we can see that the realized gain has been increased by 2 dB as before. So that's the improvement. And then so now, next is the last one is the thickness. So with the thickness, we try to vary from 0.1 to 1 centimeter, and other parameters are, of course, already optimized. So with that,
we are already late for the track 2, so please do it soon.
How can I do it? So it's gone. Okay, so can you go to the previous slide because I have to emphasize something in there.
Oh God.
I mean, or maybe it's okay. You can put this slide. I can conclude over there. So what I try to emphasize is like from when we change this reflector from the radial reflector to the square plate reflector, the antenna gain was increased by 2.8 dB. And although you can see the thickness is 0.1 centimeter, it's not that how can I say, it's not like a practical thickness. But if you see the realized gain, the variation in the thickness, if you vary, like the variation in the realized gain is at the range of 0.05 when you change the thickness from 0.1 to 1 centimeter. So I think it doesn't impact if you change the thickness. Even if you take 0.5 or 1 centimeter, the realized gain won't change that much. So the main thing is we can get the antenna gain of 2.8 dB more than what we had the radial length. And now considering the 2.8 dB, it's nearly the 3 dB improvement. I mean, it's nearly 3 dB means it's increasing, its numerical value will be around 2. That means it will be increasing by almost 50%. So your power uplink in the case of the SPA, if you are using the SPA for transmitting, it is increasing the power by 50%. That means you can reduce the size of the SPA, which is very much good thing for if you try to set up any antenna ground station at the remote side. So this improvement, I can confidently say it is a remarkable and a very good improvement. So that's what we have achieved. And with that, let me conclude it. So yes, we were able to dig into the common problem that has been ongoing in our country, that is the low Earth orbit. And I want to intervene in the low Earth orbit, despite I have a good experience in the geostationary satellite, because I worked there for 10 years. But once I come back to Nepal, low Earth orbit is the thing that is ongoing here. So I have to work on the thing that is available here. So that's why I started my research in the low Earth orbit, and I try to use this 137.5 megahertz because I'm targeting for the satellite which is already available, like NOAA and Metasat. And then I try to maximize the performance. I try to find the optimal values for antenna elements in order to maximize these parameters like directivity, realized gain, and S parameter and VSWR. For the egg-weighted antenna with the radial length, these are the parameters that we have obtained, which we can proudly share with everyone. Anyone can use this parameter to design their antenna. And for the egg-weighted antenna with the square plate, we have got this one. And the good thing is for the egg-weighted antenna, with the simulation, now we have achieved the 1 dB improvement with the existing parameters that was previously suggested, and many people have used it. So we are able to show that if you do the systematic approach, you can get the improvement. That's what we want to pitch here. And then for the square plate, we have got the improvement of 2.8 dB. So one may argue that you are using the copper plate, so it's expensive. But considering the improvement that you have with this copper plate, that 50% of improvement in the SPS side, 50% improvement in the downlink, that means you are increasing the data rate, that means you are increasing the line of sight, and so on. I think this is considerable. You can accept that much of the increment in the investment. And finally, we have this square plate that we like to suggest. And then the future work, of course, we are designing, and we will be doing the verification, which is ongoing in our antenna lab currently. And yeah, we will finally set up the communication between the LEO satellite. That's our target. And these are the references that we have used.
Any question from the audience?
Okay. No. Yes.
I think I just...
Yeah, you can.
Okay. So number one, you mentioned a lot of improvement on the directivity. What about the bandwidth? That's number one. Bandwidth. Yeah, because in antenna is very important, bandwidth. Number two, how about the radiation pattern? Because I didn't see any radiation pattern that you say you put on CST, but as much as I can remember, CST do allow us to plot the radiation pattern. Thank you.
For the easy question, I will answer first. For the antenna pattern, I didn't include because it's omnidirectional, and since the simulation environment, it gave the perfect omnidirectional pattern. So that's why I didn't thought it will be more impactful to include in the slide. That's why I didn't include it. Otherwise, it has a omnidirectional pattern. But when we try to compare it with the practical scenario, it won't be entirely omnidirectional. In that phase, I can show. But in this case, it doesn't have that much impact because it's a simulation environment. So it is from the program. So it gives the, like theoretical pattern. So that's why I didn't encourage to include that. And for the second question for the bandwidth, yeah, that's very true. That bandwidth is costly, and of course, when I walk in the THICOM, we used to charge for the bandwidth, so I know how much relevant it have. So with that, so when we say 1 dB increment or the 2 dB increment, what does that mean? That means that you are increasing the power, right? You are increasing the power. That means you can uplink the higher modulation. Like you can go from BPSK to QPSK to 8PSK and so on, provided that the threshold that will, provided that the received signal is within the threshold with the 2 dB margin. So that's what we consider. Now, if we are increasing the power, that means you are going to the higher modulation. So if you are going to the higher modulation, that means it will reduce the bandwidth, because bandwidth is equal to info rate upon FEC mode into BT. So that means if you are going to the higher, if you have high power, you can go to the higher modulation, you are reducing the bandwidth. So that means there are two things that you can obtain from this one. Either you can reduce the bandwidth, or you can keep the same bandwidth and increase the data rate. So what you want, it depends upon the customer choice.
I will speak to you later because we are...
Oh, okay.
Thank you.
That's not the bandwidth I'm talking about, antenna bandwidth.
Oh, okay, okay.
No,
Okay.
Thank you.
Okay,
Thank you very much for your presentation. Thank you. Thank you.
Thank you. Okay.
Okay, sir, you are requested to have a token of love. So it's a lunch time. You are requested to have a lunch and come back for the track 2.
Of modern digital systems. Because with the help of this AI layer, we make some intelligent decisions over the data that's been processed in the layers below. And I mean, just to add, language is basically the primary interface between humans, institutions, and technology. Without that interfacing medium, there cannot be any proper interaction between humans and machines. So, and together with that comes the term called inclusion. So nobody should be left out. So in that respect, sometimes technology can even create the divide until and unless the inclusion is basically part of the design itself. It should not be something that we engineer afterwards. And interestingly, this language barrier, meaning somebody, basically predominantly the internet and the other technologies are in the English language. And because of that, there is this language barrier, meaning that the majority of the population cannot really take the benefits of technology because they don't know the language, right? So digitization without understanding creates exclusion. That's the point here. And access is meaningless without interaction in native language. So if we basically provide this technology in the native language, then there will be a greater access and understanding of and use of the technologies. So inclusion in that sense must be a first-class design principle. As I mentioned, it should come primarily in the design phase itself. And what inclusive digital transformation really means? So what is it? So what makes these technologies or this digital transformation really inclusive? So there are these 4 pillars that define inclusion, and that is defined by access, participation, representation, and equity. So access ensures that there is universal availability and connectivity. That's access. And equity determines that the system barriers for fair outcomes are addressed, so that everybody gets a fair access. Just because somebody knows the language, I mean, it does not get a double advantage compared to others who don't know the language. And then the participation thing, it enables active and meaningful engagement. And the representation reflects all communication and identity. So in order to have a very inclusive digital transformation, we need to have these 4 pillars really addressed. Okay? So, however, unfortunately, the ICT, the conventional ICT-driven digitization seriously falls behind these 4 pillars in terms of addressing the equitable access and so on. And in that respect, in order to make an inclusive digital transformation, AI and NLP has a unique position, which basically helps in basically narrowing down the rift, or does not widen the digital divide, rather it basically bridges the digital divide. So NLP is in fact bridging between humans and systems, right? So we have all these multilingual NLP, for example. We have complex digital systems, and but the problem is the users are from different languages. So there is this multilingual NLP, natural language component, which basically helps to access these complex digital systems. So it's not just not just multilingual NLP, where NLP is basically made available in multiple languages, but we do also have these speech technologies, which can also basically help for example, the visually impaired, so they might have difficulties typing with the conventional input systems like keyboard. Rather, but then with these speech technologies, they can basically just read aloud or provide some voice commands, and then hence get access to the systems. Then we have this conversational AI systems, which we can basically visualize as chatbot systems, which can help us with certain expert answers. And there are diverse communities with diverse cultural backgrounds and linguistic backgrounds as well. So in order to facilitate the digital transformation or digital access to all these diverse communities, we need a whole lot of technologies which have AI and NLP basically addressed or embedded within themselves. So as you can see here, some of the examples that we can relate to are governance and public service delivery, which necessarily involves the communication between the humans and the machines. And education and digital learning platforms, there too, mother tongue language, for example, mother tongue education, for example, certainly makes some sense. With healthcare information access, that's another crucial thing. And citizens engagement and feedback analysis is also equally crucial, where AI and NLP can help us. And capabilities are driving inclusion. So these are some of the capabilities if we build in the digital systems that will drive the inclusion process. So we have multilingual processing in place in speech interfaces, conversational AI. If these three things are basically in place, then they would basically help us obtain the inclusion. And there are other vital services where too these AI and NLP will basically be very vital, very crucial. For example, in the government, automating citizen feedback analysis, for example, where we make use of the sentiment analysis. And in education, where we provide personalized learning in local dialects with the help of AI and NLP. In the healthcare, accessible medical info for rural areas. That means in their particular languages. So there's quite a bit of opportunities for emerging economies, whereby we have unique linguistic landscape. So Nepal basically has 120 plus languages. So these languages would require some unique solutions because they are written in different scripts, and basically they have their own grammar and own way of interpretations. So the goal is we empower local language governance and policy support. And with that, we are gradually shifting or moving beyond high-resource English-centric models. So we don't necessarily just rely on the English-centric models, which we tend to use at the moment, but then gradually the shift would be towards local language solutions. So there is this ecosystem of chains. As you can see there, we have the academia, government, and the industry, and all three need to come together. As you can see there, within the intersection, we have sustainable socioeconomic impact. So academia, that's the powerhouse of knowledge, and research and innovation basically happens in there. Whereas the government would facilitate in terms of policy and regulations, and then the industry would basically scale and deploy the solutions. There are definitely risks there are definitely risks and challenges. So these risks and challenges in terms of coming up with AI and NLP solutions constitute a lack of trust in the first place, because people might have some trust issues with these deep learning or AI models, because I mean they are not aware about how they are functioning. So that might appear to them as a black box model. So that's also one of the issues. We have algorithmic bias that's very prominent, which basically replicates inequality. And the other biggest problem is the data scarcity. So there are languages which basically suffers from even basic corpus and basic tools. So without with all these three challenges, the AI solutions basically sits on top of all of these challenges and scarcities. So I mean it's quite a challenge at the moment to realize that, but gradually we can move forward with that. So data scarcity and quality issues I've already mentioned, algorithmic bias and fairness, and the other thing related to black box model is this explainability, trust and accountability. So ethical, legal and policy considerations also need to be in place. So that brings us to the need for context-aware and human-centered AI design. So earlier I was talking about this inclusion needs to be in the design, software design itself. Now I'm adding one more thing to that we need to have some context-aware and human-centered AI design in the software itself. In the ethics and government side, definitely we have this human-centered as one of the axes there. And we have responsible deployment, innovation with accountability, context-aware design, respecting local norms and legal frameworks, ensuring data privacy. So as you can see here, in order to have an ethical AI or some AI that can be governed in an ethical manner, we need to have all of these four things addressed. About the priorities in the future, so basically first and foremost is we need to build some local capacity and local talent. For that we need to go for capacity building and talent locally, leading to policy alignment as well. The government, academia and the industry need to align with each other in terms of policy. What type of AI systems are we developing? What types of NLP systems we are developing? And gradually, that will lead us to the global collaboration, because definitely we as a nation, we don't have those computational resources, and we don't have that the state of the art, all the models and everything. But then we could use the available state-of-the-art models, which are open source, necessarily open source, and gradually build in to develop our own local solutions. And that's the ultimate goal would be AI and NLP should not only make systems smarter, but societies fairer. So here I'd like to stress on the fact that AI and NLP has a special role in making societies fairer and more transparent. Thank you. That's all from my side.
Once again, I would like to express our sincere gratitude to Professor Balkishan Bal, Associate Dean, sir, from School of Engineering, Kathmandu University. Before wrapping up this plenary talk, so if some audience member have some question, so you can ask some question to Professor Bal. Thank you.
Thank you, Bal sir, for this elaborative presentation. So I want to ask about the government's role, because currently, as you mentioned, we don't have this infrastructure for running this AI models. So what do you think we need to go ahead in future? So what are the things we need as a government, as an academic institution? What are the needs for this infrastructure and all these things? I want to ask about that. Thank you.
Yeah, thank you. So Okay, so as I said, I also represent the AI Regulatory Council, to which I am an expert member. So we have been looking into, through the policy itself, we have been looking into trying to establish these AI excellence centers in all 7 provinces of Nepal. So we are in the process of defining the parameters for the excellence center, and that basically that guideline of the AI Excellence Center would define the sharing modality and how the government, industry, and the academia would come together to realize the center as well as the sharing of these compute resources, but because that's very crucial. So the government might come up with some adequate policy so that, and the academia and the private agencies would basically work together to develop some modality and how these resources could be made available. Maybe it could be through some subscription basis as well. Researchers might need to pay some little amount, but the goal is that we don't necessarily just keep the resources within ourselves, but try to share it across the country. So that's really the plan. It might take some time. It might take some while, but we are in that direction. Thank you.
Anyone from the audience? Okay. Thank you. If everyone is satisfied, then I would like to thank you again. And then I would like to invite you to collect your token of appreciation. And I would like to invite the co-chair as well for this event. Thank you. Okay, so we'll start our paper presentation session. So we'll begin with paper ID 10, design and implementation of the mobile-based financial management system with machine learning-enabled spending expenses. The authors are R. Prithi and the team. So you'll get 10 minutes to present your work. Thank you.
Good afternoon, my dear professors, researchers, and delegates who are gathered here. Myself, Prem Kumar, from RMK Engineering College, Tamil Nadu, India, and she's my teammate Preeti. We are going to present our paper. Titled "Design and Implementation on AI-driven Financial Management System," which is a mobile-based application. And our system is mostly, actually we are going to do the financial expenses are tracked traditionally by using manual methods, by using records and analogs. So that will take more lot of time. So we are planning and using AI and machine learning so that we could easily track our expenses and using calendar APIs so that automatically we could track all those expenses, and we will be able to save our expense, our money, and the working methodologies and machine learning and reinforcement learning will be explained by Preeti. Thank you.
Okay. Here actually we have using that, what is the problem here means we have decreasing a savings and increasing the expenses. Here, like the research survey that is taken in 2025, 70% of adult like Gen Zs are expenses more, like rather than savings. They have no emergency savings at all. So we have planned to build an app because only for a saving, and then there is 3 categories of peoples, like savings, they will save a money, as well as, or they will save as in a gold, or as in a save as in a land. And another type of peoples, they will do an expense in expensive things, like which is like not that much necessary one. And some peoples, or like middle class peoples, they will expenses will be within like what they want to need and what they want to spend, they will think and spend. So our app is built for all those kinds of peoples. If like here, if the person want to fix a target, if I'm a middle class people, I will think that I want to buy a car for within a 1 year, or in a day, within a month or two. Like what the target will be. 15 lakh is in a target, means it was in a target, and then according to the target, and then how much, how we want to save the money, and then according to a salary of a person, it gives a classifications. Like if you are connected to an account like GPay, etc., means through here we are using a 3 machine learning models are there. Like here we are using support vector machine for a classifications of a data. If you are booking a cinema theater or something like PVR cinemas, it is come under entertainment category. So it is categorizing a data into like categorizing a data, like it is under entertainment, or in a food, it is on a groceries, or in hospitals like data, it is classifying doing an during of support vector machine. We have taken as a data approximately 6 months. According to that, we have classifying, and it is work, and then predictive, and then in some cases, like we can set the calendar. If your anniversary is on next month, so you want to gift a expensive necklace or anything to your wife, you want to save some money to get that. Immediately we can't able to buy all those things. So through NLP, like natural language processing, and then here we have using a calendar. So we able to fix a date. According to the date of an occasion, we can able to save a money for that occasion. So that we can't able to we can't able to do that. No much amount is needed, and then we can able to plan accordingly. And then reinforcement learning. Here, long-term investment. If you are buying, if your target is 15 lakh, your savings today will be 5,000, and tomorrow it is 2,000. It is maybe less than or down. We can't able to predict that. So that we have including as a reinforcement learning. It is like it will be learning through your data, and then it will be give a predicting date month, or it will give approximate date. Till this date, you can able to do all those things. And then this is a block diagram. This is one of the software app. First, you want to log in, and then through this login, it will be going to check your all those GPay's account, everything, and then it classifies all those things to a support vector machine, and then it will be going to an NLP to check the calendar, and then etc. As well as it will be continuously training. We have using a reinforcement learning. It will be done continuously, and then give a target amount. These are the outputs we have done. Like we have trained a model, and then it gives the expenses of expenses in a pie chart. Where we have expenses done and expenses, like food means like orange color, and then where you have green hospital sites. So these and all the expenses what we have done, it is categorized and given in a pie chart. And then these are the working, like first classification of SVM model, and then it is like we are input a salary, and then we fix the target. According to a salary and then fixed target, it will be going to process our monthly savings. How much we want to save. This will be done in an SVM model, and then predictive forecasting model for next. The time series forecasting model runs analyzing and next 6 months of an, like it will be taking a last 6 months data to process a next 30 days. And then prescriptive decision making, like according to your savings, it will be giving allotted time within 6 months or a 7 month. According to your savings, it will be giving a time within a prescriptive decision making. And contextual budget assessment, like doing that NLP calendar, with integrating of an NLP calendar, it will be allocating occasions for savings. And then these are the advantages, like here we have using a target to save all those things. And then we have emergency saving, as well as we can able to drag all those things, and we can maintain our expenses through no manually in a system, as well as we can able to less expenses, and then we can save more amount. In a conclusion, here overall in India, like these are the peoples will be doing expenses rather than savings. It was too higher, and nowadays the Gen Zs are most in expense. They are expenses in expensive things. So we have trying to do that. Like expenses things is also okay. It is not every time. It is sometime. And then here we have here we are doing a job of saving, like advising that to save money, more money for your emergency cases, as well as for your future uses. And these are the references we have taken. And then video. Can you play a video? Actually, we have trained a model.
So you have 1 minute, okay?
Sir?
Last minute remaining.
Yeah.
1 minute remaining.
That's it, sir. This is a video. That's it. These are the workflow of work we have done. This is a software which we created. This is a dashboard. Monthly salary is 50,000. How it is going to allocate it, expenses, and then the date. According to the date, how the expenses was classified, how it is going to. These all those things it will be shown as in a pie chart as well as graph. And then it will give a recommendation how we can able to save money, and then how we can to reduce expenses. Thank you.
Okay, thank you very much. The presentation is completed in the time. So if the audience have some questions, and the floor is open. Any question?
Any questions?
Thank you for your wonderful presentation. I have one question. How your financial track will save us our money? Because you have used many times, it saves your financial condition, but how it saves it? You haven't shown that reason.
Actually, savings is in our hand only, sir. It give only suggestion for us to save this. Like, we only want to follow all those things, rules. Rules is there. Follow is follow. It depends on us.
Okay, thank you.
Through reinforcement learning, sir.
So,
thank you for a wonderful presentation. My question is how you are going to implement that reinforcement learning. You haven't talked or discussed about that specific detail here in your presentation. What you are taking that feedback, let's say you have a model, you input something, it predicts something, then there is reinforcement happening,
Yes,
isn't
sir.
it? So how that feedback loop is working? Can you explain that?
Like, it will be doing at a real-time process. If your savings is, it is monitoring, like, today my savings is 5,000, and tomorrow my savings may be at 2,000, or it's more than a 5,000. According to that, it will be analyze all those things. We have certain trained data.
One particular thing is missing, what I suggest in your future work you can include? Because every person has a different target, isn't it?
Yes,
I
sir.
want to purchase home, let's say the person wants to purchase a car. So they might have different parameters beforehand with which they can configure the application, isn't it?
Yes, sir.
So after that, the prediction should derive the expenses toward his goal, his or her goal, isn't it? So that I don't see clearly in your presentation. That is only my suggestion. In future, you can work
sure,
it out.
sir.
Another important thing is in a family, like in South Asian region, generally like we work together as a family, isn't it? So different person will be expending money in different through different application. So how you are going to integrate all those expenses together
Like-
for a family goal?
For a family goal, like like you are saying that you are also earning, your wife also, like I can't able to, can you?
Let me give
Uh,
Supposing you are a daughter of a home,
Yeah.
so mother asks you to purchase grocery, isn't it? So you will go and purchase grocery.
Okay.
That is not for you, but whole family, isn't it? So if you frequently do that, then your application is going to show high expenses in grocery, other than other expenses, isn't it? So how will you cope with that problem?
Okay.
So maybe in future, we are planning to integrate for a family, as you said, father, mother, and sons or daughter. We will be connecting all those, all those accounts. All those accounts will be connecting and make a common category, sir, for each of the things. For mom means, for example, she spends mostly on groceries. For son means he spends most of his money on games or entertainments. Then what we'll be doing is that we'll be connecting all those data in a single common platform, sir, so that we'll be use it to analyze and track as a single family. Yes, sir.
And then we can able to do us in a group of accounts, like we can able to make us in a group as family into an also it is a software we can able to do anything.
Okay, thank you very much. So I request next presenter to present his or her work. So next is paper number 88, deep learning based vegetable price forecasting for Nifty's markets and STL attention LSTM approach by Pranay Nakarmi and the team. Thank you.
Thank you.
Good afternoon, everyone. First of all, I would like to thank you, the ICTP team, for giving this opportunity to present our research. My research topic is deep learning-based vegetable price forecasting for Nepalese market and STL attention LSTM approach. And I am Pranay Nakarmi from SN College of High Studies, and with my colleagues Navin Lamisani, Navraj Subedi, Janak Kumar Lal, Pravin Paudel, and Vikrant Paudel. As we all know that Nepal is a landlocked country and agricultural country. Agriculture plays a vital role in our Nepalese economy. It shows that agriculture contributes about 27% to the Nepalese GDP, and most of the employment of the 66% is provided by the agriculture for the Nepalese people. And besides these numbers, it is critical for the food security and it plays vital role in the economic stability. Agricultural sector contains numerous of challenges. The first challenge is that the high price volatility in vegetable market. That means the price fluctuates in a short period of time. And another problem is the information asymmetry between farmers and consumers. And also the challenge is that it lacks of the practical tools for the informed decision making. For this research, Kalimati market poses a critical role because it is the Nepal's largest wholesale vegetable market and it is the central hub for the price discovery. This Kalimati market plays significant in such that the overall price of vegetable in Nepal depends upon this hub. So it is necessary for the accurate price forecasting development in the Kalimati market, and it helps farmers to plan production and assist policymakers in market stabilization. Okay, let's talk about the problem statement. The problem statement, as already said, the challenge is that the vegetable price fluctuates by 20 to 40% seasonally, depending upon the weather, season, it depends and fluctuates. Rather than the price, it also depends on the supply and demand dynamics. Vegetable price is more dependent on the weather and it is also dependent on the festivals. In the festival seasons, the vegetable price rises, and in the other days, in the condition of weather, when there is the rainfall, the vegetable price rises. So it is the major challenge that to integrate these features. Previously, there are the traditional methods like ARIMA have done the vegetable prediction, which only captures the linear patterns. It does not capture the complex patterns and non-linear patterns by the ARIMA. So it is our challenge to make accurate deep learning model by combining the statistical decomposition, deep learning complex patterns, and the contextual features like festivals and weather. So this gap highlights the need for the more integrated and intelligent forecasting approach. Based on the problem statement, there are the three primary questions. The number one is, can we build accurate forecast for highly volatile vegetable markets? Another is, can we make deep learning interval for agricultural stakeholders? And the last one is, do different vegetables require different temporal patterns for prediction? Based on the research question, we have developed the framework for this research framework. Let's zoom in this. For this research, first step is, of course, the data. Data is taken from the Kalimati market, and the data is further divided into the seasonal trend and residual by using the STL decomposition, and this is also integrated with the weather and the event data. Further, this is converted into 9 features and the time stamp of 60 days is taken. After the collection of data and integration, we feed this data into the model generation, and the model for the model we have used the LSTM. 2 LSTM network is used, and after the feeding the data in the LSTM, the attention layer, the most weight parameter is used in the attention layer, and after this the dense layer is transferred, and finally the price is predicted. Talking about the data, the vegetable data is collected from the Kalimati market. This is the secondary data taken from the Kaggle, and for the weather data, we have taken this from the Department of Meteorology and Hydrology for the data. It consists of the features, temperature, humidity, precipitation, and wind speed. And for the calendar events, we have manually generated the data by collecting the data from the Nepali calendar, Nepali Patro, and the Rajpatras, which is given to us. This is the characteristics of data. In the total, there are the 4 to 117 days of data. And for the vegetables, we have taken of the 5 vegetables: potato red, tomato local, cabbage local, cauliflower local, and the radish local, because of the data availability to us. And the data taken was till the June 2025, but because of the weather data till 2024, we have squeezed the data into till 2013 to 2024, and the total data is 4,217. After receiving the vegetable data, we disaggregate this into the trend seasonal residual by using STL decomposition, and it is integrated, as already mentioned, that we integrated with the vegetable data with the weather and the calendar events. And after the integration, the data integration, we have done the normalization using min-max scaling. And after the normalization, the sliding window is created. The window was used is 60 days. And by using 60 days, we have generated the 4,157 sequence of the 9 features. And later this is converted, it is split into trend, validation, and test of the 70:10:20. And after this, the sequence is passed through the LSTM network. The 2 LSTM network is passed to prevent it from the overfitting. And then we have passed it into the attention mechanism to gather the most important weightage parameter for that. And these 2 hidden parameters from the LSTM and the most important weight from the attention mechanism is transferred to the dense layer, and finally the output is predicted. For this model training, we have used the Adam optimizer with the initial learning rate of 1%. Loss function is used as mean square error. We have set the parameter for the 100 epochs and the bias size of 32, and the matrix is mean absolute error and mean absolute percentage error. And the evaluation matrix used are RMSE, MAE, and R square and MAPE. This is our result. Based on the result, we have generated the R square of 88%, 0.88 for potato, 0.886 for tomato, 81% for cabbage, 75 for cauliflower, 83 for radish. And in aggregate, we have generated the R square of 83.3. And this is the output showing the actual and predicted price prediction. And this is all for the 5 vegetables. And finally, in the attention mechanism, which vegetable is dependent on which time frame. For the potato, it shows the time frame of the 20 weeks. Up to 3 weeks, we can say that in the meantime of 3 weeks' time, we can generate the price at that time. For the potato, for the different time, it's different for the vegetables. And based on the results and the model generation, we can say that we have developed the deep learning-based, attention-based mechanism for the vegetable price prediction with the data of 11.5 years, and the model predicted R square of 0.833 and the mean absolute error of 15.67%. Thank you.
Okay, thank you very much. Okay, so the floor is open for the audience member first. So if you have any question. Since there is no question, so I will ask. So you can ask. First.
First of all, I need to clarify something. Like, it's a very interesting topic, and you have used so many parameters. Whether you have included road blockage or, let's say, supply of one specific crop in that particular season as a feature or not?
No, I have not used any of that features. That in the rainy time, just look out for the price only. In the rainy time, the price increases. In the festival time, the price increases. That was seen through the vegetable price only.
Because as you see, like it's a simple economics, demand, supply. If there is good production and there is no blockage of road, then supply will be there and price will go down automatically. So I think that is one important factor you should include. Another important thing is, as you are using data of 11 years, have you included inflation also in that?
No, I haven't.
Because the cost of potato 10 years, that would be different from the current. Yeah. So you have to include that inflation also in that experiment. So thank you.
Okay, so I have one question. So can you go to your methodology slide? Okay. Okay. So, what is the, okay, so this one. Next slide, okay. So slide number 9, I think. This one, yeah.
This one?
Like for this one. Okay. So what is the base for choosing dense layer as 64, 32, and 1? Is there any baseline study, or you are just using as a pipeline?
As pipeline only. It is followed by the batch normalized.
So thank you very much. Okay.
Thank you.
So thank you, presenter. So next presentation is paper number 149, enhancing pharmaceutical sales forecasting using CNN LSTM model with seasonal smoothing. Okay, so we'll move ahead. Paper ID 134, secure aggregation enabled federated vision transformer framework for tissue image analysis by P. Jayaraju, Narendra V. Mustari, and the team. Okay. Okay, so we'll wait for them. Okay. Okay, so we'll continue from paper ID 145, impact of AI-assisted online compilers in programming education by Amrit Paudel and Pratik Rest. Thank you. So you'll get 10 minutes, okay?
कि मेरोबाट भन्नु म सजिलो हुन्थ्यो होइन त यहाँबाट हुन्छ हुन्छ ल चाहिँ जोडिन्छु म एकछिन हुन्छ भन्नु म यसको नोट्सहरू थियो कि त्यो अलिकति स्ट्याटिस्टिक्सहरूको त्यही भएर
Good afternoon, everyone. Good afternoon, everyone. My name is Amrit Pode, and today I'm going to give presentation on my research. The research is the collaboration between the AI and programming education. Talking about, we know that talking about computer, okay. Talking about okay.
Hello.
Okay. Talking about okay. Okay. Computer programming is a foundation skill in modern computer science. And despite its importance, we know that for the Normans programming students, it is quite difficult for them to catch the programming skills. So that like the problems for those students are caused due to lagging in or difficulty in understanding compiler errors, programming concepts, and more on debugging techniques too. And we know that the traditional idea that we use for the programming education, like DEPC++, lack real-time personalized feedback for those learners. So in the modern time, different AI compilation tools were available, and these tools helps students to better understand the compiler errors, helps them to guide to know the abstract concepts of programming, and but we know that these tools lack a proper but the resource regarding the impact of those tools on students is quietly not done. So to fulfill these gaps, we use one AI tool that is process feedback, which is available online through processfeedback.org. And this tool provides the features like explainable AI feedback, which provides the explanation for the syntax and logical errors. And also, it also tracks the students' record on programming tasks, and also monitor copy-paste events, and auto-generate the PDF reports. So, from previous research also, it was found that students face difficulties in programming education. due to cryptic error messages and debugging. And it was also found that LLM will support the programming too. But there is a there is a problem that overuse of Gen AI tools is quietly a problem in current scenario. So to fulfill this gap, this study addressed with a data-driven experimental approach to understand how AI tools actually impact the programming education. So the objective of our research is to evaluate the effectiveness of AI assistant tool, processfeedback.org, in enhancing coding proficiency and improving overall academic performance among first semester C programming students of Gondak University. This was our study design. First, the participants of our research are first semester C programming students of batch 2024 of Gondak University. There are altogether 48 students. And before the study was implemented, the students were undergone the midterm examination of 50 marks. And we assigned the students, after that, we assigned the students into two groups. One is experimental group. Half of the students were assigned there, which were using AI assistant tool process feedback for the rest of their lab sessions. And another group is control group consisting of 24 students. And they are using DevCPP, which is a traditional ID that we use during the programming lab sessions. And after performing the lab sessions, these lab sessions were taken parallelly in two laboratories with same lab tasks at the same time. And after performing randomized control trial in this scenario, we want to evaluate how actually both tool have impacted the academic performance of the students. We performed the post-midterm or interim result, interim examination of 50 full marks. And another is we took coding assessment practical lab exam consisting of 10 full marks. And those data were collected and comparative analysis were made. The students' performance was evaluated in two domains. One is in theoretical improvement score, which is the difference between the interim score and the midterm score. And another is coding assessment score. And we obtained the following results. And before performing any hypothesis test, we performed the normality test. And we found that the control group, in the improvement score, theoretical improvement score, the control group does not follow the normality. However, other groups in improvement score and both coding assessment score follow the normality test, and they are passed in those tests. And due to which we perform the main Whitney U test for the theoretical understanding, that is improvement score, for improvement score, and for practical proficiency we perform the T test. And the effect size is evaluated using Quinn's D, which is found 1, which is quite large. And the relations between the theoretical understanding and practical proficiency was evaluated with Pearson correlation. With the and the result obtained was R equal to 0.68 for B less than 0.001. And we found that the strong positive correlation with correlation coefficient R equal to 0.68 between the coding assessment score and theoretical improvement score. And from that, we can interpret that students with the higher practical coding proficiency tended to show greater theoretical improvement. And it also indicates that coding performance is a key contributor for the theoretical gains. And the large effect size of 1 shows feedback approach has a practically significant effect on learning outcomes is we know that process feedback provides the feedback to the students in real time. And which ultimately highlights that feedback is a critical pedagogical intervention. And we can conclude that process feedback tools greatly improve the students' performance, and better coding skills were linked with higher theoretical exam scores, and using AI tools like processfeedback.org can be used for the programming education. For future works, we need to investigate long-term retention of skills acquired through those tools, and we want to explore the tools' effectiveness across different programming languages. Initially, we are doing only for C programming language, and we want to conduct studies with larger and more diverse students populations, because this is only done in the context of Gondek University for single batch. So generalizability need to be validated. And for the acknowledgement, I want to thank Gondek University for providing grant, and the process feedback team for their technical support and guidance. Thank you.
Okay, thank you very much. So, anyone from the front has any question? Front.
Can I ask a question?
Okay, sir.
Okay. In your study, I think you separated the group into control group, and one was the other one. And was the pure coefficient the only metric by which you made your conclusions, or were there other metrics as well?
Is the number of students divided into two groups, one control group and experimental group, but the number of students is limited to 24, what is quite few for performing RCT trial. So to validate this, in current year also, I am dividing the students into further 24 and 24 in group for the next batch, and this will help ultimately to generalize and use other hypothesis tests too. But due to the lack of limitations in student size, I cannot perform other tests.
Fair answer.
My question is, it is only for C programming,
yes,
and we do have online application of C programming.
Yes,
and what is the use of AI in C programming?
Okay, this tool is normally to help students to understand the programming concepts and compiler errors in C programming, because in process feedback there are two features. One is to explain the error message, and another is to explain the entire code. These two features are used sometimes when there is a syntactical error, we normally get the compiler error messages, and that will be explained through explain error feature of process feedback. And sometimes there will be some logical error, but there will not be syntactical error. In such scenario, that explain entire code feature, which is the AI feature of the process feedback, that will significantly boost the students' understanding in knowing programming. Okay.
Thank you for highlighting the use of artificial intelligence in teaching and learning.
Thank you,
probably it will be used frequently in coming days in every sector, every discipline. But one question, I was wondering how you did implemented. So this particular experiment is done on midterm or final evaluation, yes. Can you say?
Yes. That before implementing RCT, we want to know how much the students understand the programming concepts. So to know how their understanding in programming, we perform the midterm examination. Normally it is done when we understand that algorithm and flowchart section. After completing the algorithm and flowchart section of programming, that is conducted after that. And after that, we will continue, while teaching, we will continue with the control structures, loops, functions, arrays, structure pointers, and we'll perform the practical sessions. After completing midterm, students were randomly divided into 2 groups and RCT were implemented. And before the end of the semester examination, we performed the interim examination for the students to how that tool improve the students' understanding in programming. So that we we took interim examination.
Now my question is,
yes, sir.
You have 2 groups, 24 in one, another is a 24 experimental and control group. So if the ability of those students is different from the initial phase, because like we sometimes see as a teacher that one group performs comparatively well in all subjects compared to other groups, and that is a usual case. Yes. So did you compare their performance in other subjects in relation to the experiment what you carried? Because like just the comparison between 2 groups is not sufficient to argue that it is boosting the performance of a student.
Normally this tool is implemented for programming and it is performed for C programming only. So we perform for C programming subject only. But to understand their improvement, we perform the difference between the interim and midterm exam score. So the difference in their scores really highlights that the difference, the improvement score. The improvement score is higher to those students who uses a process feedback tool than that of using that DevCPP tool.
Okay, thank you very much. Okay,
thank you, sir.
So we'll start next presentation. This is paper ID 94, a multi-class fault type classification using sequence component and wavelet features with comparative study of machine learning models and neural network by Santosh Kumar Chaudhary and the team. Thank you. And next is paper ID 134. Okay.
So, good afternoon, everyone. Respected chairs, co-chair, and everyone present here. First of all, I like to thank to ICTP 2026 for providing this opportunity to us to share our work in front of you all. So, it's me, Santosh Kumar Chaudhary, from a final year student from Nepal Engineering College, going to present our work on multi-class fault classification using sequence component and wavelet comparative with the machine learnings and artificial neural networks. These are our co-authors. And without any delay, let's move to the introduction. So basically, transmission line is a very important part for the power system. And in the transmission lines, faults occurs. So to cure the faults, we need fast and accurate identification and detection to correct the faults. And for that, we need to build up a good and reliable system for the fault classification and decision. That's our main goal for this work to complete. So in traditionally work, many systems are being built, but specifically for similar some types of faults that are being used for to identify, but mainly system works are done on for the transient or imbalance class. Both at the same times are not well organizedly done. So that's one lacking part of this society. So main aim of our project is to build a hybrid transients and imbalance data sets to train the multiple models and comparison between artificial neural networks and multiple models and to get a best one to good approach. Sorry. and for the identification and the fault classifications. And doing my research work, I have gone through the different papers, and we have got that many models, many papers was from the ANN models and different papers, but ANN models were failed due to needs to use data sets, and many of the paper were gone through were using only the transient signals, and many were using the imbalance signals. So our work is focused on both hybrid and transient and both signals. So our methodology is first we build up the system on the MATLAB simulating model. Then we simulate different fault scenarios on models, and we extracted the data generated. And we take out of some extracted features of voltage and current, and we split the data in the standard 82 and 20 ratios. And we go through the different machine learning model, and we get the accuracy on different models and different additional. So this is our model on the MATLAB simulation, where there are 4 buses. And first and second buses are act as generators, and middle 2 buses are 11 kV with the static loads of 15, 10, and 5 megawatt respectively, and along with a 100 kilometer difference of transmission line system. And in each time of fault duration, we have used a 15 ohm fault as a fault resistance. So the data set was different type of fault, like line to line fault, line to ground fault, 3-phase ground fault, and 3-phase fault. And also we have taken the normal condition of the power system, as we used as a fault no fault as a data. And we extracted the voltage and current signals from each scenarios, and we uses data for our sequence and wavelet calculations. One of the main part of our work is a feature extraction. So when we extracted the voltage and current signals from the MATLAB simulation, we used that for the sequence to cover up the imbalance signals, and we used wavelet Da Vinci's for DV4 is applied for the transient signals. So by this both we can capture transient signals and imbalance signals at a time, because the fault can occur anytime, and its signals varies up and down at any moment. So it's rare case, it's very. So we have applied both transients and imbalance, so less chance of the missing of the reason. And these all models we have used for training about data sets which we have generated from the model cells. So that is decision trees, random forest, exhibitions, and artificial neural networks. So our result overview, while performing all the models we got giving a same data set to every models, we got a best accuracy on the random forest, that is 97.58. And nearby XGBoost was also nearby to the accuracy is 97.36, and we got a less performance on ANN model, that is 88.123. So we conclude that random forest was the best accuracy in these scenarios. So these are the comparison metrics of our modelization. So mainly all data are not confused by the model, but in the 3-phase data sets, mainly models have been confused. So this is happens due to the fault in the 3-phase, and 3-phase ground and 3-phase fault are mainly similar type little voltage ups and downs. So model gets usually confused and reason, but in decision trees that's quite good. So in the decision, we build an hybrid extraction features for the developing a model where decision trees perform very well. So in conclusion, our work has developed in the model and deep learning model, that is ANN model, and we come to end that decision trees will perform very well, and that's the proposed methodology. In future, we are planning for the use in the real world data, and we are trying to we will implement in a real field and real protection schemes. So basically, the model will got verified. We will use in this real field, so that will help in the contribution in the power protection systems. Thank you for the listening.
Okay, thank you very much. So we'll start from here. So if you have a question, and then
Okay, I will ask a question then.
Okay.
So you have done the simulation in MATLAB, correct? You have not done this on a physical system?
Yeah, we are planning for the future works for that. First of all, we verified for the simulation model.
So what will be some of the steps in order to transition from simulation to actual reality? That is one question. And another question, you said hybrid features, but what exactly were those features? I don't think I got it. So if you could explain that, that would be it. So those are my questions.
Okay, sure. So basically, I will answer first hybrid features. So I call that hybrid features because I'm using a sequence component. So in sequence component, we are using a positive, negative, zero sequence. So that is the one features. And other features, I'm using a wavelet. So basically, the sequence components helps to identify the imbalance signals, which usually is false reason. But in model system, like for example, we used to in a house, first we guess as this, suppose there is two houses. We observe that one house is observing 10 megawatt daily, for example, and second house observing 10 megawatt. But suddenly the load become dispute. And that may cause the fault because we have not planned it. So that is called the transient voltage. So to identify the transient voltage, we use the wavelet. So there are two different features we are using. And can you repeat the first question, please, once?
Okay, so transient voltage and the wavelet are your features. I got it.
Yes.
Another question was, in order to transition from the simulation to actual physical system, what would be specific steps? That was the other question.
Basically, in moving to real world scenario, there will be first issue we will getting the datas. Basically, in Nepal, datas are from the substation are getting really not in digital form. So that will be one of the main problem of our data set. Other, I guess there will be comes on challenging part on the hardware part. Like we will implement in the hardware system rather than the software. We need to go to the hardware part. So that may be the challenging part for us.
Okay, so I have one question. So why did you choose machine learning algorithm here? So there are deep learning algorithm available.
So we tried on deep learning as ANN model also, but we didn't get accuracy. As our data set was also, we didn't use a high data set, and we didn't get accuracy on the ANN model also. So decision tree was the best.
So can you tell me what is the size of the data?
Data set was 10K. 10,000, sorry. Yes, in all folder.
Okay, first of all, thank you for the nice presentation.
Welcome, sir.
My question is, in your data set, how many features did you consider?
We considered a total 16.
16 features. Did you perform feature selection methods?
We didn't perform that feature selection method. We just added what we all needed.
So that 10,000 data is simulated data, isn't it?
No, in all fields, fault scenario, like 10,000 data consists all type of faults.
So where did you collect that data?
From MATLAB Simulink models.
Simulated
yes, sir.
Data. Okay. And beside all these traditional methods, did you experiment it with other methods also?
Other methods like?
Other methods for classification?
We didn't try. We goes through this only because as the decision trees, they works and the node base. For the classification, these models were the best for as past researchers. Okay,
thank you.
Thanks, sir.
Okay, thank you very much. So we have our last presentation for this session with paper ID 134, Secure Aggregation Enabled Federated Visual Transformer Framework for Tissue Image Analysis by P. Jayaraju and the team. So you'll get 10 minutes to wrap up the things. Okay, thank you.
Hello. So very good evening to all. This is Dr. Sivasangaras from Hyderabad, KGRT College of Engineering, Professor. So here my topic is Secure Aggregation Enabled Federated Vision Transformer Framework for TC Image Analysis. So it is in region computer vision topic. It is one of the very important topic in the nowadays computer vision. The TC image analysis, the given image is divided into number of small patches. That means the fixed size small patches, and then we are transforming into the, we can take it for the number of reasons. So here the problem is the security. So how we can, when we are sharing the data, generally for the patient data, if you are sharing from one place to another place, so there are lots of problems. So it's a highly secure data, we can't able to transfer very easily. So when we are transferring data, the client, that means the patient's data, when we are transferring, it must be highly secured. So even if you are doing for the centralized database, we are facing a number of issues for the security. So how we can avoid all those problems by using the vision, computer vision, this vision transformer techniques. Secure aggregated federated vision transformer techniques here we have used. So the medical image analysis using deep learning has achieved remarkable progress, yet collaborative training across healthcare institutions remain limited due to the privacy regulations, ethical issues, data security concerns. So traditional method, already we are sharing the data from we can able to access very easily. But the problem is the patient data, when we are transferring from one place to another place, it must be highly secured. So if we are using for the traditional method, we are facing lots of issues. So for example, then easily others can able to hack the details of the hospital and the patient detail, all those things. So how we can avoid all those things? We can go for a centralized database to federated learning. In the federated database, there we are adding for the encryption method to protect the data. So we can propose for some new methodologies, vision transformer. So the proposed approach allows multiple institutions to train vision transformer models without transferring raw medical data. That means you don't need to transfer the original data. We can keep the original, keep the data in the local. Then that encrypted data only will be shared to the one place to another place by using the technology. So you don't, here we are not sharing any original data. The original data will be available in the local drive. There we have adding the encryption technology. After that, once it is encrypted, the secured data only will be shared to the next one. So here we are using for techniques, vision transformer. So how we have used here, sorry. So the objectives for this paper, to build a secure aggregation in a federated vision transformer framework for privacy preserving analysis for tissue images. Already I told the tissue images mean the given image is divided into small fixed size of images, that is called as a token. So everything will be shared as a token one by one. So if it is encrypted, that is, it is highly secured and centralized. Even if it is centralized, it is the original data is available in the local drive. We are not sharing the original data. That's the raw data is already available. We are sharing only the encrypted data. So to compare the proposed model with the state-of-art methods on publicly available datasets by showing a trade-off between the performance, privacy, computational efficiency. So here we have taken some related works. Methods, focus and strength. Here we have shared for the limitation, just for the references here we have added the first one with the Edge AI with CNNs for elderly healthcare. Activity analysis and anomaly monitoring. So the strength for this paper is on high accuracy but low latency processing. And the limitations here they can mention for high computational overhead, limited energy efficiency, lack of privacy guarantees, small or narrow data sets. That is because of data sets. The second one they have taken for the IoT enabled wearable systems. The strength for this paper is on strong evidence of real-time monitoring accuracy, but it is the limitation is here for lax device interoperability analysis. The third one we can take from multimodal AI powered wearable healthcare orchestration systems. The strength for this one is covers biosensing, neomorphic processing, privacy preserving analytics, and future trends. But the problem is no quantitative benchmarking regulatory challenges. The next paper here we have taken for the AI enabled IoT healthcare systems. It is highlighting the emerging trends, patient engagement, device fusion benefits. The problem is the conceptual only, robustness testing, limited scalability analysis, weak governance discussions. So here we have proposed by the methodology. The TC images, already I told the given images divided into number of small images, each one will act as an tokens, tokenization, that is called tokenization. So there everything will be updated to the server, then secure aggregation. Here we are not sharing the original data, already I told. Here we are sharing only the encrypted data. In all the previous centralized methods, we are sharing the original data, but here everything will be secured by using an secure aggregation. That is called as a vision transformer. That is a methodology here we are given.
So sensing ecosystem, secure data processing. So each and already I have told all data transmissions are encrypted and securely stored in the complete cloud infrastructure with the role-based access control. For example, so read access, we know it's a very simple one. If you are using for the spreadsheet, even if it's a spreadsheet, we can able to see for the viewer, editor. If you give the access, generally we can able to access who is giving the control. So it is completely purely based on audit trials. That means access control and audit trials. The standardized pre-processing already it removes some noise, artifacts, and missing values also. So multimodal modeling, clinical integration. This is a result and findings for this our work. So I'm concluding my work here. The proposed secure aggregation enabled federated vision transfer framework demonstrates state-of-the-art performance for tissue image analysis while preserving institutional data privacy by integrating multi-scale VAT tokenization, the communication efficiency, secure aggregation, differential privacy, and personalization strategies. The model effectively addresses cross-center data heterogeneity also. The experiments on camelin 16 confirm that privacy-preserving federated learning can match or even surpass such centralized baselines, enabling practical and ethical multimodal institution collaborations. The future research here we have given the 3 directions. Here we are mentioning here the expanding multi-center, multi-organ datasets. So here we use it only for the very few datasets. Here next we can go for multi-level, multi-organ datasets. Then broader generalization, developing auditable hybrid privacy protocols combining MPC, trusted hardware, and certified differential privacy methods also. So these are all the references here we have used. Any questions here?
Okay, thank you very much. So the floor is open. So if anyone have any question, they can ask.
So we can do already here we can use for the encryption, basic encryption methods only for the security purpose. There when we can increase the security, for example, latest any encryption methods. So many encryption methods are available for a cryptography. If you apply for the more level, the encryption and the data will be highly secured. The centralized database, the previous one is a centralized database. It doesn't have any security. That means a patient data easily they can able to hack by any software or whatever it may be. But here we are using the aggregated. That means encrypted data image. That means we are keeping original with our for example, I am having an hospital. I am not sharing my original data with anyone. The raw data is with us only. We are sharing only the encrypted data. So it is highly secure. If we improve the encryption methods, that means next level. For example, if you go for AES or DDDS, different algorithms are available. If you go for the high level of security, the data will be highly secure. Yes.
Also, another one. Would you say that of your research, the encrypted transmission of data is the major focus?
Sorry?
For your research, would you say that the encrypted transmission of medical images,
Yes,
right?
yes.
That is your major focus with this research? Would you say that?
Sir, I'm not getting your question.
You transmit your data, you encrypt it and give role-based access control, right?
That means in previous they used for the centralized databases that
Yes.
can be easily accessible by others.
Yes.
So here we are using for we are not sharing the original data. The original data is always with us only. That means raw data is with us. So we are transferring only the encrypted data. So others they can't able to access very easily without knowing the decryption key.
Yeah, okay, I have understood you correctly. What I'm asking is, would you say that that portion, that particular part of your research is your focus with this research paper? That is what I'm asking.
Yes, yes, yes.
Oh, okay. Thank you. Thank you for your question.
Thank you for a wonderful presentation. My question is, first of all, would you say what is the novelty of this particular research? Number one. Number two, during training of model, did you consider encrypted data?
Yes. So here the main here we can take for mainly secure how we can share the data with highly secured. So in previous, for example, they don't have any role-based access. Without any role-based access, anybody can able to access the data. The first step itself, what we are doing, we are not transferring the original data. Original data is always, for example, more than one hospitals, if they are sharing the data, mean that original data is with me only. That means raw data is with us. We are sharing only the encrypted data. Next stage, how we are handling means the audit trial. That means role-based. For example, all the others they can't able to access. For example, each and every role. For example, admin can able to read.
It is similar to the spreadsheet I have told for a simple example. If you are giving access only for editing action, then only they can only able to download or they can do some operation. Audit trials, we can able to easily track which data, which is accessed by whom, easily we can able to track. So security we are providing. So that means the data privacy, the patient detail always we are securing.
Okay, thank you. Now my next question. Did you experiment it like this particular data set is a popular data set, and what is the benchmark without encryption and what you did get through the encryption?
So for without encryption, for example, the previous all the things are centralized database, they are not using the encryption. So when we are adding a encryption, the data will be secured. The others, they can't able to use access very easily only. So in previous, the original data is transferring. We are not transferring original data. If you have the decryption key, the similar, for example, corresponding decryption key, the person who knows, then only they can able to access. So otherwise, they can't able to access.
Okay, thank you very much. Okay. So with this, at the session, sir, it is my pleasure to formally conclude track 2, Artificial Intelligence and Machine Learning. And I sincerely thank all the presenters for sharing their excellent research and insight. And I also appreciate the audiences for their engaging question and discussion. Before closing the session, I request Associate Professor Deepanjal Shrestha sir to present the token of love to the session chair, that is me, and to the co-session chair. Thank you. Okay, sorry. So we request Professor Timila Yami ma'am to come forward and hand over the token of appreciation to me and the co-session. Thank you.
Thank you for this little space they have given me. I think going through these sessions, we have covered a very sensitive issue on protection, encryption and tissues. That's a very burning issue in the world. And, bringing that knowledge here is very encouraging for us. And other thing is, I get alarmed when we talk about AI, Mount Everest height. It's going to explode. The disruption is so dangerous. At one end, it gives such big height advantage. And the responsible AI part is another coverage. A country like Kathmandu, Nepal, it's going to be a difficult journey, as I see. And from that perspective, I think especially the paper presenters and the audience from Nepal, we have to, I do see a lot of talents there. And I'm sure, along with the international paper presenters, we can have a very, very successful journey. And that's what we all should look forward to. And I'm very impressed with all the presentations. And I think we all have learned a lot. And I feel that these kinds of sessions should be more frequent in Nepal. Yes, if we want to catch up with the world. Thank you so much.
Hello, check, check. Hello.
This is your brain when you're struggling to focus.
Start good. So, namaste and good afternoon. We'll be starting the online session here. So, some of the authors were not able to make it to the conference. So, those who want to listen, please be at your seats. And you can come closer. I'll nazik basna sakcha. And we are going to start. I would like to welcome my session co-chair, Navin Lamichane, who is an assistant professor at WRC, to accompany me for this session. Thank you.
Thank you, Dipanjal sir. Sorry for the delays. Now we'll go for the presentation round. I would like to call paper ID 25, Safayat Jamil Saim. Are you there?
Yes, I am
Can you
here.
hear me, yeah? So strictly we have 10 minutes presentation time. Now you can start when you are ready. Safayat Jamil.
Okay, I
Thank
can
you.
start now. Okay, can you see my screen? Hello?
Please, can you turn on your mic, please?
Can you see my
And you need to
screen?
turn on your
Hello?
video as well.
I can see.
Yeah, can you turn on your video, please? And
Okay, I am trying.
it's important for the paper publication. Thank you.
Hello, can you see my video?
Yeah. Please proceed. You can proceed further.
Hello?
Yeah, you can start.
Can you hear me?
Yeah, we can hear you.
Okay. So I am Shafat Zamil Siam, and my paper title is Entropy-Based DDoS Detection and Mitigation Method in SDN, a comprehensive review. So it is mainly a review paper. So
Mr.
at
Shafayat,
first,
just a second. Can you go on to a presentation mode, please?
Okay.
Run the presentation mode. Yes. Thank you. Start.
So my paper is basically a review paper. So at first, we have to know what is SDN. SDN means software-defined networking. So software-defined networking is a modern network paradigm that enhances the flexibility, scalability, and programmability of a network infrastructure. Unlike traditional network infrastructure where the control and data interfaces are integrated into the same hardware, this close integration into the same hardware in case of traditional network makes them less flexible and harder to manage them in the sensing network environment. On the other hand, the SDN approaches the It separates the control and data infrastructure of a network architecture and enables centralized control and dynamic network configuration. For this reason, it is very easy to manage this type of network in the effort-sensing network environment, and it has a faster adaptation to change and improve efficiency in the large-scale network environment. So although STN provides a lot of opportunities as well as advantages, but there are many vulnerabilities in software-defined networking architecture. For example, the centralized architecture of STN makes them a prime target for cyber attacks. There are many types of cyber attacks happens in STN infrastructure, but the most common type of threat for STN infrastructure is the distributed denial of service attack that mainly targets the SDN control infrastructure. So a distributed denial of service attack is a harmful attempt to overload a target, usually a server service or network infrastructure with an excessive amount of internet traffic, which prevents it to operate normally. So the consequences of such type of attack in software-defined network can be severe, because in that case, the attacker can overwhelm the SDN controller by sending a huge amount of crafted traffic. As the SDN controller has a limited capacity to processing packets, the controller cannot process a huge amount of packet in that case within a limited time. For this reason, it cannot respond to the legitimate network event in a timely manner. So the switches connected to the SDN controller cannot get the proper instruction how to manage the network. For this reason, the whole network infrastructure can be collapsed down. Because of although many researchers from recent and previous year have invented different approaches, including threshold-based detection, machine learning-based detection, and signature-based detection and mitigation system to protect a software-defined network environment from such type of attack. But there are some limitations of all this method. For example, the static threshold method fail in dynamic traffic condition where the network requirement changes very frequently, and the machine learning method requires a level data set, as well as they also requires a high computational efficiency, which is not possible in a limited network environment. And on the other hand, signature-based system cannot detect some new and evolving attack like low-rate DDoS attack or multi-factor DDoS attack and so on. For this reason, a lightweight and adaptive mechanism is required for SDN. In that case, entropy can help us. So entropy is a measurement of randomness and unpredictability of a data set. In the concept of computer networking, entropy measures the diversity of network traffic attribute like source IP, protocol type, and paper size, and so on. So during a DDoS attack, this type of traffic distribution becomes concentrated at a single position. This led to miserable entropy deviation. So by detecting this type of deviation, any attack can be detected. For this reason, entropy calculation is lightweight and it is highly suitable for SDN environment. So the research and objective of this study is to find out and investigate the entropy-based research and which one is better for the SDN environment. Although many researchers have used entropy, but existing studies have also some limitation because there is no structure comparison of entropy feature, entropy formulation, and controller platform. So this review study provides a structured review of entropy-based DDoS detection and mitigation technique in software-defined networking environment, and we classify the entropy-based approach based on entropy feature, entropy formulation, as well as the controller platform. Now, our final goal is identify to extent limitation and open research challenges of all these fields. So here comes the literature search procedure. So we adopted a structure and systematic literature review methodology, and we have find out our suitable literature review from the following major scientific database, including IEEE Explore, Spencer Link, Science Direct, and Google Scholar. We mainly focused on recent studies from the last 7 to 10 years, and we also use Boolean keyword contribution. Boolean keyword contribution are used to maximize coverage while maintaining the relevance. For example, DDoS and distributed denial of service and software-defined networking and entropy and so on. So here comes the inclusion and exclusion criteria. To ensure relevance and quality, we used strict inclusion and exclusion criteria. So we included the studies that includes the focus on DDoS detection and mitigation and SDN, and use entropy or entropy-derived matrix and peer-reviewed journal or conference paper, and the paper which are written in English and which also provides sufficient technical detail. And we excluded the paper which is not related to SDN architecture and not entropy-based, and which have a short abstract poster and non-peer-reviewed articles, as well as which have insufficient methodological description and duplicate studies. So here is our screening and selection strategy of our article. So at the first stage, at the initial search step, we have reviewed a large number of articles. Then we have screened the title and abstract of this article. After screening process, we have found some duplicate abstract and title in case of some articles. After that, we remove all the duplicates, and rest of the articles is underwent for full text review. And finally, the particular papers are selected for detailed analysis. So from each selected strategy, we evaluate the methodological parameter like entropy type and traffic attribute analyze, controller platform, as well as detection and mitigation mechanism. So at first, we want to discuss about the non-entropy based DDoS detection and mitigation method in SDN. We have used many different articles. For example, static and variable threshold detection, and traffic pattern monitoring and statistical anomaly detection, and support vector machine decision trees and neural network. Support vector machine decision trees and neural network, all these are fall under the same category, which is machine learning method. And the core mechanism of that mechanism is supervised classification of normal and attack traffic, as well as rule-based classification using learned traffic feature, and finally, deep learning-based traffic classification for attack identification. As well as we have included the articles which focused on threshold-based detection and traffic pattern monitoring-based detection.
Hello, Mr. Safed.
Yes.
Only 1 minute to wind up, okay? We'll stop you after that. Quickly.
Okay. So here comes the disadvantages and advantages of all these parameters. For example, threshold-based detection. It is simple to implement but cause false positive under dynamic traffic, as well as there are also some advantages and disadvantages of machine learning for rule monitoring and rule-based detection. And here comes the several studies which focused on single attribute entropy-based detection in SDN. So all of single attribute-based detection method has a common limitation, which is that they are less robust in a dynamic network environment, and they cannot provide a effective prevention against multi-factor DDoS attack. And to overcome that limitation, some researchers have proposed multi-attribute entropy-based DDoS detection in SDN. But they have also some limitation. For example, they increase computational overhead, and they are very complex compared to the single attribute-based parameter, and they also added some extra complexity. Now comes the entropy-based formulation of DDoS detection in SDN. There are mainly three formulas which is used in entropy calculation in the SDN environment. For example, Shannon entropy equation. It is perfect for the network environment where network traffic is very limited. And the Rayleigh and Salis entropy equation are perfect for the large-scale network environment where network requirements changes frequently, like data center and cloud computing environment. And here comes the controller, SDN controller. There are many types of SDN controller like floodlight box and open network service used in many different literature. And
Hello,
this,
Mr. Shafet. You have consumed a lot of time. We need to stop you because there are other people waiting for online. Okay. Okay. We'll just give you 1 minute to read this. Okay. Quickly.
Okay.
Thank you.
And our final review is the single attribute entropy is lightweight, but on the other hand, multi-attribute entropy significantly improves robustness by capturing traffic correlation, and shadow entropy based for real-time detection, where Rainy and TCLs improve sensitivity, and in case of controller, open network service and ODL scale better. And future work should focus on adaptive threshold and hybrid entropy framework. So that's all from me, and thank you.
Okay, thank you.
Okay.
Fine. So while doing this literature review, yes. So what was your basic idea? I mean, why did you want to go with this one?
Actually, I wanted to review the previous literature, which have focused on the entropy-based distributed denial of service attack detection and mitigation method in software-defined networking environment, and I have tried to find out which type of strategy is better for that environment.
Okay. So are you thinking to build some other project based on this? I mean, are you thinking to apply? In which domain, if you are thinking to?
I am thinking to... can you repeat the question, please?
So you have done a literature review, have come out with some findings, yes?
Yes.
So definitely you're going to apply in some domain. So have you thought of it, or you're just finishing up with this one? I mean, are you going to go further with your study? With this?
Yes, I want to apply all of this finding to develop an effective mechanism which will be effectively detect and mitigate DDoS attack in SDN environment. And I want to overcome all the limitations which I have found in my study in the future.
Okay. So what was the major research gap that you find after doing this literature survey?
Okay, the major research gap is many literature survey has focused on different topics to detect and mitigate DDoS attack detection and DDoS attack detection in SDN environment, but none of them actually discuss properly about the role of entropy to prevent DDoS attack in SDN environment. So I found this is the major research gap.
Okay, so that was nice listening to you. Thank you very much. Wish you good luck.
Okay, thank you.
Thank you, Safai Jamil, Saim. Now I would like to call paper ID 99. The paper title is Optical and Structural Investigations of Semiconductor Material Oxides for Optoelectronic Applications or Review. Authors Nima K.M. and D.S. Jayalakshmi. Are you there? Nima K.M. Yeah, you can start when you are ready, okay? And you have strictly 10 minutes time. Sorry, I can't hear you. Can you turn on your mic, please? We are still not hearing you. Can you switch on your mic, please?
Miss Nima, please check your mic. Go to the sound settings and just check over there. Or in the ears, I mean, you're in the Zoom link. You can just see, just on the top, you have that red cross with your mic. Click there, it will unmute you. It's there, audio. Can you see at the left screen, you have a video audio. If there is a red one, red cross, please click there, it will unmute you. Yeah. Can you speak a little loudly? Okay, so till you adjust, we'll switch to another presenter. Please fix in, okay? No, sorry, we cannot hear you. Please check first and then you can join. Is that okay for you? We'll take up the another paper and then we'll come back to you. We cannot hear you. Don't worry, we'll schedule you after this, okay? Okay.
I would like to call paper ID 67, titled Privacy Preserving Clinical Prediction for EHR and IOMT Using Zero Trust Security and Blockchain-Based Federated Learning. Authors C. Cuba Jaslyn, M. Arvindam. Are you there? Can you hear me?
Hi, sir.
Yeah,
Can you hear me?
you can start when you are ready, okay? The presentation time is
Okay.
10 minutes.
Okay, thank you so much. Hello, sir. This is Diana Priyadarshini. Hello.
അടുത്ത ആൾ കയറുന്നവർ പറഞ്ഞായിരുന്നു ആ. ഇപ്പൊ അത് കേൾക്കുന്നുണ്ടോ ഓഡിയോ എങ്ങനെ അറിയാൻ
Nima, we can hear you. I think.
Hello, am I audible?
Yeah, yes. So
Okay,
we have
then
to
can I?
Yeah, you please share.
Okay. Okay, sir. I will share.
No, Miss Nima, you have to wait for some time. We have already started with S. Diana
Yes, yes.
Priyadarshini. Okay.
Yes, sir. Am I audible now? Audible
Yeah,
now?
you are audible. Yes. But you will take you
Okay.
after this, okay? Thank you.
Okay, okay.
Dr. S. Diana Priyadarshini, please, could you go on to a full, slideshow mode? Can you enter the slideshow mode? You can find that at the right hand side, you see that there's a presenting, yes. Just come down there. The magnifier, yes, now it's okay. Start, please. You're no, we are not getting your
Hello,
voice.
sir. Good
Yeah,
evening.
no, it's okay. Yes,
Nandita
yes. Please
Institute of
start,
Medical
start,
and
start.
Technical Sciences, HR and IONT using based federated learning. No? Hello?
Yeah, please start. We can hear you, please.
Introduction healthcare for advanced analysis and prediction activity and centralized server vulnerability hacks. The major advantages of using deep learning is it enables sophisticated outcome prediction. Precision medicine requires vast and diverse data sets, potential for early intervention in sepsis and mortality. The drawbacks associated with deep learning research is the data are very sensitive and it has to be protected. And when we using centralized servers to create a single point for a single point and single disease analysis, it will we can have data breach. So standard infrastructure, what we are already using cannot safely share the heterogeneous data. So we need a system which allows models to learn from patient data without the data ever leaving the hospital secure perimeter. That is what the prime objective of the study. And from the literature, we came to know that limitations associated with the already existing literatures are AI utility. The validating of AI utility is high, but it lacks a comprehensive framework for securely sharing the expertise across the network. When you share the data in between from one network to in other network, the data breach is the major disadvantages associated with the problem. And poor scalability, regulatory non-compliance, and absence of large-scale hospital validations. These are the major disadvantages and gaps associated that is identified from the literature survey. And the major research gap from that literature survey, we derived one is privacy, second one is interoperability, and the third one is real-world scalability. To address these issues, we came to know these are the objectives we find out from the literature survey. One is first objective is secure standardization. That is to implement zero trust architecture combined with blockchain to enforce never trust, always verify protocols for data sharing. And second objective is high accuracy classification. That is develop a multimodal deep learning model capable of handling both electronic, that is EHR, and high frequency IoT sensor streams. And the third one is real world viability. That is making it to scalable. That is the major advantages. For analyzing small amount of data, we cannot use that for scalable. So that is why we use a large data set for analyzing these study. These are the major objectives and methodology. This is the overall framework for methodology. One is zero trust security. Second one is federated learning. Third one is permission blockchain. That is a blockchain enabled deep learning network is introduced to merging blockchain's immutability with deep learning's analytics for secure, efficient data transaction across organization while preserving confidentiality. It supports high accuracy multi-disease classification on heterogeneous data and scales to hospital ecosystems. In phase one, we use, that is the 4 phases we have. First phase, we analyze zero trust handshake, that is zero trust. For node ID verification via HashiCrop vault session token generated only if A, B, AC policy is satisfied. In 2, local training. For local training, VAT LSTM model is used to train the private local data. And third one is privacy injection. Differential privacy is applied. Gaussian knows added to gradients. And in the 4th phase, aggregation. Smart contracts execute Fed average on blockchain. Global model updates after cryptographic proof. And this is the experimental set we use. First simulation, we use 10 client nodes. And the server we use is one AWS EC2 aggregation node. And this is what the data we use. This is the open source data. And the task is in-hospital mortality prediction and sepsis prediction. These are the 2 main objectives, the 2 tasks which is given to train the given data. And this is what the results we get from us. The centralized baseline output is 0.88 AUC ROC, that our proposed network is giving 0.84%. That is 4% drop in accuracy due to differential privacy noise. Because and the latency is also increase from the centralized model to 17.5%. But 100% stopped, locked. Using zero trust, aim to know the decrease in the distributions across IoT nodes and differential privacies. To optimizing this, we identified the 1.2, which falls within the expected group range of 2 to 5. Founding framework. So the usage of framework, which gives this. Thank you so much.
Priyadarshini, you had done a very good work. We could not hear you in the later slides because there was a network turbulence from your side. I don't have much questions. I want to just ask you one thing. As you have done the research on clinical perspective, and we are from engineering background. How have you cross-validated your final results? Is there any clinical persons in your research who have validated your results?
No, sir, at present, we just came out the results. That part we need to do. Right, at present, we validate the results with the already existing literatures only. We haven't done a clinical research.
Right.
Or directly implementing those results in a real time.
So you haven't implemented in the real time, just you have done the research, right?
Yes.
That's fine. So in the further implications, what you can focus is like, you can more work on the validation part, and you can involve the clinical persons so that our result can be precise. And another question is like, how can we generalize the result to other aspects? Like if you have done the research over there, can that system be implemented in the case of Nepal or other countries?
Yes, sir. Yes. It is universally acceptable because the data sets is general data, and we can implement the models are already available models. So we are analyzing by changing small deviations by giving ZTA, that is to reduce data breaching. We can implement these that is results into anywhere.
Yeah, thank you so much. So there is another paper ID 71. Is that paper being presented by you as well, or?
Yes, sir, yes.
So first we'll give the turn to paper 25, then I will call you again, okay? Thank you so much.
Sir,
good luck ahead.
Thank you so much. Thank you so much.
So paper ID 99, Nima KM. Can you hear me?
Yes, sir, I can hear.
Yeah, we can hear you as well. So you can start when you are ready, and you have 10 minutes time, okay?
Okay, sir.
Thank you.
Very good afternoon to all of you. I will share the PPT. Very good afternoon to all of you. First of all, I thank ICTP 2026 for giving me a chance for this.
Can you share your screen, please?
Yes, sir.
Thank you.
Okay.
Yeah, we can see. You
So
can
this
start.
is the topic, optical and structural investigations for semiconducting metal ions, metal oxides for optoelectronic applications. So here, what I am considering is as the semiconducting metal oxides. Semiconducting metal oxides have attracted significant attention due to their versatile optical and electronic properties, making them promising materials for optoelectronic applications, sir. This kind of materials exhibit tunable band gaps and certain properties like tunable band gaps, high transparency, and high chemical stability, etc. So this can be utilized for solar cell, photo detectors, LEDs, etc. So the transparent conducting electrodes also can be made use of by using the semiconducting metal oxides. Why we are using this is a perovskite materials. This review is based on the perovskite materials, and about the perovskite material, it is they have the special features are suitable band gap, high value for absorption coefficient, significant carrier mobility, etc. So, including this kind of perovskite materials in applications like solar cells, LEDs, etc., that makes the technology becomes versatile. So for more applications, we can use this, most of the optoelectronic applications. Here, this review is mainly focuses on perovskite materials, mainly focus on barium titanate, strontium titanate, and barium strontium titanate. And here, what I am planning is to compare the different method of synthesis, compare the nature of the dopant which is added, and the concentration of materials that also affects the factors, affects the properties. Temperature also a factor which affects the properties of this kind of semiconducting metal oxides. So here, what we can compare is the theoretical in this review, a theoretical and experimental approaches that has to be compared based on DFT, the density function theory study using 3 software packages, V and 2K, WASP, and Quantum Expresso. I have studied the theory of this type of materials. That is the semiconducting materials. I have compared the properties, and also I have compared the same, planning to compare the same properties with the different experimental conditions, that is salt gel method, mechanical alloying, magnetron sputtering, etc. So the ultimate aim is to, from the comparative study, we can understand what is known as the properties. It becomes the value of the parameters affecting the properties of this kind of perovskites. That becomes more accurate, precise if you are doing the theoretical as well as the comparison. If you are doing the comparison between theoretical as well as experimental aspects. If you are comparing both the parameters, the value of the parameters, it becomes more effective. It becomes more accurate. So precise determination, precise value in the parameters. That is what our aims are by this type of a comparative study. So I have compared mainly the different perovskites like barium titanate, barium titanate, strontium titanate, and barium strontium titanate and all. So the different method of studies used, those purpose I have studied. And I have mainly my work focuses on optical and structural studies. So I focuses on the energy band gap, the permittivity, the refractive index, those kind of things I have compared both in the experimental study as well as both in the theoretical study. So that makes this becomes effective. And here, the comparative study of the properties and the concentration, the different concentrations, according to that, the band gap of the material also changes. So a list of that is given as a table. Barium titanate, when into the barium titanate, when we add the strontium in different concentrations, the band gap will increase. The increase in band gap can produce different properties. Increase in band gap produces difference in the electronic properties, and so this doping or the mixing or this strontium into barium titanate can cause or make the material different properties. Ferroelectric distortion is another property that I have reviewed. Then electronic nature of the material, it is in all the cases, it is an indirect band gap material that I understood from the theory and the experimental literature work. So then I have given an energy versus concentration graph here, and as the concentration of the strontium increases in barium titanate, for a pure barium titanate, it is only less than 3.2, and it increases to 3.25 electron volt when added a small percentage of strontium. When we increase the strontium concentration again, the energy gap increases, and so that is the graph showing here. Energy value is given in electron volt, and this can be used in different solar cell applications, because all these materials have certain properties like high absorption coefficient, tunable band gap, low cost processes, solution processes, rapid efficiency improvement, etc., etc. So it can be, all these properties can be utilized for making solar cells in a different way. And sensors, gas sensors especially, can be made using this. LEDs can be made, laser diodes can be produced using this. So that's all these are the applications. So as a comparative study based on theory as well as the experimental improves, that is the important point, the accuracy of the measurement of the value of the parameters. So that results in the synthesis of good quality perovskites. Good quality perovskites means that improve the versatile applications. So that is about the study, sir. Comparative study based on the theory as well as the experimental. So this is about my review paper, sir. Thank you very much. All of you for patiently listening.
Thank you, Ms. Nima. It was nice listening to you. Though we belong to the field of information and communication technology, but anyway, we understood the last part of your work and looked very impressive. My question to you is like, what was the most difficult thing you encountered while doing this research?
It is the theoretical software packages that we use. It is when we consider that there are three different softwares I have given. So one is the payment given to a common man, payment given to a society. That is one of the factor I focused. I listened to that point. So most of the packages, they are paid and all. So anyway, the WASP Quantum Expresso, the two are very, as you are from the information technology side, I'm saying the two are very research-friendly softwares, and the VN2K, it is paid. That can be available in almost all the very so-called big universities and all this VN2K. So the research scholars, most of them are not paid, so it is very difficult for them to achieve this VN2K software. Even, and that was a very excellent software compared to the three. But that is the theoretical part. Then the other one is a Sol-Gel method, mechanical, the experimental part when I compared Sol-Gel method, mechanical alloying, and also I am given magnetron sputtering. This sputtering is the most time taken process. So in order to make synthesis this perovskite, we can use the Sol-Gel method. It's a very simple method we can use. So by comparing this, I understood within the short time, within the very good manner, we can synthesize the material by using Sol-Gel and can compare the parameters, values of the parameters. So the different methods, which is good, which is more effective at the same time, which is more convenient, the research friendly, that I understood, sir. And most of the values, it is good. Most of the parameters, they are good.
Wow, that's great. So what will be your extension as a future work, like if you have to extend its study? Yes. So what next are you thinking?
My future work is, I have done this Solzel method of experimental studies and a few of the theoretical part. And comparing this, I will develop yes, a solar cell having good efficiency, good fill factor, etc. I contribute by using this perovskite, by using this semiconducting method that I produced, that I synthesized. Using that, I will make a solar cell having good efficiency.
Oh, that's great. So I think you'll be converting your idea into a business innovation. That's what I understand. Yeah, like if you achieve your results, like you are trying to use that into solar. So definitely solar is a product that is usable. Yes. So
Yeah,
do you
yes,
have any
sir.
plans to go as a business innovation development?
No,
For
that is not my plan. I'm actually a teacher, sir. I'm
No,
actually
I
working as a
understand that. What I'm trying to say is that, like, when you've come up with a complete product after research and innovation, you have to send it for the people so that they can use it. Do you have any such plans to, I mean, give it to some company
extend.
and?
Yes, sir. My aim is to extend this, which is usable for the society, sir. Which is good for the society. Solar cell. It is. There are many villages and all. They have no current and no nothing like that.
Yeah,
So I
yes,
have
that's what I'm saying. Yeah, so definitely you have to go to some industry and ask to develop your design into a usable solar battery cell. Yes, that's what you said. Yes.
Yes, sir. Yes, sir. I
Yeah.
will do.
Thank you. It was nice listening to you. Thank you very much.
Thank you very much, sir. Shall I?
Thank you, Professor Neva. Thank you.
Thank you. Thank you. Shall I stop, sir?
Yeah, you can stop. Thank you.
Thank you very much. Thank you very much.
Now I would like to call upon paper ID 71. Are you there? Paper ID 71. Optimized, lightweight, privacy, preserving federated learning for edge IoT. You are there? Okay,
Yes,
it's
sir.
again your paper. Dr. Priyadarshini. Can you move to your slide sharing, please? Paper 71.
Yes,
Yeah.
sir. Am I audible?
Yeah, please start with your presentation. Thank you.
I'm Dr. Diana Priyadarshini from Savita Institute of Medical and Tech. Lightweight privacy or expected. So moving all the data to the cloud is infeasible in terms of bandwidth, latency, and energy. Federated learning is adopted to keep data a local, but typical edge hardware is severely resource constrained, so standard FL protocols become inefficient. That is why the drawback from the existing methods is efficiency, privacy, and utility. And existing methods tend to optimize one or two of these things. That is, either it optimizes the privacy and efficiency, and it lacks the utility, that is utilization in a scalable manner. If you are concentrating on privacy and utility, then the efficiency will drop. So to combining these things, and already existing methods limitations, we came to know this is what the major gap we found out from the literature survey. That is, by combining three things are the major advantages while utilizing these things into a real world scalable procedure. The major limitations associated with the already existing approaches are: one is hardware centric, that is, trusted execution of environments are expensive and unavailable of low-cost IoT endpoints, and it is vulnerable to side channel power analysis. Second one is cryptographic, and it is homographic, which expands the data size. And second one is computationally prohibitive for real-time edge use. And third point is disjoint optimization, privacy noise conflicts with sparsification, which results in model lag and failure to converge on the data. And these are the three major research gaps. One is sparsity and privacy, and the other one is index leaking, and the third one is scalability. And based on this, there is no unified solution which jointly handles these errors, and that is jointly addressing the scarcification, privacy, and our scalability. So encounter to reduce these problems, we found out that jointly optimized federated learning framework for edge IoT that simultaneously achieves efficiency, privacy, and high model accuracy. And this is what the method we use. One is dynamic error compensated sacrification. Second one is privacy amplification via sparsification, lightweight coordinate hiding, ACC, AGG. The overall, each client computes a local gradient GG from mini batch during a FL. And then instead of sending the full dense gradient to the client, top case sparsification, to keep the only largest coordinates, then and proposes the remaining part to the residual. And the residual memory buffer scrolls a small dropped gradient so that their information is not lost but deferred to future rounds. That is how it is being used. This we can find out. This is what the gradient. And the problem with the standard top K is ignoring small gradients creates accumulation error. So while reducing that error, that accumulated small gradients are again used in the next round gradient, next initial round training process. In the FS, the solution is residuals are totally stored, not discarded. That is, that small gradient makes the accumulation error cannot be rejected. It is reused. And the result, the information is delayed but not lost. And this is what the methodology, why it is called lightweight security and quantification, because standard top key discuss, because each client transmits only a random sparse subset of coordinates, sparsification itself acts as a subsampling mechanism that amplifies differential privacy. So this by combining these EF-based sparsification, aggressive quantization, and coordinate hiding, secure aggregation, FASS aims to resolve the edge FL trilemma. It dramatically reduces the communication cost, strengthens the privacy, and still preserves high model accuracy under tight edge constraints. These are the results. The FASS gives 92.1% accuracy, which matches with the non-private baseline. And the efficiency gain from this methodology is 99.5% reduction. 99.5%. And the conclusion. This proposed zero trust blockchain enabled federated learning framework offers a practical way to train powerful multi-model clinical prediction models while strictly preserving patient privacy and regulatory compliance by combining VAT and LSTM-based multi-model deep learning with permission, blockchain, mutual TLS secured zero trust networking. So which securely strongly controls a 17.5% increase in training latency. The result shows that large-scale multi-institutional healthcare AI can be deployed without sharing raw records. With blockchain audit trails and access controls, provides robustness against malicious nodes and satisfying GDPR requirements. Overall, this zero ZA VCFL as a scalable blueprint for future medical consortia. So it can be that error feedback is highlighted as the mathematically, and it has been that in any other small data cannot be eliminated. It can be reused and it can be used as a raw data, but it will not be deleted, or it can be used for further uses. Maybe a small lack in data results in the overall efficiency drastic difference. That is why this method is giving a positive feedback. Future work related to this is hardware software coding and embedding fast assimilation logic directly into next generation IoT memory controllers. These are the papers we use for literature survey, some of the papers. And thank you so much.
So thank you, Dr. Priyadarsana, for a wonderful presentation. So I'm Kumar Purasaini from Global Cybersecurity Community Forum, and I'm a member of W3C SWAG Global Community Group as well. Basically, your presentation was wonderful, but I want to know how we can, as a W3C SWAG group, can integrate privacy by design approach. So how can we integrate it? Because security by design approach is quite common, but how privacy by design approach can be integrated to an application side?
From application point of view, you're asking?
Yes, from web application point of view. Because since we are developing a global guidelines from W3C side, so basically we always talk about different protocol engineering regarding that, but how a privacy by design approach can be applied. So can we integrate your research
that is what I have discussed in the last paper, so that is ZTA, zero trust authorization is the major key, and whoever comes and use the data should be authorized before using the data for training purpose. That is the main advantages of eliminating privacy, data breach and all.
So I think that you reduce the computational complexity by O(n) squared to O log n, isn't it? But so will that be useful for us, because you reduce the computational complexity as well? So what is your thought on this?
In terms of privacy.
In terms of privacy, yeah. Because you
yes, sir, definitely it can be used, because it is having 99.5% efficiency overall compared to other existing methods. So it can be useful, but we'll be share these over a whole paper to you if you are okay with that. We can have a separate discussion regarding that.
Okay, thank you very much.
Thank you, Dr. Priyadarshini, and thank you, Kumar sir. I think that's a good work, and we congratulate you for this good work. Thank you.
Thank you so much. Thank you, sir.
May I request paper ID 53 to present the paper. The title is Low Cost Teflon Substrate for Enhanced Performance of 60 gigahertz patch Antenna for 5G wireless applications. And I just wanted to name this John Adbisi. Am I right? And then you have U.H. Liahu N. I think yes. And then we have something called Nidhi Juluva. Yes, Tala Anwar, Anzum Afroz, Arjuna Marzuki, Ichika A, Uka A Bu. I'm very sorry for this last names. You can start presenting. And 10 minutes is your time. Thank you.
Hi, Professor. Can you see my screen?
Yes, we can hear you and see your screen also. Please go to the presentation mode. Thank you.
Okay. So thank you so much. This is Talhan. I'm from Nazarbayev University, Astana, Kazakhstan. And here is my research team members, Anama Pros, Professor Arjun, and also our professor from Professor Ikichi. So today's the main things to I came here. It's related to our research project that is based on low-cost Teflon substrate for enhanced performance of 60 gigahertz patch antenna for 5G wireless applications. The main concept of this research is to focus on compactable and affordable antennas for millimeter wave applications. Before moving to the main presentations, so I would like to describe the agendas of today's presentation. First of all, I will introduce our research, and then I will see where is the problems and why we conduct this research, and then we will see the objectives of this research, and also we will discuss about the objectives, and then we will see the related background information, and further we will go through the methodology and results analysis, and finally I will conclude my presentations. So as all of us, we know that 5G technology demands high data rates, ultra low latency, and wide bandwidths. There are many requirements. Many of researchers, they significantly use the millimeter wave application spectrums. To fulfill all of these requirements, the 60 gigahertz bands is usually because it offers a large unlicensed spectrum, and it also supports the short range 5G applications. However, antenna performance at these frequencies is highly dependent on substrate materials that is directly affect on cost and the efficiency of the antenna. Most existing 60 gigahertz antennas use expensive substrates like Rogers. No doubt they provide a better performance, but usually it's that the manufacturing is costly. Additionally, many designs and researchers, they only focus on performance, but they ignore the cost efficiency. So there is a need to design an antenna that at 60 gigahertz that should be provide a low cost, compactable, and high performance at 60 gigahertz solution. So there is a still need to improve the antennas for millimeter applications. So here is the objectives of our today's presentation. We conduct 60 gigahertz antennas on a cost effective, using a cost effective materials like Teflons instead of Rogers that is expensive one as compared to Teflon. So we analyze the single element and the array configurations as well, and during that time we get the improved gain, bandwidth, and the impedance matching at that point using the CST microwave studio source. So if we discuss about the background, if we see many of the researchers from many years, they explore the evaluation of 5G to 5G beyond networks and find the key challenges, and also say they are going through from each of them, and they work on a single band and array configurations as well during at 60 gigahertz millimeter wave applications. But they most of the times they use usually Rogers RT because it's provide a good performance, and it's provide a good performance, and they enhance the frequency of wireless communication as well. But there is some motivations that motivate us to research on this design related to 60 gigahertz microwave antenna to improve the bandwidth using the stream structure, using the different materials. So here is the methodology of our antenna. We use the CST studio source to design a single patch microchip patch antenna with the Teflon substrate with the relative permeability of 2. The thickness of the of our substrate is 0.254 millimeters. We implement a single patch and also the 4-array configuration with the quadratic wavelength impedance transformations. We provide it in a different scenarios to stabilize to provide the power H distribute equally, and also we to enhance the bandwidth and improve the radiation pattern, we put a defective slot at the ground plane. Here is the structure of our proposed antenna. For you can see at the table where the dimensions of our antennas that we use for the single microchip patch antenna and also for array as well. We provide using for the array configurations, we provide 3 different optimization feed line to exactly resonate at 60 gigahertz and improve the impedance matching and the bandwidth as well. Here is the results of our single patch microchip patch antenna. As you can see, the front view of our antenna that exactly resonate at 60 gigahertz. If you see the figure 6, that related S11 parameters that shows our bandwidth that is going from that is approximately 0.2 gigahertz with a peak gain of 6.3 dB gain, as it shows in the 3D polar. That is, it's a very directional antenna, and with the stable impedance matching at 50 ohm. Here is the result analysis of our design of 4-element antenna array configurations. That shows the reflection coefficient of approximately minus 33 dB with the bandwidth of -1 gigahertz. No doubt the bandwidth is lower as compared to single element, but it's still suitable for the 5G short link applications with the peak gain of 9.9 dB. That is improved performance as compared to a single element as well as the Roger element as well. Shows the highly directive radiation pattern. So here is the table that shows our work with some others like the single configurations arrays and others like gain. With the gain of we use the Teflon materials with a configuration of array. The gain is about 9.9, the bandwidth of 1.1, as it shows the high improvement and the gain radiation and the bandwidth as well with the low cost. That means we can use these materials as compared to Rogers that is expensive. So in conclusion, we successfully design a 60 gigahertz a low cost microchip patch antenna that is suitable, and also we define the array configurations that provide a better result as compared to single element, and it shows, and finally we achieve the high gain stable radiation pattern that is suitable for 5G millimeter wave short range applications. So here is some reference that we use for the presentations and also for the project as well. Thank you so much. If you have any questions, you can ask. That's all from my side.
So thank you, Anwar, for a wonderful presentation. My question is, you have done a wonderful research, but did it had been validated by an industry and has been initiated?
Yeah. Basically, I want to share it like most of the researchers, they use the Rogers RT588 materials. As you know, we are moving from 6G.
Yes.
And
so my question is same, yeah.
In advance, we will see problems at 5G as well. As we are from South Asia countries, we didn't have a 5G. Like we cannot say as they usually face problems like it's a cost. It's mostly not a cheaper. They use a Roger 5880 materials. But if we use the Teflon materials at industry level, then it is easily, because it provides the same advantage and the same results at provide the Rogers RT5880 material substrate material.
So has any other previous research has been done before?
Yeah,
That's one question. Another
yeah,
question
yeah.
is, so we are moving towards 6G, and will your
In
model be
so
will be useful for 6G as well?
Yeah, at 60 gigahertz previously in IEEE 17 applications of information and communication technology conference held in Baku in 2023. We present our work with the Rogers RT58880 substrate materials that provide our results, and we publish on it. But now we significantly work on our research with our different materials, and we get a higher results as compared to Rogers RT. Here I mention about the results as well.
Okay, thank you.
As you can see,
Mr. Anwar,
yeah.
you have used Teflon as one of the substrate, yes?
Yeah, Professor.
So I just wanted to know, you are the one first researcher to use this, or other researchers have also used that? If yes,
No,
then what did
actually
you...
they use, but not exactly at 60 gigahertz. Especially our team, we conduct our research on at a millimeter wave applications. But others, they use Teflon at 28 or 2.4 or 5 gigahertz.
Okay, so there's an
Yeah.
improvisation at your side.
Yeah, actually,
Okay.
many of the researchers, they use Rogers because it's provide a better results and good performance. But
Okay, so I have
here
a...
you can see our results. It's a cost effective as well. That's our theme of our research.
Okay, I have a professor from Kathmandu University. He's interested to ask you a question. Over to our
Yeah, sure.
Professor Madhav.
So, Mr. Anwar, thank you very much. Good work on patch antenna design, right? So, it's not any question, in fact, but I was just, little bit confused to see that you have only discussed about comparison with Rogers. As far as I know, because Rogers is, of course, a little bit costly substrate, but there exists
Yeah.
FR4, right? Which is the most common
Yes,
and the
of
most
course.
cheapest one. Why didn't you compare your this thing with FR4? Because that is the one that you should compare if you are trying to develop a low-cost solution. Of course, Rogers is costly, but the FR4 is there.
Yeah,
Is there any
it's a nice
limitation of
question. Like
FR4
Rogers,
for, just a minute, please.
sure.
So if there any constant, because I don't know, so if there any constant in 5G that restricts FR4 to be used there?
We can use our RF4, but not at a higher gain, but not at a higher frequencies like 60 gigahertz millimeter wave applications. If you can see many of the researchers, they cannot because it's not provide a better results. We cannot get a higher band, we cannot get a directional antenna. Usually the RF4, they substrate materials, they use at 2.4 gigahertz or maybe approximately around 28 gigahertz or maybe 5.5 gigahertz of 60 gigahertz. But researchers not use at 60 gigahertz. Mostly they use Rogers at 60 gigahertz because it's unlicensed band as well. They have a lot of problems as well.
Okay, thank you.
At 60 gigahertz, you can.
Thank you so much, Talva Anwar, and good luck ahead for your further research
Thank
journey.
you so
Now I
much.
would like to call paper ID 163. The title is Microcontroller Integrated Sensor-Based Mobility Aid for Visually Impaired People. The presenter, John Adbesi.
Yes.
Yeah,
Thank
you can start when you're ready, okay? Thank you.
Trying to share my screen. Okay, can you all see my screen?
Yeah, we can hear you. You can proceed. Thank you.
Oh, okay. I want to say good day, everyone, and thank you for this very good conference. My name is
Can you turn on
Dr.
your
John
video,
Adebisi is
please?
my name. Hello?
Can you please turn on your video?
Oh, okay. I'm using a desktop PC with an attached camera, and I've been trying to.
Yeah,
I'm trying to do that, but let me
that's
see.
fine. You can proceed.
Okay. Okay. So, can you all hear me and still see my screen? I'm sorry for that break. Okay. So I'm presenting on microcontroller integrated sensor based on mobility and aid for visually impaired people. And this is one of the work that we did together with other authors, Ilma and Leocadia. And these are the outline for this presentation. We'll look at the abstract. I'm going to introduce the work, some of the review from past related work. We'll look at the methodology, some prototype that came out of this particular design, and some conclusion and references. We have seen that in recent time, technology has really affected a whole lot of things and the way of life, and especially when it comes to application of engineering in biomedical fields, especially when it comes to visually impaired people. So this work is focused in assisting visually impaired people that have challenges with mobility, and it is designed to enhance some of the existing efforts in this area based on some improved performance and some additional integrated sensors for this work. And one of the things about this work is the possibility and support for omnidirectional movement. And according to World Health Organization, recently reported high number of individuals that are visually impaired, which is actually pointing to the fact that there is need for more creative and innovative ways to develop some solutions that could help this population to be able to solve their problem in navigation. So many countries have at least presence of visually impaired people, and that have been either by birth or either by some other incurable conditions. This work designed a sensor-based integrated solution to overcome limitations of some of the existing technologies. And this is actually an innovation in the area of assistive technology and is addressing the need of visually impaired, as I've said. Some work are actually explored, and we look at some of the previous efforts in this area. And some of them have designed visually impaired sticks using Raspberry Pi. Some have also established some framework that are still in the design phase. And while some also considered some things that are related to what we are also considering in this work. However, in most of them, there are certain features that are still lacking, and this is what this research is also addressing. The smart stick is a transformative technology that improves mobility and freedom for visually impaired people. And we have a prototype that is also just designed for the purpose of experimentation as an output of this work. It is made up of sensors that are connected to microcontrollers, and the programming base for this research uses C programming and some simulation too. As a continuation of the methodology, you see from the overall block diagram that there is also a renewable support for battery and backup power supply that can help the functionalities of this particular navigation, unlike in previous, most of the ones that have been reviewed that do not have a backup power supply. And once the power, the battery goes off, then there is no need to be able to help the visually impaired. And another thing is that this uses three sensors. There are sensors from the left, from the right, and as well as in the front with their various buzzers. And these buzzers are actually going to be the point as an indicator to wherever the problem is coming from, or maybe there is an obstacle in the path of the visually impaired. Okay, this is an excerpt of the algorithm flow of how this work is being implemented from the initial power on from the system and up onto the other subsequent flow of the system. Looking at the prototype design, this is the circuitry design for this particular work. And at the end of the day, we came up with a simple design, and this is how it looks like from the prototype that we have actually established as one of the outputs from this work. A model of a smart stick was developed and tested to evaluate the mobility performance through sensors, and we checked the feedback mechanism based on the general design. A simulation was also carried out in MATLAB, and various scenarios were also explored even physically. And indicators and alerts were actually shown in these figures, as you can see from some of the results that we have. When there is no alert at all, then we will not see any signal or any kind of progression from the results that we obtain. And that is also telling us how sensitive and how responsive this design has been. The result of this work serves as a fundamental pathway to next generation assistive technologies that will guide in secured navigation for both internal and outdoor environments. And looking at some of the past work from 3, 5, and 6, we compared some of the improvement that we have made in this work in terms of the sensors, in terms of the cost, the weights, and the distance, especially the backup power supply that is introduced to this work make it very unique. These are the references, and I want to say thank you.
Thank you so much, John. Can you please move to the first slide?
Oh, okay.
Okay, so you have been talking about microcontroller integrated sensor-based mobility aid for visually impaired people. Fine. So have you tested the model that you created? I mean, with the real people?
Say that again, sir.
My question is that what you have developed, the microcontroller integrated sensor-based mobility aid, fine.
Yes.
So have you tested this with the real people, or you just did some pilot study?
No, we just did some pilot study. It's an experimental study that is being carried out.
So there are already...
when we did this, we just put ourselves, we try to use students in the lab, and also try to put ourselves in the position of visually impaired, just to be able to see the responses and how it is performing. And it did excellently well.
Yeah, my question is, the sample that you used, okay, were they visually impaired people? Like you said, you used the lab students. So you asked them to act as a visually impaired, or they were really visually impaired?
No, they are not really visually impaired.
So how could you, generalize the model?
Anyway, one of the challenges with this nature of study is if at all we need to subject it to a visually impaired, we need to go through some permissions and try to look for, and that is one of the things that if we look at the bigger picture of this work to see that, number one, the prototype is going to be well modeled and improved on. And with that, we can approach some hospitals or some medical centers where we have people that are really visually impaired, and that could take it to a next level of trying to implement the model on a larger scale. And that's the bigger picture.
Okay. So my suggestion is, I think you're just on the very initial stage of your study, fine. There are a lot of mobility aids that have been already developed, and they're quite efficient, fine. So make a comparison, and then just compare your model with them, and work with the real world dataset people. I think this is a good work. Thank you.
Yeah. Thank you so much. Thank you.
Thank you, John, and good luck ahead.
Thank
I want
you.
to call paper ID 2. The title, Conjunctive and Agentic AI-Driven Support Ecosystem for Engineering Products, Opportunities for Autonomous Troubleshooting. Author Sri Krishna Rubulapalli. Are you there?
Yes, sir.
You can start. You can proceed when you are. Okay, please. And you have just 10 minutes time, and you need to take care of the time as well.
Sure. Okay. I hope you can see my screen and listen to me.
We can listen you.
So
Please continue.
thank you, sir. Yeah. This is my paper title, Cognitive and Agentic AI-Driven Support Ecosystem. This is the ecosystem we are proposing through this paper. This is my agenda. I will go through the background and the proposed system, the approach, and key results and conclusion. Okay. Let's look at the background, why we wanted to look at this new ecosystem. So let's look at what we have right now for the engineering products. Most of them are human-centric support. We have so many call centers and support people working throughout the clock. And they are all reactive based support. Whenever the production issue happens, they get notified and they start looking into it. So I want to help the support engineers and make their job easy so that they don't need to work around the clock, and they have the metrics available to take the decisions quickly as well. And if you look at the evolution of current engineering products, they are growing with the scale of data and the rapid rate of configuration changes and interconnectedness of the components. So with the evolution of these engineering products, it's hard for the support engineers to support it. So that's why we propose this intelligent support system, and we make use of a cognitive AI and the agentic AI. So the cognitive AI collects perceptions from the products based on the sensors, and does the contextual understanding and the pattern recognitions and reasoning. And the agentic AI helps in taking autonomous actions and plan the multi-step task for the remediation of the problems. Let's look in detail of these two systems. So our approach is primarily 5 layers. The first layer is cognitive perception layer, and it extracts the real-time telemetry, and those telemetry is used against the models to find the anomaly detections, and if there is a possibility of failure going to happen, the anomalies will be raised, and those will be then it gets into the logs and the operational data for reasoning. And the next step is multi-agent reasoning. And the multi-agent reasoning, we want to have couple of agents which work together, and based on the operational data collected by the cognitive layer, we have diagnosis agent, optimization agent, and configuration agent, risk assessment agent, and innovation agent. So these all agents work like together using the reinforcement learning based autonomous troubleshooting, and shares the knowledge across them. And the next layer is digital twin simulation. Right now we can have human in the loop to take the suggested action by the agent, and if we want to eliminate the human in the loop as well, we can go with the digital twin simulation. Like we can have a simulation of the product running in another instance, and we take actions over there and see if it's getting better, and if it's getting better, we can make the same action onto the production systems. And the autonomous optimization and innovation layer. So here the objective of all the agents working together is to minimize energy consumption and maximize reliability, reduce latency, and improve the throughput. So all these layers work in a closed loop. So it gets the feedback and gets improved over the perception, reasoning, simulation, optimization, activation, and learning from that actions, and get improved in the next scenario. So for the key results, we conducted a couple of experiments in Google Cloud by deploying multiple instances of the product and see how the agents are reacting against the existing support systems and our proposer system. So we calculated three key metrics. The one is diagnostic accuracy and anomaly detection. So with respect to anomaly detection and diagnostic accuracy, we achieved 96% compared to existing rule-based diagnostic systems, which are static rules, and that is currently yielding 84%. And troubleshooting efficiency and autonomous decision making, we looked at the time to resolution when a production issue happens. So that has been reduced by 40 to 55% compared to manual procedures. And this is the metrics we used. So we looked at the optimization outcomes against the product performance enhancement. We see improvements in the peak load stress times and the reduction in the computational overhead and reduction in the maintenance frequency. So our conclusion is this agentic AI-driven support system establishes as a foundation for the autonomous engineering product management, integrating this cognitive layer and the multi-agent system. This ecosystem can advance towards fully self-managing engineering products capable of proactive maintenance. So going forward, we'll have the products having the proactive maintenance instead of the reactive maintenance. That's the core idea behind our research work. Thank you.
Thank you, Shri Krishna ji. Could you please go to the first slide, your title?
Sure.
Okay, so you have a cognitive genetic AI-driven support ecosystem for engineering products. So you're talking about opportunities for autonomous troubleshooting. Fine. When I look at your research, you have multiple, layers of this troubleshooting. Yes.
Mm-hmm.
Yeah. So have you done? Have you done an integrated testing of all the layers combined together?
Yes, sir. We'll have to do all the layers together. The first layer is collecting the telemetry data. So without telemetry data, we cannot make the agents make a decision about what's the problem scenario and all. So we made all the layers working together and collected the key results.
And how did you validate your model? Like, what was the base for you to validate your model?
Okay, right now in our organization, we have existing models which are rule-based, and we compared our model against the existing rule-based models and simulated the scenarios like shortage in the compute storage and decreasing the CPU resources. So we simulated the scenarios like that and checked against the anomaly detection whether the red flags are raised by the model or not, and if it is raised, how the model is trying to fix that problem.
So by this, I could understand that you did it with your own development team, yes? Like what was done in your university or maybe your, Boredom, Texas. So you're from the company side and also
Correct.
Professor G. Sao. I just wanted to ask you that did you compare it at the global level also? Did you some literature where these kind of, troubleshooting using cognitive and genetic AI systems are existing, and have you compared at that level also or no?
No, sir, we haven't gone up to that level. And those are not available for the engineering products. They might be available for other domains. And the main challenge I have noticed is for the software developers, we have the coding assistants. In the similar way, for the support engineers, we wanted to develop some agentic solution which can make their life easy. That's the goal.
Okay. So what will be your extension further?
In the extension, we want to apply this mechanism to multiple products in our organization and see and see the results. And based on that, we want to take low stake products as a initial adoption and try to see how it operates in the real time production systems at customer environments.
Yes, so I found it very interesting. So that's why I asked you a little more questions, okay?
Yeah,
I wish
no
you good
worries.
luck. I think if this can be converted to a real working prototype. We have one professor, Professor Madhav from Kathmandu University. He's also very interested to ask you.
Sure.
So thank you for your presentation. It seems that you have proposed, architecture, and my query is like, you have tested and your results are reported for a particular type of scenario, right? In engineering, there are various type of products, and you have a wide range of troubleshooting situations. So I think before generalizing your results for accuracy of sensing, you should test it for a more variety of situations, because the type of sensing things that is too diverse. So that's my suggestion, that before concluding about the sensing accuracy and this, you need to do this for a larger variety of situations or scenarios. The second is you have presented the result for sensing accuracy and response time. So where you have said that your ecosystem or your architecture performs better than the rule-based systems. However, you have stated, but you have not presented the results of accuracy for troubleshooting, because I think that is the most important parameter here, because the 24 support system is so that troubleshooting can be done in a good way. So response time only is not, I think, enough, and you need to have a very high level of accuracy of troubleshooting. But you have not presented the results of accuracy of troubleshooting, only of the accuracy of sensing and the response time. Yeah.
Yeah. Thank you, sir, for the feedback. Yeah, we'll definitely incorporate it in our future studies. Thank you.
Yep.
Thank you, professors. And I wish you best wishes, Sri Krishna. Now I would like to call another paper ID. That will be our last presentation for today. Paper ID 27. The title goes like this: Performance Analysis of 3D FCC MDW Codes for Cardinality Enrichment in OCDMA Systems. Authors AJ Rupak and team. Are you there? Yeah. You can proceed.
Yes, doctor.
Yeah.
Can you hear me?
Yeah, we can hear you. You can start when you are okay. Please go ahead.
Okay. Okay, thank you. Good afternoon, respected chair and the participants. First of all, thank you for this opportunity to present our paper. So my name is Abu Jubair Rupok from University Malaysia Perlis. So our title is the performance analysis of 3D FCC MDW code for cardinality enrichment in 3D OCDMA system. This work actually focus on to improve the user in number of users and maintain the good performance. So in the optical code division actually is a multiple access technique that offer the asynchronous transmission, and it's shared the spectrum the uses. So in OCDMA there is the issue is we can see the phases. So first one is the multiple access interference, that which can happen when the signal between of the users and collide, and the other the issue is the phase induced intensity noise. It create when the overlapping the phases and create the intensity, the fluctuations. So in OCDMA, we can see in top actually the OCDMA promises. We see that the secure, asynchronous, and flexible bandwidth. But when the number of users increases, then we see the reality that the performance hit the wall. And then we found the issuance is multiple access interference and the phase induced intensity noise. So the evolution of the OCDMA code is the first one is the one-dimensional code that previously already developed. It means that using the one domain to using the users, and the benefit is in 1D is just zero cross correlation. But when the user increase, then there is the issuance of the collusion, the issuance of the interference, that is overlap. So the researchers go through the 2D. The 2D means that using the two domain, that is spectral, spatial, or the spectral temporal. So it can better efficiency by compared to the one dimensional. But when the same thing, when the user that increases, there is issues of the interference, and issuance of the complex and the hardware complexity. So now we arrive to innovative the third dimensional by using the space. So our breakthrough is to using the three domain. So first domain is the wavelength by using flexible cross correlation. This adjustable the wavelength codes for the lower interference. The second domain using the MDW codes, that using the modified double weight, that it control actually the pulse distribution, and it can prevent the temporal the collisions. The third one that we propose, that is space or spatial orthogonality, that it physically separation. So the question is why in wavelength domain, why are you using actually the FCC? Because the FCC adjustable for the cross correlation. That means if the lower cross correlation define that there is the better user separation and the lower interference. So that's the main that we follow up. And in time domain, we using MDW because the MDW by using the MDW, it's flexible from the time separating, and it's crucial for the preventing the temporal collision between the asynchronous user. So our solution by propose this, there is the three independent axes, the three dimensions. So first one is the dimension 1, the wavelength, dimension 2, the time, and dimension 3, the space. So inside of these, the dots actually define the unique user code by combining these three of domains. If we combine this one, then the unique user code can there is no overlap to one of these, so there is separated, and that we call the when we using these three axes by combine, then we show the cardinality enrichment, that we call, that means the user enrichment. So now I go through our transmitter methodology for the transmitter architecture. So how it's work actually step by step. So first one, we show the laser sources to generate the optical links. Then the optical links go through the modulation by using the on-off keying with the MZM. Then it go now the wave spectral encoding. The encoding have been started in here by using a spectral encoding using FBGs. After spectral encoding, it go for the temporal separating. That means to apply the time delay units. So after the temporal but time delay units is go, now we go for the spatial mapping. In spatial mapping, it can assign the signals from the different users. So this is can separate it was actually separated from the users, and then after that all the signals combining by using the optical multiplexer, and it go by the optical link, transmit by the optical link. So in the transmitter, it encoded by using wavelength, time, and the space. In receiver architecture, we see that in optical, by transmitting the optical signal, first is incoming, the incoming signal is split spatially, so each user branches is separated, and each user branches pass through the inverse time delay unit. That means it can do like a reverse in the transmitter to recover our data. So so second is go the inverse time delay units to remove the time domains. Then it go by the wavelength filtering. The wavelength filtering, it can catches only the wavelength, our wavelength patterns, and it remove, and it also with the wavelength filtering also remove the the unwanted signals and the noises. So after that, the process, it go for the detection by using the photodiodes, and it converts the optical signal into the electrical signal, and then it go for the low pass filter to recover our data. So after that, we can recover the data by using the three domains: wavelength, time, and the space. So we evaluated by analyzing the performance, and evaluated by the performance, we using the signal to noise ratio that is defined the total current divided by total noise power by using the three noises: short, thermal, and the phase induced intensity noise. So after that, we using these parameters by comparing with our proposed code to the different the others existing codes that we use. So in the first, we found the result, the BER versus the number of users. So this one is actually for our proposed code, and the others is the existing codes to comparison that actually what is work which one is actually work by comparing in BER versus the users. So in comparison, we see that our proposed code support the 200 users at the BER when its error-free threshold, the 10 to the power minus 9. It can support the higher users, and the others is the by comparison is the lower. So in comparative, the improvement can show by comparison with the 3D multi-diagonal code. The capacity will increase the 1 to 2%. But in comparison, the 3D DCS MD, we found that plus 61% improvement in our proposed code. And comparison by the two-dimensional code, we can found the 769% the capacity increases. And the second one that we analyze is the receiver sensitivity by comparing our proposed code to the others code. Then we found that our code achieved the lower receiver sensitivity, which is the minus 22 dBm, and the 3D multi-diagonal code is achieved the minus 19.5. That means there is the improvement is 2.5 improvement in our proposed code. By comparison others, then it's actually to show the improvement and the good performance or the lower receiver sensitivity in our proposed code. And the third one is using the bit error versus the number of users by comparison the different type of weights. The weights actually define how many number of one is present in the three domains. So by after this, we seen the result that when the weight is the balance is 322, then it support the more users. So the question is why the 322 is supports by comparison others to higher users. Because there you using because it's the wavelength. If we increase the wavelength, the weight, it can improve the separating the wavelengths. It can use better. And if I reduce the weight in time and the space, it so there is the reduce of noise. So there is a reduce of the pollution and the interference. That's why if I when I balance the 3 to 2, this one, so it support the 170. But when I increase the time and the space domain, the weights, then it supports the lower users. So our conclusion is first in the support the 200 users at 10 to the minus 9 to say 769 improvement our 2D codes. The second one is the superior sensitivity minus 22 dBm, and our robust is the multi-domain orthogonality by using wavelength, time, and the space. So effectively supersedes the multiple access interference and phase-induced intensity noise. So this one is actually the reference I uses, and thank you so much for your attentions.
Thank you, Mr. Jubair. Your presentation was very nice, and we already know that OCDMA has a very good promise, but the strongest limitation is multiple access interference, as you already said. So
Yes,
if your codes are improving that, that's a very good sign. However, OCDMA has other limitations also, right? For example, the limitation in spectral efficiencies are there. So does this help into reduce those limitations? And secondly, have you ever tried your simulation in a free space optical scenario?
Thank you, Professor. In first question, actually in this paper, I actually seeing the performance analysis only the three of this, and by using spatial separation, we actually complete the in this ongoing the comparisons or the performance analysis. So we'll go through inshallah. And the second one, actually, I have not go through the FSO by comparison in our 3D because it's a new one of my study, the 3D FCC MDW. So I just completing only the performance analysis first, and then I complete the simulation that okay, it's working good or not by using the simulation to integrate the equipments, but not go through the others. So it's actually our future work is to complete the full by using higher bit rate for the analysis. Then I go through to comparison the with the FSO actually.
Good. So I think if you can, study those two things, that would be very nice, right? Because
Yeah,
those are
sure,
the
sure, sure.
second and third most important limitations in OCDMA after multiple access interference. So best of luck for your future works. Thank
Yeah,
you.
sure, sure, Prof. Thank you, and I will follow up obviously that one. Thank you so much.
Thank you. One of the presenter, we missed him. We would like to invite him. And this is the last paper of the session. Paper ID 158. Are you there? Paper number 158.
Yes, yes.
Okay.
I'm there, sir.
Okay. So the title is Dandelion Optimized Residual Attention CNN for Identification of Attacks and Security Issues in VANETs. And it's by Raghunath Kawale, Ritesh Patil, Lalit Patil, and Surendra Mahajan. So you can start your presentation. Thank you.
Hello. Good evening, sir. Hello. Am I audible, sir?
Yeah, please go ahead.
And whether my screen is visible, sir?
Yeah, you are audible, you are visible. I just request you to start the presentation in the presentation mode.
Okay, sir.
Thank you.
Okay, sir. Okay, sir. Just a minute, sir. As you have told me, I want to say very thank to team ICT 2016 for giving me opportunity to present my paper. My paper is basically it's a just a minute, sir. Just a minute.
Yeah, it's okay. Don't worry. Take your time, please.
Okay, sir. Okay. So my today's presentation title is Dandelion Optimized Residual Attention CNN for Identification of Attack and Security Issues in VANET. I am the Raghunath Kawale along with my co-author Dr. R.V. Patil sir, Dr. L.V. Patil sir, S.A. Mahajan sir. We are from Pune, Maharashtra, India. This is my agenda. Introduction, literature survey, problem statement, proposed methodology, result discussion, conclusion, and references. As my presentation is basically start in the area of VANET. Basically, VANET is a mobile ad hoc network, and basically in a VANET, the topology poses challenges to the system security. So the system security and protection of the public competence is directly related to the crucial and in the growing adaptation of the ITS, where the security is a very sensitive issue. So we are still dealing with which includes the problem of authentication, privacy, trust, and also network ability to function the presence of many types of attack. So that's why the study and identification of VANET and security issue needs to be understand. That is why I'm presenting this particularly. So these attacks may most probably targeting in the network layer, routing layer, application layer, and privacy related threats. Basically, in this VANET is a very vulnerable to the wide particular spectrum of security attacks, compromise the availability, authentication, confidentiality, privacy, non-repetition, and data trust. Along with that, many more attacks can maybe includes here the particularly replay attack, Sybil attack, man-in-the-middle attack, GPS spoofing attack. So based on that, I'm trying to propose a particularly new approach, that is DSDP RACNN, that is dual sampling dilated pre-activation residual attention convolution neural network, that that can configure the pre-gained, particularly as well as the wide contextual pattern in the VANET intrusion data. Basically, it improves the pre-processing via FMMN, that is fuzzy minimum maximum neural network, to effectively handle the uncertainties and overlapping the data, leading to the cleaner input. To conserve the most valuable characteristic of walk spread algorithm balances the exploration and exploitation in order to select the best features. Employ the multi-dilated convolution to learn short and long range dependencies simultaneously, allowing the detection of diverse and sophisticated attack types. Then tunes model weight through the nature-based Dandelion optimizer to acquire the convergence at a faster pace and greater detection accuracy. Sir, am I audible? Hello? Hello, sir. Am I audible? Hello, sir.
Please continue. Don't worry. Please, please. It's your time to speak, so that's why we're not speaking.
I have did the literature survey, and that literature survey shows that there is a necessary to use the some Dandelion optimizer algorithm. That's why I have proposed a methodology. That methodology suggests that here in this methodology, I have given the particularly Vermi dataset, and through that dataset, I have given the input to the DSDP RACNN, which did the attack detection. So initially here, the pre-processing is done with the help of fuzzy minimum maximum neural network. Then feature selection can be done with the help of, or is done with the help of walk spread algorithm, and then attack detection done. And basically attack detection done with the help of optimizer technique, that is Dandelion optimizer. So this is my proposed architecture, and in that proposed architecture, I have implemented that. Here, these things already I have told, so I will not waste time. Then in this proposed methodology, I have collected the data from the Vermi extension dataset from the Kaggle. It includes the 18 classes such as normal behavior along with the different 17 attacks. Out of these, 18 fault types of corresponding to the position and speed spoofing were taken into the account. After that data collection, the pre-processing using FMMN is done. Then, based on this collected data, here the particularly further analysis is done. Like a training set is represented by order pair B, comma J. Here B is equal to all the feature input vector of attack data. Then J denotes the class index. A hyperbox is defined its minimum point of vector, that is W of minimum K, which includes minimum 1 that is up to minimum Mn. W of M minimum N represents the lower bound of kth hyperbox in the each feature's dimension, and its maximum point vector is represented by x max 1 that is up to x max M, representing the upper bound of that particularly hyperbox. Then this hyperbox were given to the membership function G of B, comma W minimum K, comma W max K. Evaluate the degree of fitness between input pattern P and the hyperbox boundary, producing the values in the range of 0 and 1, where 1 indicates the full inclusion. The parameter alpha is the sensitivity parameter, control how rapidly the membership value decreases with the increasing distance between P and hyperbox boundaries are represented. Then the parameter N represent the dimensionality of the input feature vector. Mathematically, fuzzy set is expressed as like a IK is equal to in bracket B, comma W of minimum K, comma X minimum K into G of B, comma WK minimum, that is here. And the function describing the membership as explained in the equation number 2, that is IK is equal to 1 upon 2m summation of that is starting j is equal to 1 to m with this equality. Here bj represent the jth feature value of the input vector, w minimum k and x maximum j denotes the lower and upper limits of hyperbox with the jth dimension. Then the feature selection using WSA is calculated. It is used to select the most informative feature from the preprocessed data. Yes, sir.
You need to take care of the time.
Yes. Okay, sir. Okay, sir.
Thank
okay.
you.
Then after the feature selection, particularly these equations were evaluated. Then attack detection using DSDP RACNN is calculated, and then this attack detection can be passed to the following main components, that is multi-dilated convolution. Then in that it is providing the particularly identifying the space varying magnetic attack. Then the pre-activation residual convolution, that is spark, is calculated. Through that we are getting the prior residual summation of to improve the refinement of the feature map. Then we have did the particularly dual sampling attention network by using DSA. Then optimizer using Dandelion optimizer can be is performed. Here it includes the 4 steps like initialization. In that initialization we have did the initialization of the things. Then after that fitness evaluation is calculated. Then rising stage is calculated. Then descending state, landing stage, and termination stage is done. So here as I have stated that data, we have a different 18 set of classes of data, out of which 17 are categories of attack. Through that we have analyzed the model. Basically that model is compared with the random forest. Then it is checked with the SA by LSTM, CNN LSTM for detecting the attacks, and the major performance metrics like accuracy, precision, recall, all the values are calculated, and through that the particular results are shown over here. So this result shows in the A diagram shows the accuracy, in the B diagram it shows the loss curve of these two. On a y-axis accuracy is shown, and on x-axis epochs are shown of both the diagrams. And in the next diagram, the performance metrics are calculated with the help of recall, accuracy, recall, specificity, precision, and sensitivity. Then this result discussion, basically at the last, this table summarizes the comparison of different models in a VANET for the attack detection. So the proposed model that provides us 99.2 accuracy, 99.0 precision, sensitivity is 98.8, specificity is 99.5, and F score is around 98.9. So finally, I would like to conclude that the presented DSDP RACNN with the Dandelion optimization model achieved a best performance in the attack detection over VANET. The excellent feature set, strong processes, hybrid deep learning architecture, and the Dandelion optimizer lead to the good performance of our model. The related metrics of F1 score is around 98.9. The sensitivity is already I have mentioned. When Dandelion optimizer was incorporated, and the convergence rate and detection were greatly enforced. So we will say that like it's a good method for doing that. Then I have referred, these are the references. Thank you. Questions and suggestions, sir. Over to you, sir.
Thank you, Raghunath.
Over to you, sir.
Yes, we are here. So thank you, Raghunathji, for your very nice work. It's VANET is I think something network of future. So it will it will be in practice very soon, I think. And attack detection is also a critical issue. It is very obvious that if nowadays the common mechanisms to detect attack are anomaly based, right?
Yes.
Proposed neural network based method. Compared to the anomaly based method, your mechanism or neural network mechanism will need a very large number of computations. So that will cause significant delay in response or significant delay in identifying the attack. So isn't that a crucial thing? Have you compared the parameter of the response time compared to an anomaly-based mechanism and neural network-based mechanism?
No, sir, I have not compared it.
Okay, so I think that's also should be a crucial issue before you, recommend this method for attack detection, because the accuracy is very nice. But if it takes a lot of time to detect, particularly for a mobile network like VANETs, I think it should be very concerned that the response time is a big issue. Okay, so I
Yes, sure,
request you
sure.
to
I
check that
will
also.
take a sure care of that things. Whatever the suggestion you have provided, I will take care in my further research.
Yep, that's it.
Raghunathji, I also have the same kind of feeling like your accuracy is very, very high. Yes, almost like, can you go to that accuracy slide?
Just a minute. I will close the slide.
Last slides where you're talking about the results and accuracy. One graph that you showed to us. Yeah, this one, okay. No, next one, please. Yes, sensitivity analysis, almost like 100%, fine. Like what was the size of a data set? I can see 18 classes, 17 parameters, but then how many data sets?
So at the initial level, I have taken the data size was too small, sir.
Okay, and later? Or you just work with a very small data set?
Later on, just I am doing the further study on that, sir.
And do you think Kaggle data set is good enough for your study?
At the initial level, I think as a student, as a research student, I feel that it is good. Later on, I'm just collecting the data set, and through that, I'm trying to do the further evaluations.
See, Kaggle data set is an open data set, yeah? How
Yeah,
do you
yes, sir,
validate
yes, sir.
your data is authentic? That's the biggest question. Why I'm asking you this is because I think, are you a PhD student?
Yeah, research scholar student.
So that's PhD, if I understand that.
Yeah, yes.
So that's what my suggestion is. I think your results, like if we see the results, I think you are done with your study. Yeah?
No,
So
sir,
what
sir.
next?
This is basically means at the initial level, I'm doing the study. This is related to the deciding the factors.
So you're
Now
just
I'm
talking
my
about the
study is going
piloting and
on,
just
sir.
choosing, yeah? So must be on the information gain, what you want to include. But I think Kaggle is not a good data set. So I'll request you to
Okay, sir.
take
Okay, sir.
some validated data set. Maybe you can go to the government agencies and ask for it. Fine, one.
Okay, sir.
Then data sets should be comprehensive. Okay.
Okay, sir. Okay, sir.
And also it will matter what is your training data set and then what is your testing data set. Fine.
Okay, sir.
And then when you do the split, there's one more thing I would like to request, negative bias. Okay, put that also, just to get more
Yes, sir.
accuracy. Fine. And
Okay,
just see that
okay.
your data doesn't looks formatted or featured, so that, or if you do that, then definitely you'll have a very high accuracy.
Okay, sir. Okay, sir.
Okay. So thank you from my
Okay,
side.
sir.
Thank you.
Okay, sir.
Yeah,
Okay, sir.
there's one madam. She wants to ask you.
Okay, sir. Okay, ma'am. Okay, ma'am. Please go ahead.
Raghunath sir, myself
Yes, sir.
Deepmala. I actually belong to management faculty, but yet from your presentation I could categorize something, summarize something. So I would like to ask from the management perspective, how feasible you feel from your topic is to implement this in Nepal's emerging, the smart transportation system. As you already mentioned, there are 18 classes, normal 17 categories, various categories you go with, and the normal traffic system. So based on that, could you please tell me how feasible it is to implement this in Nepalese emerging smart transportation system, if I could make sense. Thank you.
Ma'am, particularly early in the particularly providing the solution to the one of the most important country, just like a Nepal. But surely, as and when I will come with the solution, I will definitely provide you the map.
no, what I thought was when you were writing a paper, you must have gone through various literature.
No,
If not, you are encouraged to
as
write
sir
a
has
paper
suggested
on.
me, I have collected everything from the one of the online data, so that is Kaggle, and based on that Kaggle data set, I have provided the outputs. So it's very early stage to provide some solution to the like country like Nepal. So I will, as and when I will do the particular research, then I will definitely try to help you, ma'am.
Thank you so much. Any question?
Okay, so we are over with the technical session. Thank you, all the presenters from abroad. You all have done a fantastic work. I congratulate you for presenting your work and sharing your knowledge with us. Wish you all the best for your future work. And with this, we come to the end of this session. Now I would like to hand over the mic to the secretary of the conference, Engineer Birod Rijal.
Thank you so much, Dr. Dipanjal sir. Now we are at the end of the session, and I would like to ask our conference co-chair, Engineer Ganga Subba, to hand over token of love to the session chair, Dr. Dipanjal Shrestha. Please. Yeah. No, you look at this side. Yeah. Similarly, I would like to call upon the session co-chair, Engineer Navin Limsani sir, to take the token of love. Thank you so much, conference co-chair, Engineer Ganga Subba ma'am. And now I think the session is over. Thank you everyone joining online and offline. Thank you.
Okay,